Can you stop there for a minute?
I'll stop.
Just watch your tether. Okay, get back on it.
Understood. Coming down.
As we're getting closer to the bottom here, Ashton, I see there's a pretty heavy sediment layer. Rock outcrop.
Yeah, and so that's, that was one of the things that we was really kind of curious in terms of picking this site. How heavily sedimented would this area be? Are we going to see this for the next 4 hours?
Right.
It's hard to tell. We had the ability to look at that, the hardness of the acoustic return. And that was that backscattered image we were showing earlier, and it was kind of modeled, so it kind of looked like some sediment mixed in with hard rock.
And as we look at the navigator screen, Navigator's got this high-pack screen, it's got the bathymetry in plain view. The contours are pretty widely spaced, so we're landing on the flattest part that we'll see today, I believe.
Yeah.
We'll go up slope, so hopefully this will change some. I'm already seeing some sea cucumbers, though, but go ahead.
Oh, I was going to say, a sea cucumber and some bioturbation trails, and look, maybe also looks like some mounds.
I can't quite tell, but I see what you mean. I'm not sure if those are ripple mounds or biogenic mounds. Yeah. But directly below, I did see what appeared to be a feeding trace of a spoonworm, a neck urine worm. That's kind of star-like pattern to in the sediments. Star-like feeding pattern. Sorry, go ahead.
Oh no. So this brings us to a conversation we were having yesterday about infauna versus epifauna. And could you explain the difference?
Let me just take a note of this jelly that's coming through here. Another tool that we have on board and that our scientists on shore can use is C-Tube, which is in Ocean Networks Canada. The software is being hosted by Ocean Networks Canada, and it allows us to make logs of all the observations we're making.
Pilot, you good if I deploy?
This is ROV Navigator.
Go ahead, Nav.
I was wondering if you would like to take a Niskin at the bottom, if you were planning on it.
Absolutely. Once you guys are set, that's the first thing we'd like to do.
Copy that.
Thank you.
Pilots, it sounds like we are going to dig a Niskin sample once we get to the bottom.
You want the jellyfish while we're here?
Thank you, Lars.
Yep.
Science would.
Take a video. You can see it. Yeah, just while it's here. My co-pilot's getting my lights ready here. Figured I'd get a zoom for us.
And I want to say coronate jellyfish. I don't think that's quite right. But it reminds me a little bit of Periphylla.
Your lowers all the way down. You happy with that? Three-quarter?
Yeah, that's good.
Right. What is that? Is that a coral?
That very well could be a coral or a sponge. I'm thinking it's a sponge. That might be a chondrocladia sponge, which would be really cool. If it is a chondrocladia sponge, that's one of the carnivorous sponges.
Okay, and watch it, just to be clear, we just finished our setup and we're ready to start the dive.
All right, awesome. Can we get a zoom in on that branching structure in front of you?
Absolutely. I'd like to inform you that we are on the bottom at this time. I would also like to verify that the center rotation is about the A-frame, and when you have an opportunity, if we could discuss a brief bailout plan, that'd be great.
And pilot, I apologize, I was distracted here. Did we trip the Niskin, or are you just prepared to trip the Niskin?
Getting ready to take it now. Just wanted to make sure everybody was ready to go.
We're standing by. We can take it right now if you'd like.
Good copy. Thank you.
When you're ready, I just wanted to be sure about the logging. Thank you.
Okay. Co-pilot, you want to fire it?
Yep. Niskin
video, you want the jellyfish? I'll get the coral after the jellyfish.
Niskin firing.
Good call on that coral, Aston.
1. Niskin fired.
Beautiful image of a jellyfish here. I love the coloration. There's a lot of these deep-sea taxa that have red associated with them. These lines that you see, the globular thing in the middle is the main part of the mouth and the stomach, and then the lines that radiate from that are called lateral radial canals, and they go to a ring canal at the edge. Those are extensions of the stomach. And by having that red pigment, light won't be able to move through it. So if that jellyfish ingests any bioluminescent organisms, then itself won't light up because of what is ingested, so it's protected from a predator. This looks like an old bamboo coral growing on these rocks.
Yeah, I wonder if you think it grew there, or maybe, I mean, this looks like a talus pile, so I guess it could have also...
Yeah, but if this tumbled down the slope, I wouldn't expect the skeleton to be in as good a condition as it is. So I do think it grew here. I'm not sure why it's now dead. Yep, that looks like possibly a brachiopod over there on the left, and there's also some kind of burrow there. Yeah. There's a variety of crustaceans that look great worms.
Zoom in,
yeah, so we're looking at the polyps here, and these are octocoral polyps, but I don't believe these are the polyps of the coral that created the skeleton. I think this is something that is settled on the skeleton and grows as one of those stoloniferous mats.
Just as
That's my impression.
How's your compass feel?
We have a move if you're ready.
Yeah, it's pretty good.
Range,
it's
5
good shots
meters.
I could be wrong, but
5, 3, speed, 0.
The skeleton is so worn away. Actually, yeah, you can see where the tissue ends there as you look to the left. And the skeleton is so worn away, it actually looks more like a protein-based skeleton than a calcium carbonate. Yeah. But it's hard to tell because I see some white bits underneath there too. So it's been dead for so long. Deposition, incrustation, other organisms. You can see there's hydroids, forams. There's all kinds of little stuff here.
And you can see the weathering through the translucent membrane of the octocoral.
Yeah, that's a really good observation. So that suggests that this octocoral has grown over it after it died. Yeah. So that's, I think, what we'd call a stoloniferous octocoral overgrowing, probably a bamboo coral. But it's a good sign that this stuff can live down here. Yeah, that thing that looks like a wide open mouth is either a brachiopod or I'm not sure. So I'll have to go with brachiopod. I just have to make a note here, so I will leave it to you. Oh, I've already done that.
You come in, zoom in on that.
And ROV, just to confirm, we have a move with the ship that you guys already put through, I think I heard?
Yeah.
All right, perfect. So, I think the important thing to me is kind of just to try and keep ourselves on pace for moving up and hitting the top of that slope. Should be about 500 meters over ground, and I'd like to make sure we get that exposure. So,
understood.
If we get too slow, let us know.
So this is not a brachiopod. This is a tunicate, actually. You can see at the top back there, there's this little chimney-like opening, and then it's got this wide opening here. And I'm trying to remember the name of this thing, but I believe this is a predatory tunicate. So tunicates, we've seen several throughout the dive, mostly the pelagic ones like salps. But tunicates are filter feeders. They belong to the phylum Chordata. I've said a few times it's an invertebrate that's closely related to vertebrates. They're filter feeders. They have a very elaborate filter inside, cilia that draw a current in. Well, this is one that has adapted, much like the carnivorous sponge, instead to be a carnivore. So that is essentially a large mouth. And when a zooplankton swims in there, it'll close up, and then it can feed on it.
I mean, quickly, like
I don't know how quickly it happens. I've seen a video on one of these, like Discovery shows where they have great audio and it makes it sound like clump, but I don't know if they sped it up.
It reminds me of like a Venus flytrap of the deep ocean.
Exactly. That's exactly what it is. And yet it's retained that opening at the back. That would be an X-current opening if it was a suspension feeder. So again, adaptation, evolutionary changes. You deal with what you have and you modify that. You don't just de novo create.
So is there a do you expect a valve in that back little port?
It's not a valve, but
is there an
at
escape
least
hatch?
So the way they work for the others is that you would have to pass through the filters in order to get to that other opening.
Yeah.
So this is a holothurian, a sea cucumber that is lifted off the bottom and is drifting a little bit. See, it's quite transparent. It's an echinoderm, and this is a deposit feeder. And if we see a lot of the sediment, nice fecal pile back there, highly coiled, it tells me that there's probably an acorn worm or something. I suppose a holothurian may have done that. At any rate, I'm already seeing a bunch of things that are telling me that there are several organisms that are using the sediments down here.
Okay.
So there's plenty of organics. I see a sponge on the rock in the upper right.
Eyes on.
Was it fired now? Was that fired now? Niskin 2?
Yeah, we've taken Niskin 2.
Sorry, I need to know when it fires so I can hit the collect button.
Got it.
Good copy. Thank you.
I can't change the time. That's why I like to do it as close as possible.
And so we've got about a 30-meter overground, no, 30-meter vertical, maybe about 100-meter overground ascent. And then we'll get up to the top of a small little hill, which will then be the beginning of our larger ascent up the main slope of this larger feature. So we'll probably get to the top, and then we'll have a little bit of maybe a short transect through some water column until we hit that slope, kind of like yesterday. And so this was just kind of, we could have started on that lower slope, but the goal of starting down here is it was really interesting to see how sedimented it is. And this is our kind of one opportunity to get into this kind of deep basin area.
Coming down, just so you know.
Understood. Following you down.
Just waiting for the tether.
Yep.
Now, what's our average speed necessary to make it to where geology wants to make it?
Stand by one.
I don't know if I've moved at all so far.
Copy. Yeah. Yeah, the deeper the dive, the longer the ship move delays are.
Yeah.
So let's just get a quick view of this sea cucumber. The sea cucumbers are pretty well known because they live on soft sediments. They're much more easily trawled from the deep sea. So we have lots of examples of them. Doesn't necessarily mean we have the good in situ imagery, but the things that are growing on a hard substrate are harder to sample in good condition, and so getting good images of those is a...
I've seen these on... Just from my own experience, I've seen these on flat ground. I don't think I've ever seen one kind of just heading up a steep sediment slope like this. It's interesting to me.
You can see that this one is very different from the one that we just imaged swimming through the water column. That one had modified podia on the dorsal surface that was kind of like a large fin that helped it swim, whereas this one's much flatter. Still transparent. You can still see through the body wall that coiled intestine full of sediments. Again, these guys are deposit feeders. Deposit feeder means that it's an organism that will ingest chunks of sediment and pass all of that sediment through the gut and digest whatever organics it can get out of there. And organisms like that they're similar to ruminants in that they have a very long intestine because you have to process that food or that minimal food and all that sediment over a very long period of time.
And for us lay people, again, a ruminant is
like a cow and a sheep, right? Exactly. And so being able to digest all of that grass takes a long time, and so there's a long residence time in the gut. And you had said it earlier in one of our previous dives that there's a different sea cucumber, this purple one up there.
I'm going for the vertical branch right here.
Thank you. Yeah, I think it's a worm actually. I think it's a tube worm. We'll check it out, and I'm not sure who's.
I'm going for
right
cool. Here. I'm going for this right here.
Oh, you saw a coral that I didn't. Thank you, pilot.
Yeah. Let's start with the coral. Come in, video.
Anyway, I was going to talk about reworking the sediment. We can talk about that later. Yeah, this looks like a bamboo coral, I believe.
Oh, there's one of those brittle ones back there too.
Yep, that's a bryozoan, the fan that you see in the rock behind there, and we were able to get a great collection of a bryozoan yesterday.
Want to take the polyps?
Yes, please.
Video. Okay.
Yeah, absolutely. Bamboo coral, I can see a couple of the dark nodes in the skeleton there, those polyps. So bamboo corals are one of the corals that I would fully expect to see at this 3,000 meter depth. There isn't a huge diversity that we know about, only 3 or 4 species. There may be more, but that's what we know.
And what's the deepest that you are aware of them being found at?
I think it's 4,200 meters for a bamboo coral.
And that was in the Pacific or the Atlantic? Or
that was in the Pacific. Yep.
We have a move if you're ready.
If you're clear video, we can move on to the other
subject. Range 10 meters, bearing 265 degrees, speed
no.
0 decimal
come wide,
3
and
knots.
there's a tube worm thing.
I saw that worm from a distance. It's a fan worm, so we can move on from there.
There's a little star on the left too.
Good copy, Bridge.
That's a brittle star.
Yeah.
I would suspect Ophiumuseum. It's a pretty common brittle star on the abyssal seafloor and the bathyal seafloor. And you'll notice it's a slightly different morphology and not the kind that we keep seeing associated on the corals. Yeah, so this is a fan worm that is built a tube probably of mud and mucus, and it's extending anterior structures in order to suspension feed. That's good for us. Thank you.
Understood. Do you want the star, the brittle star? Okay.
I don't think we need that brittle star.
Okay.
Really common down here.
Understood.
Thank you.
I want to maximize our time here.
Yeah, and it looks like what we're just looking at is a slope field of talus that's come down kind of this larger, steeper slope that we're heading up to. And it's kind of interesting. We're in this fracture zone between these two segments of the Mid-Atlantic Ridge. The fracture zone is about 20 kilometers wide, so it's on the lower end of fracture zones that we observe. We're in this active portion of it, so where volcanic and tectonic activities are taking place. And what's interesting to me is all this talus looks like it's come from kind of our west on this little, several 100-meter bathymetric high that we're starting to come up, and not from the northern section where we're on the older plate on those ridges that we were on earlier.
Kind of waiting for tether here, so I just want to see what's going on.
Oh, great. Yeah, so if we have the time, I'm happy to have a look here. So let's see. We've got another bamboo coral. One of the ones that we've known for a long time is the deepest is the genus Bathygorgia. And I was noting yesterday that there are a lot of taxa that get a name bathy appended to it, which refers to the fact that it grows very deep. And Bathygorgia also grows as an unbranched whip, very straight. So it's quite possible that this was Bathygorgia, although I need to hear from my colleague Les. I'm not sure that it's known from the Atlantic. It was originally described from the South Pacific.
Go ahead,
Nice
Rich.
view. Most of the polyps seem to be on
Thank
one
you.
side of that axis. They're not highly dense. Yesterday we were seeing some where the polyps are really dense in there, and you can see the tissue is transparent, very thin central white axis made of calcium carbonate. And then you can see some of the sclerites in the tissue. That some of them look really quite small. And then I noticed just off to the right on the side of a rock, there's a large anemone. You can just see its tentacles sort of peeking out.
Video come out. I'm going to go for the large anemone. Got just a
There
little
it is.
bit of tether. I'll try to get you a better view, Scott.
Thank you. All these sort of bluish circles that you see on the face of the rock, those are sponges, encrusting sponges. Sako Matsumoto is joining us from Japan, and she noticed, as I did, just off to the left also, I think we saw a brachiopod. And that reminds me, I need to dig up the name of that tunicate.
And so, just to remind everyone who's watching, the ROV system we're using is a two-body system. So we have the ROV Deep Discoverer, which provides the camera view that you're looking at right now that we're zooming in on, but then that's connected through a tether to a separate ROV, Sirius. And Sirius hangs through a winch and a cable off of the back of the ship, more or less straight down. And so in order to move, we have to get the ship to move, which then moves Sirius, which then allows Deep Discoverer a new area of exploration. And the deeper we are, the longer it takes for that ship to move and for that motion to translate all the way down. So we tend to have a lot of opportunities to kind of stop and look around while we're transiting up this fracture.
Okay.
Up this slope.
That's clear. Nice. Just sponge upper right I want to see, but I'm not sure if I have enough tether for it. Oh, there's a... Alright, Scott, is this a bolosoma? Snap it. Alright, you put... No, what's this?
Hyaluronima, I think.
Oh, gosh.
I think. But that's a nice bamboo coral that's growing in the foreground. That's branched. That may be different from that other one.
That's my favorite kind, is the...
Hyaluronima, I think, is that tulip sponge or that goblet sponge on the stick.
Hyaluronima.
I think. I'm going to have to check that.
You need to make little flashcards. Use your...
That's a great idea.
Your deep sea website. Print them out. Come in video.
There's two options
that can choose, right? Option 1 and 2, you get just science.
Oh, that's nodal branching right there. Yeah.
Nice. So this is branching at the node. What a great view. So we've talked about this a lot. Part of the taxonomy and naming of these bamboo corals is where they branch. So here you can clearly see that branch is coming out of the protein part. So this is a nodal brancher. And I think that this is a different coral than we were looking at earlier. And the other thing that I'm looking at are the Sclerites, which are the calcium carbonate parts. And I can see that they're relatively small. We don't have the really big needles here. And I'm not seeing them protrude in between the tentacles.
The extra lights at about 30%.
Understood. Coming up now.
Did you feel it?
Give me 50%.
You want some more? Did you feel the?
My sonar return has never moved.
Yeah, I guess we're not seeing it.
Science is done with this view.
Understood.
Lights are clear.
Big, come on.
I'll note, I got the name here for that predatory tunicate we saw earlier in the family.
Video swap it out.
The genus is
my angle to you has been the same.
Megalodictopia. It's a bit of a mouthful.
Now, it's interesting, among all of this fractured pieces of basaltic rubble, I assume it's basalt. It's almost 100% likely basalt, but it's hard to tell with all the coating of both biological and manganese. You also see these huge lobate intact pillow blocks. So the one in the bottom right, and that's one large pillow. That looks like it was probably formed in terms of a, not one of those long kind of pillow lobes that we saw earlier, but a big inflated pillow that then fell off of its main eruptive source.
Come in video.
So it'll be interesting to see what the transition looks like as we go up.
Oh, sorry. My bad, Brian.
Probably you're good with another 10.
Yeah.
Bridge is
so this sponge to me again looks like the genus Hyaluronima, or at least in the family Hyaluronimidae. It's a glass sponge. You can see just extending down there below it is the stalk, which is formed of the silica spicules that this sponge forms. It looks like there might be an amphipod living inside of this sponge.
Look a red dot.
We're getting a closer look here. See how great the video and the magnification on this video is.
It's playing the focus game. It's deep in there.
Yeah, it's deep in there, and of course the sponge itself is bobbing in the currents. But almost assuredly that's what that is, an amphipod crustacean. Sponges are often home to a lot of different associates. Worms, crustaceans, shrimp, zoanthids, anemones. And you can see actually as we look down below at the stalk, you can see at the upper part I see some exposed silica, but below it, it's been colonized by something else. So it looks like its stalk is wrapped up in something, not sure what it is, mud tubes or a different kind of a sponge. Good stuff.
You can come out and we'll keep going. Thanks. I'll probably continue up this rock pile here, see what's attached. Oh, there's some.
Well, there's already more colonies than I was expecting down here, Ashton.
Well, don't get carried away.
No, I'm trying to be really good.
I want to try and be in a pseudo one continuous move, but of course, if you do see something you want to really investigate or sample, please, by all means.
Yep. Most of these colonies that I'm seeing don't look in great shape. You know, they're still alive, and I'm seeing they're being clambered up upon by brittle stars and so on. This one looks like it has a bunch of barnacles on it.
They look, for better word, ragged.
Exactly. Most of the tissue is dead. That last one we looked at was in pretty good condition. But these 3 or 4 that I'm seeing up here, most certainly not. And that's very interesting. And I have no idea how long this skeleton has been sitting in place. So this is a bamboo coral skeleton. I don't see any live bamboo coral tissue. I do see many hydrozoans overgrowing it. I see at least 2, 3 brittle stars wrapped around. They're probably fishing in the water column. Looks like a couple of barnacles on the upper branch there towards the top. Actually, several barnacles. What else do we have?
Go ahead, Rich.
There is some tissue. Look at that. Something's hanging on. At least 1 or 2 branches.
Yeah. It's got a little bit of polyp left there. You can see where it connects on the right there.
Shall we do it, Ashton? I'm not dead yet.
You do you, Scott.
All right, thanks. Yeah, so that one branch that you see there with the pinkish polyps, that is the bamboo coral. And so there is still some tissue alive. And in this one, you can see very prominent needle-like sclerites. So this is different from the one that we were just imaging down the slope. All the tentacles have been withdrawn. Oh, there's also in the center there a tube-like fan worm.
Oh, yeah.
So that's kind of cool. The worm has built its tube up on this colony. And then the larger polyps that we see over here on the right, that's a different coral. That is a stoloniferous coral, one of these ribbon-like ones that's settled on this dead skeleton. It speaks to the importance of the habitat structure that the bamboo coral created in the first place as habitat for all these other organisms, even after it's dead, or in this case, mostly dead.
Yeah, we've talked a few times about the what an opportunity any type of relief above the seafloor creates. And so, whether that's geologic or whether that's dead biologics, giving the ability for other organisms to find a little bit higher perch.
Well, actually, did you need a closer look at this one here? Just snap it.
Yeah, let's do it. This one looks like it's alive, and there's something different on it. Oh, no, I'm just looking at a different view of a wrapped-up arm.
Okay. We'll let it go video.
Yep.
We'll keep going.
Yeah, can we actually get that snap right there?
Coming back in?
No, just wide, just zoomed out like that.
You want to stay wide? You want to see the...
Yeah, I want to see those lobes, those pillows, especially on the left-hand side on that slope. See those large bulbous features, those large pillow basalts? Those actually look like they might actually be in place and forming kind of part of the structure that all this talus is on.
Can bring it around. Let's go Holothorian.
Yeah, so I think what we're looking at is actually kind of a big stack of pillow basalts. So a big stack of the actual active volcanics that form this area with some rubble draped on top of it, and then some sediment.
I'm kind of seeing like this really wide ridge that's filling most of the screen right now, with lots of pillows on it. So you're telling me that whole ridge is all pillows on pillows?
I think that's all pillows
down.
Yep, and then
there's probably more of them.
Yep, and then there's fragmentation coming across
10 more meters.
And I actually, I'm hoping that it'll get less sedimented as we come up, just because we're not too steep in some of these areas on top of these pillows, and there's actually not too much sediment.
Move when you're ready.
Copy.
Range 10 meters.
I'll tell you, Ashton, I'm really surprised how many suspension feeders there are down here.
Well, I want you to know,
colonies.
I picked this area just to surprise you.
You continue to surprise me every day.
Yeah.
So we had this discussion yesterday, but it speaks to the productivity in an overlying water column. So we are really deep, but clearly there's so much production above that enough of it's getting down here to support this fauna. The density is obviously lower than what we saw yesterday, but it's high for 3,300 meters.
Yeah, and so that loose kind of generalization that you can make in the seafloor around areas that are dominated by calcareous depositions, the depositing of marine sediments through animals that form their tests and skeletons through calcium carbonate, calcite, is about 10 meters per million years. And so, on a rough estimate, if we're on something that might be 500,000 years old, then you might expect 5 meters of sediment. And so that's
kind of mind-boggling.
Yeah, so that speaks that this actually might actually be pretty young. It's not necessarily some of the older portions of the Mid-Atlantic Ridge in this transfer zone, in this fracture zone.
A lot of barnacles down here that I'm seeing on these skeletons that have been stripped of the tissue. So we have two corals in front of us. They're both bamboo corals. The one that's just off the screen on the left, that one's mostly dead and overgrown by that stolonifer. But the one that's right ahead that we're about to image, this is another live one.
Start at the bottom.
So this one's in good condition. And to get at this idea of, how old is the bottom and how much time has there been for accumulation of sediments, I would say the same thing about these skeletons. So how long ago did this one land here? Actually, this is really interesting. I'm more interested right now in the thin stalk on the left of the main coral, because if that is a bamboo or some other coral. I actually think maybe it's a sponge, but if it is,
50%.
that's telling me something about recruitment. We want to know, okay, we see some corals here, they're all big, they're all old, but what's happening now? Are we having ongoing recruitment? And so when we see small corals, that's interesting. I actually think that's an Asbestipluma carnivorous sponge. So yeah, nice colony. Let's see. So okay, so this has got the prominent needles again. Probably the same one we imaged before. That branch looks like it's coming out of a node. That's great. Thank you.
And Cindy Vandover, one of our shoreside scientists, is also chiming in that another complicating factor in terms of the deposition is not just how old the seafloor is or how much primary production is, but what are the ocean bottom currents like. So that can help sweep away material. It can also help deposit material. It might be a source for food for these organisms, and it might kind of alter our perception of how old the exposed rock is.
Yeah, Cindy's comment about how the fracture zone may channel food or currents to support what we see here, or her question about it. I had the same thought, when I'm looking at that map, I'm thinking, we're in this sort of cross where we have two deep rifts, or excuse me, I should say valleys coming together. And so there's got to be some degree of funneling of the deep currents. And so that may improve the rate at which all this marine snow, these dots of white that you see in the water column, are drifting by these polyps, and that's what's necessary for all of these suspension feeders to feed.
Okay, thanks.
It's kind of like if you're sitting at the dinner table at a conveyor belt and your food comes along the conveyor belt. You want that conveyor belt moving just fast enough that you've always got some food to eat, but not so fast that you can't grab it off, and not so slow that it's like, I'm finished, give me the next thing.
Good copy.
That's not typically the way I eat, Ashton, to anticipate your next question.
I was going to say, well,
thanks.
I just had a problem of picturing a conveyor belt full of desserts.
I don't have a problem picturing
Sunday, cake, Sunday.
Come up and over it.
Masako Matsumoto on shore says that Okeanos close-ups are always amazing. That's so true.
Thanks.
And so ROV, just for geological sampling kind of awareness, what I'm kind of always looking for in areas like this are these large low-bait pillows that don't look like they're talus from upslope. They don't look like rubble. But then looking for maybe a section where it's fragmented. So that, we're grabbing a section of one of these pillows, but we can pretty much tell it came from that pillow. So keep your eyes peeled for that.
Okay. Understood.
And then, also just based off of some of the weathering and alteration we saw, the one we grabbed, one of the ones we grabbed yesterday, which was about softball size, we picked it out of the bucket, and it was either Scott's amazing grip strength, or just the depressurization. It came up in about 4 or 5 pieces. So
really?
Yeah, so it's pretty weathered, and so we might be grabbing something a little bit larger, maybe cantaloupe size.
I hadn't dialed down my hand before I stuck it in the rock box. Sorry about that.
Is this lasers? Is that something you like?
Yeah, let's see if that's some stoloniferous octocoral or small sponges.
For a rock.
A rock. Come on.
It's a great rock. It's big, but we could give it a wiggle.
Yeah, I think we can give it a wiggle.
It's certainly in place.
Yeah, it's in place. It's been reflected to me a few times by some colleagues who's been doing this for 40 years. You never really need anything bigger than about a grapefruit, but you also take what you can get.
It definitely looks like it's like freshly cracked from that, that pillow. Right?
Yeah, it looks like it's cracked on those two surfaces, so it's definitely looks like it's an in-place feature, which is great.
Thanks. Hydraulics going on.
One of the hard things about after collecting these rocks and we bring them ashore and then bring them on ship and then we try and write descriptions of what they might be, we can usually assume some type of basalt in where we are, but in terms of mineralogical assemblages, so what type of minerals are actually making them up, or vesicularity, how much pore space is in them, is that a lot of these rocks are coated in a precipitant, sometimes manganese precipitate, and that makes it really difficult to see that kind of fresh surface, and so we kind of have to wait till we get back on shore and they can be sawed in half.
Nope, now it's stuck.
Yeah, it looks like...
You see that?
Yeah, it looks like it's probably still attached on the other surface.
Yep.
All right.
Worth a shot.
Yep. No, just and just so you guys are, aware of what we're looking for. So I'd always rather have, 6 set of eyes looking than
I
one.
think that's about the right size, though. That's like trying to get you a sizable one. It's definitely in place. Okay. All right. Take it off.
The jog's clear.
So, Ashton, you don't have confidence that, I mean, for me, I wouldn't think that these had tumbled down slope. They all seem to be part of this feature, so you don't have confidence in the ones that look more separated that they're not. You can't, you can't eliminate the possibility.
You just can't be sure, yeah. And so, a great example of that is out in Hawaii, right? We're on the volcano Kilauea, right? It's one of the 5 volcanoes that form the island of Hawaii. But in kind of some of the landscaping that people have done around the park areas, they've used large blocks of basalt that are from Mauna Loa. And so you can imagine you actually have these erratics from a different volcano that are scattered through the landscape, forming trails and things like that. But, 100 years from now, who knows? Maybe those will get buried by an eruption, and 100 years from then, a geologist will come out to interpret it and be like, why is this large Mauna Loa basalt in the middle of Kilauea?
Sure.
Now, if you want to get
it's like there's some kind of fan on a rock down here. This may be an example what you're saying about tumbling down slope, just under the lasers. So that rock has surely moved since that coral began growing. If we can get a zoom on that, great, thank you. Understood.
5 degrees speed, 0 decimal 2 knots.
And then some other complicating factors, although these are probably less of an issue the more equatorial you get, is you have glacial erratics, so you have large boulders that have been carried through icebergs and glaciers that as those glaciers melt, they drop those erratics. And then you also get tree erratics, so large trees that get blown down or collapsed or landslide driven into the ocean through fluvial systems. They might have rocks entrained in their root system, and then as those decay, they drop rocks. So
what about if I think of like a classic volcano exploding? Would rocks be thrown that far?
Not here.
Okay.
We're so far away from everything. There could be submarine eruptions that might erupt pumice. And then, of course, subaerial eruptions, large eruptions on land, will erupt ash and volcanic glass that can make itself this way and fall through the water column.
Larger section. Okay. All right. You come out.
Thank you. So what you can see here is it's sheared at the base. And so this is a large skeleton. I'm not 100% certain it's a bamboo coral. I don't recognize that kind of growth. But whatever it is, it's tumbled down the slope. There's no tissue on it. And you can see here all kinds of rubble. This is interesting because this is octocoral rubble, where the last several dives when we've seen these huge pile of rubble, those were stony coral rubble, scleractinian. But the bamboo corals do produce pretty hard calcium carbonate skeletons, so they persist for very long periods of time, more so than those protein-based ones would. So this is kind of promising that there will be even more as we move upslope, which is going to make it even harder for me to acquiesce.
I know, but think about all those beautiful corals you've already seen, all the beautiful corals you'll see, and take a minute and stop and smell the rocks.
I will do that. Yes, so this is another good example of the bamboo coral that's dead and been overgrown by this other thing. I've been calling it a stoloniferous one, but now as I look at the upper of those 3 branches on the right, it looks quite thick. I'm actually wondering if this is in the family Anthithelidae. I realize that's not going to matter to most lay people. But the interesting thing about the anthithelids is they can begin by growing like a mat and overgrowing stuff, and then produce their own skeleton as they extend outward from there. So that might be what's going on here.
Thank you.
Zoom out a little bit. There we go.
Complete pilots.
Toe slipped a little bit. I'm back.
The dots in there are really kind of interesting. Let's see what's going on here.
So do you try to put a little forward way in when you've got the toe down?
Yeah. Depends on the hold, but typically.
I guess those dots must be sclerites. I'm so used to looking at bamboo coral and their clear tissue and identifying basically different kinds of rods and scales and needles that I'm not used to seeing the sclerites of other families through their tissue. And they have such a huge diversity of shape. That's why this looks so different. That's cool. All right. No idea what it is. I think I'm going to go on a limb and say Anthothelidae.
Thanks, Bill. Said you got 10 meters going, right?
We did.
What was
Just
the bearing
finished.
of that?
It was 265 still, but we can make the next
Yeah,
one.
it looks like the shore-based scientists are also excited to maybe see some steeper exposure of the wall.
Yeah. Our depth is 3,327 meters, so we're more than 3 kilometers deep. Close, getting close to 2 miles. It's about just over 1.8 miles. So another thing, as we move up here, there's a dead skeleton at the base of this pillow, and I can see 3 brittle stars climbed up on that coral. Note there's no brittle stars on the rock.
Yeah.
You know, and that's very common for that kind of brittle star. I'm not exactly sure. Well, I do know that to get from one coral to another, they do have to clamber over the surface. So occasionally you see that. But it is interesting that it is the fauna, the corals and the sponges that are our habitat, not so much the basaltic seafloor, at least for that kind.
Yeah. Yeah, and it was, you know, I'm just, when I'm looking at this, I'm of course thinking of what we saw, I think it was the other day, where we actually had kind of those 3 little micro environments on kind of one side of a ridge. We had kind of the really active side. We had kind of the less inactive side with some of the less of the larger megafauna, and then we had that side that looked more or less barren to a certain extent in terms of the macroscopic organisms, just because it was in that talus field. And so until we kind of get an idea of what we're looking at, we don't know. Maybe we're in one of those large talus areas right now.
Just had a sea cucumber go flying by, which gives you a good indication of how fast things are. Can we zoom on the fish that's just to the lower left of the lasers, spotted by our geologist, Hawkeye Ashton?
I don't know how I missed that.
Nice job. I missed it too.
I thought it was a wiggling rock.
Oh, that's why. Okay. Yeah, this one's different.
Yeah, take it.
Ophidiidae, maybe? Cuskiel, maybe? But I don't think the same species that we've been seeing earlier. Oh, that's really interesting.
Yep. Do my best.
Deep sea snake.
It's full.
You saw a snake?
It's not quite.
Well, I think there's a large worm of some kind, maybe a mollusk, but it was snake-shaped.
Come on, turn around.
I was getting excited.
Yep. I knew I shouldn't say that out loud.
Are there deep sea snakes? I mean, I know they're ocean
there
snakes,
aren't,
right?
Because they're air breathers.
Yeah.
And so, it'd be too hard to get back up to the surface, like whales, right? Whales can do it. Other cetaceans can dive pretty deep into the deep sea. Maybe not this deep. But they have some amazing capacities and can go down to 2,000 meters.
Yeah. Sonar looks clear. Give it another minute.
Yeah. Understood.
Cool. 3 little sponges also tucked into the rock. Just before you go, look over to the right, please. Lower right, I think. In the sediment. Or was it in the sediment or just not that low? Sorry. Yep. No, let's just go right there. It is just on the edge of the rock right there. So that's what I saw. Can't tell if that's a tube or.
Are you talking about on the right of the screen there?
It just went out the top right corner. It's on the rock.
Small tube.
There. That wiggly thing. Not the tube, but on the rock face.
Oh,
that's it.
Worm-shaped, sediment-colored.
Yeah, so I think it's actually a tube made of probably some parchment and sediments together, so it's almost assuredly another fan worm.
Yeah, my toes slipping.
Yeah. Parchment?
I'm not sure what the material is, but worms can secrete something that is almost paper-like or leathery-like.
Yeah.
Maybe not leather, but it's harder than just mud and mucus together, and it's softer than calcium carbonate. So I described it like a parchment.
Okay. Yeah.
But you're right to call me on it, because I think parchment is actually paper.
Yeah, so that's why it was implying cellulose structure to me.
Yeah. I don't believe it's a cellulose space, but I don't know what the chemistry is. It's kind of a very interesting question. Something else now I'm going to have to research.
Okay, so now that
what's on the top of this rock, this purple thing? Oh, it's just another sea cucumber. Okay.
So I never thought I would ask this, but what is the taxonomical difference between a snake and an eel?
My goodness. I'm just so impressed you're asking about taxonomy.
I know. I should probably just quit now.
So a snake is a reptile.
Yeah.
So it'd be more closely related to lizards and crocodiles. It's basically one of those with no legs, where an eel is a fish. Oh, so here's a really cool sea cucumber. which has some of its podia really elongated. I want to say something like Dendrochirota or something. Hopefully someone will correct me on that. But again, just another deposit feeder. The interesting thing about this one is it's sort of clambering up on the rocks. So I'm not sure if, it's there's a thin layer of sediment on that rock that maybe, I wouldn't say it's necessarily adapted to that, or we've just caught it in the act of moving from one sediment pool to another. There's quite a high diversity of sea cucumbers.
Okay, take it now that I'm closer.
Let's see if I can find a name for this one.
Spiky.
Old Spiky.
What'd you say, Chris?
I think
so that snake eel question to me, that's kind of one of those questions I would ask. I can see myself asking my parents that question when I was 7. What's the difference between a snake and an eel? And how do you explain it to a 7-year-old? Or, for a lack of a better word, how do you explain it to a 40-year-old geophysicist, which is like a 7-year-old?
Honestly, it looks like
well, I think was that pretty good? Reptile versus fish.
I think so. Yeah.
Right.
One has gills and one's an air breather. So the eel has gills.
How far long ago did those?
The reptile and the fish?
Yeah.
I would guesstimate, I should know my geological timetables better, but I'm going to guesstimate 200 million years to 300 million years.
Okay.
Someone's going to call me out on that for sure.
Yeah.
So I'm looking at an image in the animal guide that suggests this is in the family Dematidae. And boy, here's a mouthful for this genus. Orphnurgus. Orphnurgus is a possibility. So what you're looking at are tube feet, basically. Compare this to a sea star. If you've ever looked on the underside of the sea star, it has all those tube feet that it uses to move around and grasp its food. So these are just longer, modified tube feet. And I think, this is kind of funny, I think the head is at the right, but I could be wrong. And that's the problem with some of these sea cucumbers. If you don't actively see them feeding, sometimes it's a little hard to tell.
You could be right.
This one
could be left.
It could be right, could be left, could be right, could be wrong. It doesn't have the modified podia that it uses, like little hands to grasp food. So that's why it's a little hard to tell with this one.
And those little modified podia, those are on the head base side, so that's an easy way to kind of distinguish them when you see them.
275.
On those other ones.
On those other ones, yeah.
275 at a range of
10 meters.
Just to chime in there, Scott.
Yes.
Going back to the polychaete tube thing, I was at Emory State when you were talking about it, so I couldn't chime in at the moment. But those tubes are usually made out of kind of mucus that they secrete into fine threads and then agglutinate it with sand or mud particles.
Yeah, and so I agree. And a lot of the tubes we see are like that, and that's what that vertical tube is. But there are others that have more of a papery feel to them when they dry. And so think of the Riftia tube worms as a good example at the hydrothermal vent. Those are clearly not mud. So there's something else that's being secreted along with the mucus.
ROV, do we have a minute? Or are we moving?
Nope, we're good.
Okay, you see that large fragmented pillow right in front of you on your left?
I sure do.
And you see there's kind of almost like a little rectangular keystone rock in the middle of it.
Yep. Little tiny one?
Yeah, I want to... Maybe something in there is sampleable. It might be a little small, but it's definitely in place.
Understood. All right, let's see if we can give that a poke. See what it looks like. Hydraulics up.
Hydraulics are up. Ready to go.
I'm coming off. Thank you.
And if we could get the lasers on real quick, too.
Got that. Lasers on.
Thank you.
That little tiny one. that what you want? Watch lead?
Yeah, maybe pull it out and we'll see. Or, I'm hoping maybe some of that stuff is just kind of fragmented enough so we can kind of dig around in there.
Do you want a bigger piece? Or see if there's a bigger piece to come?
Yeah, if you see one.
I could try to touch the one next to it.
What about,
yeah, that one doesn't seem to be.
See the larger one right in front of you? What if you take your jaws on the left side of it, pull up on it, and see if that one's loose, and it might make stuff.
This guy?
Yeah, that one, yeah. Bigger one, see if you can see if that one wiggles.
Understood.
There's also the one sitting on the ground right there that looks like it fell out of that crack. See that? You saying? That one?
Yeah, just below me?
Yeah.
Yeah, that was.
Oh, there you go.
Oh, okay, so the one there is loose.
Yeah, that one there, that loose would be perfect, yeah.
Okay. Let's see what we can try to get out of there.
Want to go open the box, or do you want to
try to get behind it? See if we can.
Go ahead, Bridge.
Do you want to open the port rock box, or do you want to do starboard?
Move is complete.
We can do starboard.
Okay.
See if I can get this out of here without sliding. Okay, we'll re-grab that.
Having a wing inboard.
Stand by one.
Okay.
And so if you're just joining us, our ROV team is sampling a piece of this pillow basalt. And one of the important things for geological sampling in the deep ocean is to make sure that we try and get something that's in place, something that we know came from the rock and is not a piece of rubble from somewhere else. We also want a portion of that outer skin of that pillow basalt that's quenched quickly and has likely a large concentration of volcanic glass in that. And that volcanic glass is used for subsequent geochemical analysis.
You got me turn the lights on. Yeah. Okay, hold on. Coming up. Just a little bit. There you go.
That was really nice to be able to pluck that out of there.
Yeah, that was some great skill by our ROV team.
Sure can. Stand by.
Could you bring it up, too?
Beautiful, you guys.
All right, video. Come back on that. Yeah, I think we can get that in the starboard.
Okay. Sample box. Ready for me to bring it in?
Yep. Right.
All right.
Understood.
Thanks, Brian. There you go. And mini Zeus.
All right, so sample into
I think I should be okay.
Okay.
starboard side rock box. Yep. And that'll just, we can just do pillow basalt 1. And then if we could also just get a few stills of that outcrop.
Pillow fragment 1, you said?
Yep. Or pillow basalt fragment 1. Although pillow implies basalt, but yeah.
Might as well be thorough. All right, it's in the box.
All right.
Yeah, you're good. Okay. All right.
Clear.
All right. Wing outboard.
Wing outboard.
And do we have some nice glamour shots of that?
Shoulders up.
Outcrop.
Okay.
Hydraulics clear.
Okay. Oh, wrong edge.
There's a little jelly.
All right, painted tilt's coming back to
looks like the one we imaged earlier with the red canals, the yellowish bell.
Oh, yeah.
I'm not sure if it must be the cells that are forming the bell, but in between there's a layer of cells on the outside, a layer of cells on the inside, and in between it is a gelatinous matrix.
Okay. By the way, Potters, we're going to start asking for percentages. My editor's saying we've had them too high.
Okay.
Starboard rock box.
Thank you.
Thank you, RV. That was a perfect example of a beautiful geological sample.
All right. I turned to port a little bit, Chris.
Understood.
Or, excuse me, to starboard. Yeah, what's our next waypoint? Like, I see waypoint 1 there, but what's our...
Interesting here, these different sort of highs, ridges that we can see all the exposed, broken up pillows and then the sediment in between.
Copy.
Yeah, and so, you know, it's hard sometimes, especially when things get this sedimented, to really tell what is rubble and what is primary, especially, you know, in those areas that we've been on those tops of those ridges where everything is just so fragmented. So it's fragmented, but it's actually in place. But there's just been so much shear that's occurred on those fault structures. So when you see those nice, beautiful, large, low-bait pillow features, you know for sure those were kind of erupted in that place or erupted from up and then kind of dropped as a large pillow structure.
It may be obvious, but the other thing I like in the view that we're seeing here now is that these corals are growing on these rocks. They're not in the sediments. We're seeing something very different on the sediment compared to the rock. And in fact, you can see down in that chute down below, I see a purple sea cucumber on the sediment. That's where you would expect to see the sea cucumber. It's a deposit feeder, so that's why that last one that was on the rock is a little bit odd. But it gets to the, I guess, obvious difference that major habitat differences are going to affect the biological communities that are living on them. They're processing food in different ways. And in most of the deep sea, it's a sedimented bottom you're going to see. We're targeting the Mid-Atlantic Ridge. We often target seamounts. And so we're looking at places where that rock does sort of stick out of the bottom, and so it may be to the average viewer of Okeanos Explorer dives that, wow, most of the deep ocean bottom is rock. But that's what we're targeting. Most of the deep ocean bottom is actually sediment. And so when we do see these large, diverse, and dense communities of suspension feeders, we know that, oh, that's a special place. This is different from sort of the average deep sea.
Now, we were either the other day or the day before, I forget, you know, don't hold this against me. We were either talking about a coral or a sponge, which I still can't necessarily always tell the difference from afar, about the one that had developed, it evolved to be on hard rock and then soft rock and kind of had an inflated peduncle.
Yeah, I would love to be able to find that today. So that was a coral. Specifically, it was a sea pen, a member of the Penatulaceae type of octocoral.
Sea pen, okay.
Yeah, and so the sea pens have been adapted. The base of the colony is this inflatable, what we call a peduncle, and that allows them to stabilize themselves in soft sediment. But yeah, a small subgroup has now evolved to come back onto rock.
Would you expect to possibly find those in a deep area like this?
Oh, I would love to. Yeah. So
I can't find which
most of the known observations. Let's see. Oh, good. Upashana Ganguly is in the chat room, so she can tell me exactly where are most of the observations. I think they go down to maybe 1,800 meters. But last summer we observed 3 or 4 of them. When we got onto the bottom for about 15 to 20 minutes, we were doing a mid-water dive, went down to the bottom just to see what was there, and we saw some at
maybe it's
3,200 meters.
No, so right around in this range.
Exactly, the deepest ever known. We weren't able to collect one, so we don't know what it was. So I would love to be able to see that, and that would be a collection target.
That's about the tether you got.
So here we're looking at some encrusting sponges on one of your nice rocks.
Partial.
Not sure what the filamentous stuff is. We collected, when we were at the Moitira events, we collected a rock that had a lot of these filamentous strings, and so I preserved a bunch of those to find out, are they being produced by worms, amphipods, foraminifera, something else, so hopefully somebody can.
And so the ones that you collected, what did they look like once you had them back in the lab?
They maintained their integrity pretty well. I could not see that the tips of them were open, as you would expect from a worm tube.
And how big? They were tiny.
Yeah, they were maybe 2.5 to 3 centimeters in length. So my suspicion is that they're more like foraminifera. That's probably fecal traces in the
No, are those little
those mounds?
Those little cups.
Those are winch tension looking.
The cups here, those are all sponges.
Those are all sponges.
Yep. Ashen's pointing to the rock in the foreground. There's several gray-white structures that are arising. They're very small sponges. They look like little tubes, actually.
Pile of poop.
Yep. Pile of poop there, and then beyond it, that ball-like structure, that would be a xenophyte.
And is that a glass sponge?
Yeah, nice tube glass sponge just below the coral that's on the rock. Has the general morphology of the one that we collected yesterday, except that this one appears to be growing in the sediments, which suggests to me it's probably a different species.
And another glass sponge.
Yep, same sort of morphology, right?
Once we get to the far
spot.
left.
I'm going to take your job.
Just do like 30, 30,
That's
30,
good.
30.
Yeah.
That means we've been training you well. I don't know what that is. Something collapsed over the rock. Maybe a sponge folded on itself. Or maybe an encrusting sponge growing up a rock.
Yeah, so we're looking at this angular pyramidal rock on the bottom left. Down to the left.
That's a bamboo coral that's on the rock. We've looked at that a couple of times, this unbranching, whip-like form.
Yeah, that thing, right?
Yeah, okay. That's a sponge. It's an encrusting sponge.
Yeah.
With a whole lot of other little globular sponges. And there's a beautiful tube sponge.
Dip, right?
I'm going to say something like the family Euplectellidae.
That is tiny and so delicate of a structure.
Yep, sure is. I think I predicted when we were diving that there were probably going to be a lot of sponges down here.
You know, it's kind of a shame that the modern art movement in architecture didn't happen at the same time of deep-sea exploration, because I think they could have drawn a lot.
Absolutely, and on some of these expeditions that go out, like on the Falcor, they take artists with them to interpret this, because there is a lot of beauty down here. And I just love the complex architecture of these glass sponges. And there you can see that sieve plate at the top, very
it almost looks
diagnostic.
domed.
Yes, this one does look domed, I agree. And it looks like silica fibers on that dome coming up the top. So that'll be useful to our
taxonomists. I had that too, Chris, and I think it might be...
Yeah, right. I can't help but look at that delicate doming, interarching structure and think, Buckminster Fuller and geodesic doming.
Sure.
I did the same thing. I was at 60%, and I think...
I grew up with that. I grew up in Montreal, and we had Expo67. He designed
waffling, so that's the kind of
huge dome was designed as a Buckminster Fuller dome that included a very large pavilion.
Or it's just the toe just
drifting sea cucumber.
Maybe we can't really help. I don't know.
I wanted to come back to my prediction that there would be a lot of sponges, and one of the reasons I predicted that is I thought that the amount of organics getting down here would be relatively low, and sponges have a lower energy requirement, and so tend to do quite well in those environments where there's low current flow and perhaps not much food, better so than some of these larger suspension feeders. Can we zoom on the fish, please? Straight ahead in the middle.
Take that portion.
Thank you.
There's two.
There's two of them.
One on the left we saw earlier, I think.
Yep, I agree with you. This one might be a very small rat tail, perhaps. But anyway, this is one of the reasons I'm surprised with all the corals. There's obviously some burrowing fauna here. I see little mounds. Yeah, I think this is a little rat tail with very tall dorsal fin.
You're going to give me 10 more. Due west.
Due west. Copy that.
Thanks.
I'm not sure what London pickle is, but that last wild sponge reminded Cindy of it.
Range 10 meters, bearing due west 270 degrees.
Does she mean the little cocktail pickles?
I'm not sure. This is interesting to me. It's like a head with a tail.
That's it.
You know?
Thank you. Ship move is in.
Thanks.
Is that where the rat tail comes from?
Absolutely, yeah. So I think this is a grenadier, and the other common name for the grenadiers is the rat tails. And I think you can see it looks like this rat tail appended to a head with very large eyes. And I believe these are bottom feeders. So they sort of move slowly above the bottom. They move slowly to conserve that energy. Yes, the building in the London skyline.
ROV pilot, like DB gain was high. Like if it was +3, it's real washy.
That's good for us when video's ready.
Clear?
Got it.
And so if you're just joining us, we're on the Mid-Atlantic Ridge. We're in the Kurchatov Fracture Zone, which is a right lateral offset in the north-south running Mid-Atlantic Ridge. And what I mean by right lateral is, I mean, if you were standing on the edge of the southern segment of the Mid-Atlantic Ridge, on its most northerly tip, and you looked at the Mid-Atlantic Ridge to the north of you, the whole system would move about 20 kilometers to your right. And so we're in this deep basin between that westward portion of the Mid-Atlantic Ridge and that eastern portion, right where it kind of steps over to the right. And we're kind of right in the middle of it, in this fracture zone area. And we're exploring this large slope, which is covered in calcareous sediment. So sediments derived by microorganisms that live in the water column, and these large pillow basalts that are draped under them. And these pillow basalts are volcanically erupted. A lot of these look like they were erupted in place in here, and so we collected a sample, and we'll use that to age date to see how old these rocks are. And so just to give you some geographic awareness, we're about 175 kilometers from the Azores, from the northwestern island in the Azores, the island of Corvo. We dove to about 3,130 meters below sea level. Right now we're at about 3,310, and we're going to try and come up about 200 meters to about 3,340. And so, those numbers are reversed. Sorry. We dove to 3,340, and we're coming up to 3,127. And hopefully we'll see a little bit less sediment on the way up and a little bit more primary exposed geology. We'll get an opportunity to sample some of the biology and then also take some more rock samples.
So I asked for a zoom here to show you the brittle star that is more characteristic of the seafloor and perhaps the sediments. And also you can really see nicely how a brittle star moves. And it has ossicles, calcium carbonate, hard parts in the tissue that are formed into vertebra, just like the vertebra in your back. And so you can see along the arm, it looks like there's a whole series of segments. Each of those has some musculature and some connective tissue between it. And it literally is using muscle to lift the arms. And it's very different from its cousin, the asteroid sea stars, which use their tube feet to sort of glide above the surface. The other thing that is just so cool about echinoderms is that the connective tissue that they have between these ossicles is under neuronal control. And they can basically partially liquefy that connective tissue so that they can more easily bend. And then they can make it stiffer after that to sort of lock themselves in place. And by locking themselves in place, it reduces the energy requirement. This is the fascinating thing about echinoderms. Thank you for that zoom. You can also see all kinds of sponges on these rocks. I mean,
how big is that brittle star across?
The lasers were on before, so the arms are more than 10 centimeters. Yeah. But the disc is maybe, what, centimeter and a half, 2 centimeters, but the arms are more than 10 centimeters long.
So maybe 25, 30 centimeters all the way across. Yeah. And then, of course, it's just sitting on this cleaved surface of this beautifully exposed pillow, this large pillow basalt behind it.
You know, I think I'm going to ask the next time we see a nice little rock like that that has those nice little sponges on it, that we pick that rock up to get those sponges, because it'll be a nice opportunity to look at that. Another sea cucumber here, the purple one, the upper left, and a bryozoan fan on the far right. We saw a close-up of that before. Yesterday we made a collection of part of a dead coral that had this beautiful bryozoan fan on it. They're really hard to collect. They're very brittle and fragile themselves, and they're usually quite small. But it was great. Came up in perfect condition. So
it's still funny to me seeing these they're fragmented, but they're pretty well exposed pillow basalts, and I keep comparing it to where we dove in the Axial Valley Ridge a couple days ago, which was just blanketed with 10 times more sediment, but should have been an order of magnitude
sea
younger.
Spider right in the center.
Yeah.
Coloscendus sea spider. Can I have the lasers on right now?
Goated center.
When did that move?
Thanks. There, the lasers are just passing over the sea spider, so you can see how long its legs are.
Can we sit and look at that?
Yep. Just creeping in now. Yeah, maybe we'll wait 1 minute.
If we were lucky, we'd find one that's carrying eggs.
Tilt your camera
Different
down
kind
so
of
you
sponge.
get
Much
relatively
more
close
frilly, I
to
think.
it.
Yeah.
Between your toes.
Stand by there.
These sea spiders are specialist predators of polyps, basically. And you'll see that they have a long proboscis that they can create a muscular suction in.
Take that.
And so they aren't chewing their food. They're instead sucking up their food kind of like a soup.
Yep. Low percentage.
Be about 50%.
50, aye.
This one's a little paler than I'm used to. It's probably still in the family Colossendidae. All these really large sea spiders are in that family. You can go in shallow water and just kind of pick through some algae or hydroids, and you'll probably find some sea spiders. They'll just be a lot smaller. Sorry, I was hesitating there because I'm seeing that streaming stuff. So I think this one has been feeding.
Range 10 meters.
You can see the orange part, I believe, is the proboscis. So we're looking at this from the back towards the head. So the head is away from us. And that orange part that you see hanging down now on the right, that's its proboscis. And you see some stringy stuff coming out. So that has recently stuck its proboscis into something and has been feeding on it. Oh, that's a really cool view.
I really hope I don't run across one this big in the shallow water. That's going to haunt my nightmares.
You can also see the darker lines on the inside of the legs. Those are extensions of the gut that extend down.
Oh, really?
Yeah, because there isn't enough space up in the body for the digestion to occur, so they sort of pack it all into their legs.
That's interesting. I assume that was just skeletal, but
so what I'm looking
digestive.
At, look, see the D2 sonar.
Thank you. That's beautiful.
Let's see if we can watch the legs.
Nice little fan worm there.
See that?
What Arvind was talking about, this would be one of the tubes that's made of a combination of mucus and mud grains.
Slight tilt down. Hold that. Laser's clear.
Laser's off.
Let's get that for about 18 seconds.
Whenever you're clear video.
Things of my nightmares. Okay, video's clear.
All right.
Pulling out.
So I'm looking at this, Chris.
Yeah.
I'm looking at that. So we'll assess that next.
Understood.
Yeah, and you can see how we're just kind of on this geomorphological ridge.
Extra lights are clear.
Bridge.
This high that comes off of the seamount, off this small
lights are clear.
volcano. And to your right, we see this valley that looks to be much more covered in sediment, and then some talus, some basaltic rubble,
head
upright, and then these beautiful outcrops
sonar can't see over that.
Of fragmented
so
pillows.
Try to see over it, but I don't think I
can. Much more biological diversity than I expected.
This is it's a polychaete worm for sure. You can see the flashing lights on either side are the parapodia, which are the swimming paddles. And it's head down, moving through the water column. I was hesitating because I was going to try to put it in a family, but I'm not sure what family it is. There are some pelagic polychaetes. Most worms, when you think about them, are associated with the bottom and, sort of burrowing through the sediments or building tubes. But there are a few, and notably the family Tomopteridae, that are adapted for swimming in the water column. And there's some that are really fascinating in their biology. Look up the Swimma bomba, or bomber worms.
So, yeah.
This sponge that's coming into view just right of center is a new one for the day.
Understood.
Thank you.
Now, have we seen that before? Or hard to tell?
We haven't seen it today unless it's the one that you pointed at way in the distance. We haven't had a close-up of it, but I don't know yet if it's something that we've seen on other dives.
You can look to the right and show them the wall.
As we're coming in, I'm kind of thinking not. I remember seeing things like this up in the Aleutians. They're glass sponges. They're really quite crispy, not soft at all. And they have these lobes that are kind of sticking out all around the sponge that are open on the inside. And I remember describing it kind of like a condominium for amphipods because there was an amphipod inside each of those lobes.
What gives them that crispy consistency?
Yeah, so the skeleton is made of silica fibers, and we saw earlier that beautiful vase, the construction, how the fibers are all kind of overlaid with each other, and the tissue is really, really thin. So there's a lot more silica than there is tissue, whereas in the demo sponges, the more regular sponges, they have another compound inside them called spongin. It's a protein that makes up the bulk of the sponge. So, for example, you know, if you bought a true bath sponge that was a real sponge, that skeleton, that would be the spongin fiber, and that's soft and it holds a lot of water. So I think that's the difference. Yeah, this looks a lot like what I saw. Doesn't mean I can put a name on it, but
just bring up the other lights.
As we get this close view, maybe two things we can do is look at what it looks like at the base, and then is it open on the top?
Copy.
But yeah, you can see all these lobes kind of poking out. And I think when we look on the top, there we go. Nice. So it's very narrow, constricted, and has some kind of hold face. It's tucked onto the rock. Excuse me, hold fast, glued onto the rock. I'm not seeing anything through the tissue that would suggest it's populated by amphipods on the inside. So the question is it open like a vase at the top, or is it closed?
270.
Almost assuredly we're going to find it's going to be open.
And what did you call that structure on those glass sponges where it caps the top?
Well, I was saying sieve plate.
Yeah.
There may be another, another name for it. Yeah, so you can see this one's open at the top. So it's kind of like a great big cup or a bugle that has the walls kind of poked outward from the inside. That's the way I would describe it. However, the water flow in terms of feeding would be from the outside to the inside, and the outflow would be out the top there.
Now let's look at the top opening.
These lobes are X-current?
Understood, thanks.
No, I don't believe so. I believe each of those lobes is closed, so they only open to the center. And so I believe only the top is the X-current, the inside. You can really see there nicely this sort of meshwork, and that's this complex of silica fibers that is overlapping one another to create the main
hole.
Body and wall of the sponge.
Back soon. Holding for near ground.
When video's happy, we're happy. Thank you.
Video's clear.
All right, come on.
You can go ahead and lift off.
Done with the lights.
Hang on a second till we move off the shot.
Okay.
I've got no thruster.
Joy lock.
Thank you.
Okay, lights are clear.
I thought I had it on for the set shot.
Go ahead, Bridge.
Copy.
So I hit it and re-engaged it.
Move is complete.
So I'd probably settle
over
to that wall and kind of just face it and look at that big white sponge. Kind of will come up.
The top of the screen there, that thing you see that's kind of lying down, that may be the sponge you're just looking at dead, though.
Yeah. So
As you notice, it's brown, but it has all those lobes around the cylindrical body. That's almost assuredly what it is. Here's another one, this brown thing. This is another dead sponge. Once the cells die, they're less able to remove sediment from the body, and so the sediment begins to accumulate on the skeleton that remains until you get that color.
Right. The brow's pretty close. See how many is this?
Yep.
So Ashton, as I'm looking on the left side here, is there anything different about the pattern that you see on the inside of this pillow? I see some sort of radiating spokes here, or is that?
Yeah, so, you know...
mic coming in? Mic check, mic check.
No, I don't hear you. Only...
I don't hear you either.
Yeah, so as those erupt, right, and and as lava oozes out, or is erupted out of this kind of vent of this pillow volcano, it forms these large kind of lobes. Those lobes travel down the slope. They're fed by the magmatic pressure, but then also gravitationally driven. And as they cool, they also degas, so you might get some little vesicles, some little air bubbles trapped in the lava that tend to decrease in size as you move through the mound. The outer surface tends to be very glassy because it's cooled very quickly. It's chilled rapidly.
You want a tighter shot of that?
I was just going to have you get a partial, but that's okay.
I didn't hear you. I was
understood.
Communicating with Survey 1.
Every once in a while, I'm trying to get some of the names for some of the stuff by going to the animal guide, but it's hard to do and pay attention to what's going on the screen. I'd rather pay attention to what's going on the screen. So for some of the stuff, you're not getting the best names. When we have the scientists, the appropriate scientists in the chat room, then that's much easier because they will provide some names for us. But it doesn't look like we have any sponge biologists right now.
But we also have your army of students if you wanted to give them a shout out. I don't think.
My army of students doesn't seem to be annotating right now.
Uh-oh.
Yeah.
Uh-oh.
Well, I'm the only one making the annotations, so.
Mic check and all. Okay, EX. Mic check.
Now I can hear you. If we can, let's try to get a snap zoom of the swimmer. Yep. Top of the screen, we have a little hydromedusa here.
Take that roll.
Oh, looks like this is that same one that we've been seeing repeatedly. Oh, beautiful view. See a very slow pulse to the bell. The underside of that bell is hollow, so when it contracts the muscles around the margin of the bell, that forces water out from the underside. And that tube-like structure that you see hanging down, that's called the manubrium. And the mouth is on the bottom of that, and it leads into the gastrovascular cavity, which is basically the stomach space, digestive space.
I love the color of those.
Yeah,
that
those
purple
are
and
awesome.
amber.
And that's, I think that's a color that we get as we get deeper like this. You don't see that up in the shallower regions. That's kind of interesting.
And so you were talking about kind of the shape of some of these pillows, and one of the things I'm kind of constantly looking for is, about 20 to 25% of the volcanic activity that forms a pillow volcano like this will actually be these more voluminous flows of sheet lava. So the same consistency, same probable temperature, but maybe just more voluminous, so more activity. And those won't form these these stacks of lobate pillows. They'll actually form these large horizontal sheets. And we saw just a hint of them the other day where you'll actually see this horizontal transition in these pillows. So instead of seeing all these rubbles and mounds, you might just see a line that goes right through the middle of the screen. And that's important because it might indicate the beginning of one of these individual eruptive events. So they're kind of these individual eruptive events. What is that on the right? Sorry.
So these are the Hyaluronima or hyaluronimatid sponges. So 2 or 3 of them we've just passed. They're the sponge body, the main filtering part, is on the top of this long silica stalk, or maybe, I'm not sure if that's multiple silica fibers or one. There is this one interesting genus, I don't think it's these ones, called Monoraphis, where it does have one silica fiber, and it's, it's like a centimeter more in diameter, and its optical properties are so pure that engineers are studying it because it can transmit light better than the ones that we can artificially make. So they're trying to understand, how does the sponge break down these, I guess essentially I don't know if they're called crystals, but these molecules of silica to form this really pure structure that can transmit light so well.
Well, that's interesting corollary because in igneous petrology and igneous mineralogy. So by igneous, I mean rocks that are formed through eruptions or intrusions. They're not formed through sedimentary processes, and they're not formed through kind of post-depositional alteration or shearing like metamorphic. But that's interesting because in terms of silicate structure of those sponges, we classify silicate minerals depending on their structure. So are they single chains of silicates? Are they double chains? Are they sheet silicates? And so I've always been curious whether the biological side has a corollary. And I'd love Scott to answer me, but he just went to lunch. So We're gonna look at some more beautiful outcrops, the pillow basalts.
Oh, really?
Yeah.
And you can see these individual lobes, and then actually on the right-hand side, there's a pillow about halfway down in the screen, and the lasers are just getting to it and stop right there. And that's actually really interesting because that pillow down there, you actually see this curved arch of the rim. And then beneath that rim, there actually looks to be a hollow space right at the top of it, and there's some sediment that's moved in. If we could zoom in on that for a second.
Yeah, you can take partial video.
And so that's really cool because that's one of these large lobate pillows that had magma and lava flowing through it, and then all of that lava was actually tapped out and moved. All that lava was tapped from another exit and removed from that pillow basalt, and that pillow basalt basically became empty on the inside, and so it just formed this rind of that outer basaltic crust. That's really cool. That we see that is the same process that we see on land that forms lava tubes. So these really big lava tubes that you can actually go and walk through in places like the Hawaii Volcanoes National Park in Volcano, Hawaii, on the Big Island. Shout out. Yeah, that's really cool. Those are also excellent things to try and sample when we get the opportunity. That outer rind, we know it's in place. It tends to be a little bit weaker than some of the denser material, and it usually has a large concentration of volcanic glass that we use for downstream analyses. And there's another one for comparison, but you can actually see it's a lot more dense, and it's actually got multiple levels within that table. And so that means that there was probably a variety of removal events of magma through there over a short period of time. And just for some geological jargon, we tend to use two words, lava and magma, and they're both chemically identical. The only difference is we use the word lava when things have actually been erupted on the surface, whether it's subaerially or in the air or submarine in the ocean, and then we use magma to describe anything that's never really erupted onto the surface and is only in the crust or in kind of the sediment in this case, depending on when it was erupted.
Creeping out on it, rolling.
Yep. And so we're just going through an ROV watch change. The ROV pilots set shifts of between 2 to 3 hours.
Can you anchor up in that
position? The entire ROV team gets swapped out, and so they do a kind of an exchange of information for situational awareness. And that's our three ROV operators. That's the ROV pilot, who operates the ROV Deep Discoverer, our ROV co-pilot, who operates the ROV Sirius, and then our navigator.
And we're all from the Global Foundation for Ocean Exploration.
Yeah, and as Roland said, they're all part of this partnership with NOAA Ocean Exploration and the Global Foundation for Ocean Exploration, who brings out an amazing ROV team and video team.
It's all way up in my brow.
Wow, that's sort of cool to see, though.
All right, Ron, let me leave this, and I'll get Sean in here.
Okay. You're still full wide.
nav, Copilot.
Welcome aboard, pilots.
Video. Yeah. Classic. Hey, watch it. We just did a quick pilot change. I think I heard there might be interest in a sample around here.
You betcha. I just came running back from my room. If we could get a close-up of that multi-branching thing, it's a coral, and I couldn't tell from where I was. What's that line?
Behind it?
Yeah. Is that just like a really tall sponge or something?
Coral, I think.
Okay.
I'm going to snap real quick video. Yeah.
Oh, wow, it's a carnivorous sponge. Oh, my goodness. Look how tall it is.
Big.
Yeah, it's too bad I plated it already, but it's going to sit there. Huh. Well, I don't know how tall that is, but I don't know that I've ever seen one that tall. But yeah, in the foreground here, excuse me, this large branching thing. Let's get a look at that, see if I can determine what it is. I mean, it's a coral, but I don't know if it's a primnoid coral or bamboo coral. At first I assumed it was a bamboo coral, but down slope we saw there was that dead skeleton kind of lying on a rock, and I suspect it was kind of like this one. The way this is branching,
into the scene?
I would kind of expect it to be a primnoid, but it's not one that I recognize. Let's see. Unfortunately, I've been disconnected, so I have to reconnect.
Looks like we're stopped, right? Copy. All right, video. Tell me what you need.
Okay.
Lasers off.
So bright on top compared to the bottom.
Okay, so indeed, this is from the family Primnoidae, and I've actually been really surprised that we haven't seen more from this family during the expedition. This is one of the most diverse families in the deep sea in terms of the number of genera and species that have been described.
If you put fogs, it could balance
and it has, it belongs to this subgroup of octocorals called the Calcaxonia. Those are octocorals whose skeleton is largely protein-based, but has quite a high amount of calcium carbonate deposited in it. So the bamboo corals, the Chrysogorgiids, and primnoids all belong to that group. And so they have pretty stiff skeleton. You can kind of see that here. It's not waving very much. Primnoids are the ones that have the scale-like body. So yeah, if we could take one of the branches of this, the branch point itself isn't hugely critical. It's not like this has nodes.
Yeah.
But it would be nice just to be able to get a piece of it if possible.
Can I get a small piece and put it in the suction jar? So we don't take up a box?
It's not very flexible.
Okay, understood. We'll put it in a box.
Yeah.
Do we have all the boxes open?
Go full screen.
Yeah, we have no bio yet.
Copy.
Get lasers on one more time.
Get with the base there.
Yeah, we can see the holdfast probably about 5 centimeters across. I'm looking at the white part. It might be even bigger. That's slightly browner, maybe even 8 centimeters apart. The two laser dots are 10 centimeters.
See how to set up here.
Pilot, I'm kind of anticipating you grab something from the top there that's sticking up, or is it easier for you to go down low?
You said lights off?
Probably top.
Yeah.
It might take me a second to sit down, though. But yeah. I'll start setting up.
You get set up, and then, yeah, we'll confirm.
Sounds good.
Yeah, the last move ended 17 or 18 minutes ago, so should be stationary, Copilot.
Copy.
Laser's clear.
Copy that. Laser's coming off. So I think I can grab it and then I might just hop up to the flatter part to open boxes. Sound good, Kaput?
Yeah, sounds good.
Okay.
I can watch it down here. You look like you're clear on kind of all directions except forward, obviously.
Yeah, copy that. All right, our hydraulics up.
We're ready.
All right. Arms come live. 3, 2, 1. Arm is live.
So while the pilot's setting up here, I'll just reiterate. So this is in the family Primnoidae. I'm not certain what genus. I can try to look that up. But what's so remarkable is the size of it for this depth.
Yeah, watch it. If I just go for this top piece, is that?
Yeah, the top. I prefer the top piece that has a branch point in it. You see, it's the one down from the topmost one. I don't know if you can slip in there or if that's on the back side.
Down.
Yeah, so I'm looking at that top
so like
curvature.
Top one goes
Yeah.
like
Just below it, I see
Right
there's one
below
that's
it.
got a bifurcation in it that's not too deep. But just go ahead and take.
Okay. Let me get closer and let me know what you think.
Sure. I can't tell from the 3D nature if you would have to go in behind. Or I also don't have a good sense of the size. Yeah, I'm looking at this. Right there. You see it? Yeah, all three are. Yeah. Yeah, that's perfect, pilot. Right there.
Kind of like that.
Yep. And that should cut pretty easily. It'll come up in 2 pieces, but that's okay.
Is that what you wanted?
Yep, exactly. So what you see is it's coming in 2 pieces. We got 2 different branches, but the lower one, or the one on the left, you've got the branch point as well. So that's great.
Okay.
Thank you. Looks like there might be, I don't know if that's a brittle start in the end or one of those radiolarians. I think it's one of the radiolarians that floats by.
Do you want to get a quick zoom of this video and then we'll kind of reposition for box?
Another thing about Primnoidae, you can see here nicely in this close-up, one of the characteristics that you use is whether the polyps are oriented up or down. These are all pointed down, and that's a great view. You can see that there are lines going from the end of the polyp down towards the base, and what you're seeing are the edges of the scales that make up the base. They almost look like a series of rings. And even the tentacles have their own little scales on top of them. It's very much like a suit of armor in this group. Great view. Look at that, those polyps at the end. You can see that really clearly. I wonder if this is a Neurella. I'm seeing 3 rows of scales. We could almost identify this from this in situ video. It's so good. 3 rows of scales, and then there's some upright ones that are associated with the tentacles themselves that are called opercula. Thank you. That's great.
Okay, so yeah, at this point, I'm just going to move a little bit so we can open the drawer.
Understood. I did have a request from Short of look at something else that's in that area, so let's not go too far, but I understand the
Copy that.
operation. Thanks.
Understood. So, Kobai, can you put up Sirius cam again? So I'm just going to hop over here real quick. Sorry for the dust. push forward a little more, see if I can get altitude lock. Otherwise, I'll just kind of set down.
Sounds good. Right there, you're getting bottom lock.
Copy that. Let me see if that holds. Okay, looks good. I think this will fit in the starboard inner. It's kind of long.
Starboard inner.
Or starboard outer. I'd have to like...
Yeah, it might be kind of tricky to like...
Versus...
I guess you could rotate jaws, but... I don't know. Probably just put it in a port.
Yeah. Okay. I'll go port side.
Copy.
And then you can put your... When you're ready, your mini suits back up.
Okay, so pushing roar out. Are we ready for that?
Yes, sir.
Okay, out all the way.
Nice.
Give it a second. Okay, you can go ahead and close.
All right, great. So you can see one of the things that's kind of challenging about that coral we just looked at,
Thanks,
one of the things that was interesting was the branching point. And what I just saw there is the, after it branches, then it grows for a very long time before it branches again. And so that actually created a bit of a challenge for the ROV pilot because it was so long that it gets a little bit difficult to maneuver into the bio box. But did that very nicely, so we have that collection in port outer. Thank you, pilot.
Yeah, of course. Okay. Arm is off.
Okay, changing the monitor. Are we keeping mini SUS up or down?
I'll put it up. I had it down for the sample. Just put it back there. And then you want me to backtrack a little, Watchley? There was something of interest?
Yeah, so I unfortunately was keeping my records here, so I didn't notice. I saw when you were stowing that there's a bamboo coral on the left, but I'm not sure. I've just asked Shore for clarification on what else they wanted to see. But
okay, do you want me to just kind of move back and
sure.
give a general?
Yep. Thank you. I would, pilot.
Port outer, right?
Copy.
Yes,
yeah.
O2B.
There's a really good indication here of how fine the sediments are. This is basically from the thruster action. We have some of the sediments being moved up into the water column, and they're really, really small particles, and so they create these clouds.
Yeah, not much current down here, as you can see. I kicked some up a little bit ago, and it's just kind of hanging around.
Yeah, that's another good observation. So pilot is noting that there's not very much current. If the current was really strong, then this would essentially be quote unquote blown away or moved out of our field of view. But the fact that it's hanging here is telling us that the currents are not very strong. So on shore, they're saying it was to the right of the fan that we just collected.
Copy that. Just back up a little bit.
We're getting kind of a different view of these pillow features that Ashton has been discussing so much. You can see them from the top, arranged in these linear fashions, and now we're getting to the front side where they're cut. It must be this one that's just come into view. It almost looks purple. I wonder if, is this what you mean, Asako? Yeah, it must be, because there's the large one we just collected off to the left. So just below the lasers now.
Copy that. Getting closer.
This one's going to be a tough one to image because it's growing out the rock towards us.
Yeah, I can try to get low and kind of look up.
Okay. So another thing I'm noticing, you know, as we're changing our position in the water column, for me, the distance to the coral and the amount of light that we had on it, the lighting changes a lot. And so, you know, your initial instinct is to call it something based on what you think it is, because, oh, it's got this color and this shape. And now, as I see it better, you know, it's clearly white and not blue or purple.
Good video, you want to come in?
I'll bet this is another primnoid octocoral. Again, the primnoidae are really common in the deep sea, and when we get really deep, they start to take over.
This is it, right?
Yep, this is absolutely it. And so again, notice all the polyps are kind of droopy, and they're drooping downwards. And if you look at the bases of the polyps where they're attached to the skeleton, they're coming off 3 or 4 together. That's called a whorl. So this is another primnoid. I don't know that it's the same as the one we just collected, but there you go. And so Ashton is back, perfect timing. We just finished with that collection. We got it stowed, and you are ready to resume your journey.
All right, let's make waves.
Thank you, pilot.
Copy that. Video all set.
Yep.
Probably nothing too good with all the dust. All right, we'll keep moving forward.
Yeah, and let's lay some tracks and move at. I would say almost move at the speed you feel comfortable with.
Pilot.
Copy that. We'll do that. Yeah, let's get ahead. So nav, what general directions? Just kind of.
Oh, that's a good question. I think it'd be good to characterize kind of this step before we know exactly, but I think for now, like southwest is good, so 240 or something like that. Waypoint 2 is pretty much, yeah, 235, 240.
Copy.
Yeah, I mean, it looks
clear, yeah.
Yeah, can I do 30 meters, 240?
Sure.
And then recalibrate?
Yeah, let's do it.
Okay, great.
And so if you're just joining us, we're coming up on this flatter portion of the first little hill before the large rise of the slope that we're going to be ascending.
Okay.
So I expect it to be much more sedimented for the next 20 or 30 meters while we're on this flat portion until we get to that hill. And we'll probably try and make up some ground and try and get over some of this quickly. You can see in the bottom left some of this crust of those pillow basalts I was talking about, how when the pillow basalts are formed, there's an eruption underwater on the surface. Yep. And that pillow forms by lava flowing through a tube-like structure, almost a big lobe. And we saw some of those elongate pillows. You see one of these elongate pillows in the foreground. And then sometimes that lava, it breaks out into a new little toe of a pillow, and that evacuates the lava that was in that currently formed one. And so what you do is actually get an evacuation of material. But that harder outer surface had already been cooled and quenched by seawater, so it forms this beautiful crust. And so you get these features that almost look like they're little hollow eggshells of lava. And then another one of these sponges on the lower left. I think we saw one of these earlier.
We maybe tilt up on Sirius and sort of zoom in since we've got a nice side shot.
And so one of the really interesting questions is we're definitely on some type of pillow volcano, and it doesn't look to me that that what we're looking at has formed or has been exposed through a faulting process. So we're not seeing the same type of highly fragmented pillow basalt outcrops that we saw on some of these previous dives, where everything looked more fractured and broken from just that shearing force of the faulting surface. It looks much more in place. It looks much more like a nice stack of lavas. Now, of course, the entire upper portion of the oceanic crust is pillow basalt, so you can imagine the first 1 to 2 kilometers, or the first mile of oceanic crust are actually erupted pillows that have just been erupted on top of each other and on top of each other. But in those previous areas, we were looking at places where that crust has been fragmented and moved in a faulting mechanism. So you can imagine the same type of faults that form large earthquakes. Here, I don't think I see that. What I see is actually just that primary exposure of pillow basalts. And so that looks like that one of those little crusts of that outer pillow basalt surface that's been tilted over.
It's a jelly to the left.
Lots of little brittle stars on it, and then the jelly.
Snap or wait for serious. Yeah, you can see how light the current is. He's moving pretty slow.
He's not moving at all.
A little bit.
Nice. Totally still.
Yeah, the current. You're also listening to our ROV crew. The current looks pretty still. This jelly doesn't seem to be getting moved around laterally in any opposition.
Light on the thrust.
Kind of just
to kick up,
beautifully floating.
Dust. That might be a little slow.
Yeah, so I'm definitely moving now. So maybe like 4 minutes.
Okay, good.
Having to both iris and focused. Beautiful float. Good job, pilot.
That was all truck. All right.
I saw some dolly.
Whenever you're set, video, let me know. No, kind of move away.
Video's clear.
Okay, we'll keep moving. Laser's coming back on. All right, copilot's moving.
Yeah, it's quicker than I thought it would be.
Yeah.
I mean, it's hard to tell because we're still heaving, so I was looking at that rock right there, and it's almost out of view. Yeah. But I think we moved a little bit, although I'm seeing it again, so not sure.
And it's amazing to me just how quickly the exposed seafloor changes from when we're on those slopes where we saw all those beautifully exposed pillow basalts to this flatter portion, which is just much more blanketed with these marine sediments.
Pilot?
Hey, Nav.
Co-pilot?
Hey, Nav.
Sorry about that handoff earlier, Sean. Didn't put you in the greatest spot.
No, this is great. Yeah, we have a 30-meter move in.
Understood.
I think Sirius just started.
Go ahead, Rich. Understood.
Yeah, we're definitely moving now, for sure.
The ship is all stopped, pilots.
Copy. So maybe I would say maybe 4 to 5 minutes.
Copy that. If you just start moving.
Yeah.
It's not bad.
Gonna rotate down. I'm gonna come back up a little bit.
You got this nice big flat step here, huh?
Yeah, we're just kind of pushing forward.
Traversing it.
Yeah. We're just going to go like 240.
Understood.
Find the next slope pretty soon.
So the offset was about 30 meters from when we acquired bottom.
Is that offset is in depth?
No,
to belay that, it was about 15 meters in depth, yeah, from what we were seeing on HAPAC to what we're actually seeing.
Okay, it's not bad.
So right now, turns. You're almost...
So Sirius has a full turn.
One turn, yeah. So I would have to like go to starboard, full turn, and then
port, full turn. You need to put negative in right now to zero out.
Yes,
that.
You're right.
Yeah.
Port, full turn, and then you have to do. So I go like this. It's like if you were going like this.
So you do that.
So you have to do.
And so again, we're just on this,
I guess, just half
lower to port hill feature.
That would put me at a positive. So then I would do
half to port.
Yeah, you got it.
Lower slopes of this much larger, likely pillow volcano. And this entire pillow volcano that we're looking at.
I was right the first time.
It's about
30 meters.
It's about 200 meters high, and it's
maybe coral to the right.
Yeah, I think it's just at my reach.
Maybe a quarter of that is new construction, and then a lot of that is probably partially exposed old pillow basalt volcanism. It's hard to tell just based off of the bathymetry and our limited visual observation that we're able to acquire when we're diving. So part of that will also can be told when we get geological samples and we hopefully age date them. And right now, since we're on this flatter portion, we're just in an area where much more marine sediment has an opportunity to accumulate. And so that's that white background that you see. That's all likely primary calcareous sediment. So sediment that's derived from marine organisms in the upper water column in the photic zone, producing calcite, that's calcium carbonate, structures as part of their exoskeleton, so their tests and their shells.
Well, actually, can we snap on this real quick, just while we're waiting for Sirius?
Is that a question for Watchley?
Yeah, Watchley, did you copy that?
Yep, go for it.
Okay. Go snap real quick video. This is
full screen.
Got that? Sounds good. Then when did that move end now?
That move ended 4 minutes ago.
Copy that. So let's see. Do you see anything in sonar?
I don't see anything on blue view, sonar, nowhere. There's
Okay.
nothing.
Do you want to do another 30 meters?
I would be fine with it.
240.
Understood.
Got some
Bridge RV
associates
now.
on that coral.
Hey, Bridge, I'd like to request a ship move, please. Range 30 meters, bearing 204 degrees, speed 0.2 knots.
I'm going to explore this edge to the left real quick, see if there's anything.
And so if you're also listening to our
degrees.
ROV channel, or the audio, the way the ROV moves is it's a two-body ROV system. So there's an ROV that's driven by our ROV pilot, and that's the ROV Deep Discoverer, where you're seeing the video from right now. And then there's a second ROV driven by our ROV co-pilot, Sirius. And the ship moves, and by moving the ship, we move Sirius, which is attached to the ship through a near vertically downward cable.
Oh, video. I'd be latched. You made it unlatched.
And then from Sirius, to Deep Discover, there's
yeah,
a
by
tether,
default, you guys shouldn't be listening to me
Deep
because I'm
Discover
talking
can
to
move
a bunch of people.
within a radius
I'll
of
always
that tether
interrupt
around
you guys
Sirius.
when I want to talk to you.
And so right now, we're kind of on this flat area, heavily sedimented.
Yes, I'm
we're
always
using
listening,
our
so
ROV
you don't have to have me
forward-looking sonar to look for hard returns, bathymetric structures that might indicate the beginning of that slope. But you can imagine, in order to move to that slope, we have to know where it is, because we can't move the ship too far or too quickly, because that will move Sirius too far or too quickly, and that can potentially move Deep Discover into a place where, you know, it goes somewhere it doesn't want to do. It goes right into the slope. So what we do is we slowly move.
I think it's a good idea what you did
and
when
slowly
you were
move
sampling,
Sirius
to put up the
until we can see the return of that slope in the forward-looking sonar. And then once we know where that slope is and how far away from it, we can kind of pick a place right next to it and move safely to it.
At the same time, so
working in areas where there's really hard, really large vertical relief is especially always a little daunting, and it takes some excellent ROV pilots. There's another one of those little small black fish on the bottom left that we saw earlier. I think we've seen 3 or 4 of those now. Yeah, I think so. Yeah, I think we're just on the top of this little hill that sits at the foot of this larger slope that we are going to try and zip up. Yeah, well, I want to get to the top. You got to think about where all these volcanic pillars come from.
Can you zoom out a little bit now? How far are the waypoints, or where we're heading to?
I believe you are 200.
Okay.
I'm not sure what.
I mean,
let me see what waypoint is being selected. Yeah, stand by.
463, but where's that at? Okay. And then is there like a waypoint 3 and 4 and 5? Okay.
It's a 3.
3's at the top.
Yep.
Okay. All right. Thank you. So 463. Quite a ways off.
You want me to just roll another 30 as soon as that move's complete?
Let's leave a couple minutes in between.
Understood.
Just so we don't stack too many.
So if we can trust the bathy, it's about 150 meters of flat on this step here.
Copy that.
Go ahead, Rich. Good copy. Thank you, Rich. All right. That move is complete. Give it a few more minutes.
Yeah, sounds good. Do you want to put Cirrus sonar to 80 meters out? See if we can pick anything up.
So he put it yesterday at 385 kilohertz. How far actually can we trust like those readings?
So I think that's just. I think those are occurring because it's a lack. It's a lack of returns.
Okay, so but you think if we see something at 60, like we can trust that it's there? I guess.
Yeah, if we got like a bright return, I would trust it.
Okay.
Based on what we've been seeing this cruise.
All right.
This though is just all this is yeah. Kind of does that, but it just can't find anything.
Okay.
It kind of colors it in that way. So looking, let's see, that's straight west.
So this little thin little valley-like feature that's just below us is kind of interesting. There was kind of this long trench that we've kind of been going over for a little while, and they're kind of almost like little pillows, fragments that have fallen into that. And that looks like it almost looks like it might be a little fault plane, a little fracture surface. And so if one of the deeper falls off is
are you guys actively using
our
the blue
left
view
side, then maybe this feature is
pointed straight out, trying to find some type of slope.
Yeah, maybe this feature is part of this failure surface.
All right, so I should be stopping like within 30 seconds or so.
Yeah, we gotta figure out what to do next. So let's see.
It's actually dropping.
Yeah.
Okay.
So this is I'll line up with you.
So if we range out the blue view, it's already 60.
70, see if it picks anything up.
So for situational awareness, at least in the 3D scene, it looks like we're near the top of a hill, and it's going to drop off everywhere around us until we get to that next larger slope. So we're not necessarily on a flat. We're on a little hill. Yeah, it goes back down until it hits that slope and goes back up. And so what the ROV is doing right now is it's kind of just looking around, and both visually but also with its forward-looking sonar, it's trying to find where that slope is ahead of us, because we want to know where it is, but we also want to know how far away it is, so that we can move the ship appropriately.
Hey, Washley, so yeah, we're just kind of discussing what we want to do next.
Yep.
We're kind of you see it's kind of dropping off here.
Yep.
This is the direction based on bathymetry, the way we want to go. But it looks to just drop off, and we're not picking up anything in our sonars yet. And based on HYPACK, it's the next slope, it would be too far for our sonars to pick up. So the only thing we can think of is just keep pushing forward in blue water, and it might just be blue water for a little bit till we get to the next slope.
Yeah, that's perfect. That's kind of what I was expecting looking at the Fledermaus scene. Looking at the 3D, it looks like it's it might be 100 meters from the top of this hill to the foot of the slope.
Yeah.
And maybe even depending on where we are, maybe 100 meters of lateral blue water. But yeah, that's kind of what we're expecting.
Okay, sounds good. Just want to give you a heads up before we enter into some blue water for a while. All right, so yeah, let me line up center with you, co-pilot. I'll put auto depth in, and I'll come up just a little bit, and then do you want to put your camera at 45, or you're roughly there?
And so if you're just joining us, you might see us staring off into this murky blue abyss of the deep ocean. And that's because we're at the top of this little hill that's at the foot of this larger slope that we want to explore. And so we are going to jump basically through the water horizontally from this hill until we see the slope ahead of us. So we're kind of just, you can imagine us just kind of hovering across from this hill to the next slope instead of staying on the bottom. So
and I'll just try to stay center with you.
We're going to see kind of just what we call blue water,
at
just kind of the water column, for a little bit while we do this transit.
Head changes.
Bridge, are we now?
Keep lights as is.
Hey, Bridge, I'd like to request a ship move, please. Range 30 meters, bearing 240 degrees, speed 0.2 knots.
Now, the ship is moving right now in about 30-meter increments in the direction of the slope. And we're probably maybe 100 to 120 meters away from the slope horizontally. So it might take 3 or 4 ship moves until we get to that slope.
I can't hear you.
Now, hopefully, within
were you gonna say
2 ship moves,
something on
we should hopefully see it within in the blue view.
But it's not going to be a mid-water thing.
And so that blue view sonar that we have,
I don't plan on rotating.
It looks up to about 80 meters right now.
Light, so I think they're fine.
And so for 120 meters away,
and then just kind of
translate
translate
like 30 meter ship move.
Very much doubt it.
It might be on the fringes of our next.
I doubt it.
Our next move.
Well,
have some optimism.
I mean, like before the cliff, well, it dropped pretty steeply, right?
Yeah.
Like the one before it.
Depends it depends. Yeah.
I mean, if it goes past, well, this would be a good test.
Right?
Yeah. Although with sandy bottom, I don't expect like good return when it's farther than maybe 20 meters, but we'll see. So that was a 30-meter move?
30.
Copy.
How fast, Sean?
At 0.1 meters per second, stepped in.
0.2?
You want to try 0.2?
0.2.
Engaged.
Yeah, watch it for reference. That's referencing the ship's actually moving. Ship's moving what, 0.2?
It is 0.2.
Okay, yeah. So what we were just talking though is the autopilots. We can engage with the vehicles. They can be good with in situations of blue water like this, where we can still maintain an altitude lock, and then we can kind of set in a step size, which is a distance, and like a step rate, which would be like a rate of travel, and then kind of use that to maneuver, as opposed to manually, which is what we traditionally do.
Yeah. Autopilot engaged. I like it. Let me try that.
The secret is we've been in autopilot this whole cruise. We don't advertise that.
Science autopilot engaged.
That's right.
That's when you're supposed to just start talking, Scott.
Well, but I'm not sure what the auto mode is.
No.
It could be that I'm in deep thought and relaxing.
I thought it was you pick your favorite sponge, and then you tell us it's taxonomical breakdown starting at the very top.
That is definitely not it, but I can tell you this. Here's something that Ken Sulak chimed in about earlier. So Ken Sulak, formerly of the USGS, now retired, expert on deep-sea fishes, and at about, let's see, a couple hours ago, just before lunch, we saw that rat tail look like a big head and a long tail. And he said that looked a little bit like Coryphaenoides rupestris, but it's too deep for that species, and the coloration does not match. So another possibility is the genus Ventrafossa. It's the first time I've ever heard of that genus. That also has a rounded head and a long tail. But there are no species in that genus known from deeper than 1,200 meters. So he said that is a species that he does not know. I don't hear Kent say that very often.
No, I was going to say, that's the first time I've seen it on this cruise.
Right, but he gets back finally to the theme that we said many times. That's not surprising for him at this depth because there's so few observations so deep here. And we've been saying that about the sponges and the corals. And so while you said this well before, actually, at the start of the dive, the average depth into the Atlantic is about 3,800 meters. The average depth for the ocean overall is something like 3,682 meters. And we're at 33, which we're considering very deep, but we're not even at the average. The ocean is a really deep place, and the number of dives that have been able to take cameras like what we have to get a really good view of the in-situ fauna is relatively low, so we're all still learning. And in fact, Cindy Van Dover said something really interesting earlier. I had made this comment that
you can stack those as well, right?
Perhaps we don't need to spend as long on the zooms of the holothurians because historically we have collected a number of them by using benthic trawls, the trawls over the soft sediment that bring these up.
It'll kill that.
But she's very correct in saying, but they come up as squishy blobs that have been put in formalin and ethanol, and we look at the museum, they've lost all their color and so on. So, and she's absolutely right. So translating what we know from, Challenger expedition trawls that were done in 1872 to this fantastic imagery that we have now is difficult at best.
Yeah, I hadn't appreciated that point about color either, because you were saying that a lot of these things that you bring up and preserve in ethanol or formalin will lose their color, so you don't get an appreciation for just how beautiful and colorful the bottom of the ocean is.
Yeah, I don't know if you noticed, if you saw the letter I sent out last night, but I put in a photo of one of the plexaurids that we collected, and now that ethanol is this beautiful blue color, and that has been leached out of the polyps. So some of these pigments are... what's the word I want?
Soluble?
Thank you. That is exactly the word I want. And others are insoluble. They're bound up in the hard parts.
Lost autos. Darn. It's fun while it lasted.
How far off the bottom you actually get bottom lock? You've been getting bottom lock?
I've been picking it up intermittently, but
solid,
strong signal, like 99 meters, which is great.
Okay. So maybe try to engage them again. Maybe they will hold.
When did that move in?
Or 30 seconds ago.
Copy. So yeah, we'll put another one in. Like 3 minutes.
Understood.
I think that should space us out pretty good. While still moving forward at a quick rate.
Hey, Blue, don't be afraid. We'll see sea floor eventually.
You needed one more word in there. Apparently I missed, Dupashna Ganguly just pointed out, I missed a comment that she made. You had asked me before about the rock pins, and I was telling you about where we saw them. So she says most rock pins have been observed between 1,000 and 2,000 meters, and unfortunately, Auto Refresh just took that away from me. I'll have to scroll back up and find it now. Okay. 1,000, 2,000 meters. The deepest one ever seen was at 3,800 meters, and there goes the auto refresh again.
And yeah, watch rates for reference. D2 is about 23 meters above the seafloor right now.
Thank you.
And I've been maintaining the same depth, so it's a significant drop off, if that's of interest.
So that was 3,800 meters that we saw in the Atlantic last year, and she says that the deeper observations of rock pens are all from the Atlantic rather than the Pacific. Thank you for that.
D2 sonar out to 82. See how it does.
I believe like one of those we just didn't trust it past like 50 or something.
They've been pretty good this cruise.
Okay.
I think this one on the higher frequency did better at closer up items. With the lower frequency. Yesterday at least it seemed to pick up.
I don't remember how how far were those though yesterday.
We had it at 80 yesterday and we were picking stuff up. You
oh
saw
really?
It.
Okay.
Yeah,
I remember seeing it, but I just don't remember the range.
Yeah.
All right, pilots, you want another?
Yeah, let's do it.
Yep. Bridge, RV-nav. Hey, Bridge. I'd like to request a ship move, please. Range 30 meters, bearing 240 degrees, speed 0.2 knots.
And so the ROV team just put in another ship move for another 30 meters towards the slope.
So it's been
and I'm going to guess that by
25.
near the end of this slope, or maybe the middle of this move, maybe near the end of it, we might see something on the outer range of the sonar.
Got it.
So there's a might and a maybe and a probably in there.
Which means
so
you're predicting there's 2 more moves maybe to that slope.
Yeah.
Yep.
I'm going to move the mini Zeus a little bit down.
And so if you're just joining us, we are on the Kurchatov Fracture Zone in the Mid-Atlantic Ridge. And this fracture zone is a right lateral step over in the north-south running trend of the Mid-Atlantic Ridge. And so if you're on the southern segment
40 meters down
of the Mid-Atlantic
at
Ridge,
that angle,
looking northward,
makes sense, right?
you would see the entire length of the Mid-Atlantic Ridge step over, move over about 20 kilometers to the east, right? So by right lateral step, I mean you see that Mid-Atlantic Ridge move to your right relative to your position.
We don't see anything? No.
Now this fracture zone is about 20 kilometers wide or long in the east-west direction, separating these 2 segments. It's called a ridge transform intersection. And we're right in the middle of this fracture zone. And what's interesting about this fracture zone is when we think about fracture zones in general, we think about transform faults. We think about faults that move between 2 surfaces in a direction parallel to the strike of that plane. So you can think about like the San Andreas fault. Now what's interesting about this is there might not actually be much transform motion along this fracture zone. And it's been referred to that it actually might be a source of new volcanism itself. It might be leaky. It might have volcanism that's coming up in the middle of it. And so we're exploring we started on one of the deeper portions of it at a depth of about 3,340 meters below sea level. And we're going to try and get to the top of this large slope that looks to be a large pillar volcano.
50 meters off the bottom and still
at shallows about 3,130 meters below sea level. So about 210 meters of rise. It gets quite steep in some places. It's almost up to 40-ish, 45 degrees in some places. And we just got onto the top of a small little hill on the base of
I wonder,
this large slope.
With the 80 CP,
and now we're jumping
you can have
from the top of this hill
bottom block,
to the
so
steep section
where
of
the
the
bottom
slope.
is, but you can also see
flying through water column.
Like bins in the water, how fast they're moving. So
we're currently at a latitude of 40.
I don't know if you could like look at a certain
degrees north.
Bin of water
longitude of
and have that as the reference and see how you're
west.
moving against it. So pretty much have like arrow XY when you're not looking at the bottom. I don't know if that would be possible.
Oh, so essentially you're tracking the particles in the water?
I think that at least that workhorse, like there's a mode you can put it so it looks at the water column and it sees.
Oh, that'd be cool.
So I don't know if...
Yeah, if there's enough, I mean...
Yeah, I don't know how accurate it is, but... So you would put like auto depth and then track a layer maybe 5 meters down or something. And well, if there's current, then yeah, there you go. So if there's current, then it's gonna do who knows what.
Yeah, the water column itself looks incredibly still right now. You don't see any pervasive currents in any one direction.
Standby one.
Just curious what kind of
layback
we're at getting.
About 30 meters.
Copy. So that's great. Just move of layback. So we can expect that as we approach slope.
What did you collect earlier, Sean?
Coral. Starboard, port outer. It's kind of long, this is a little awkward. Went in nicely though.
Go ahead, Bridge.
Correct. Depends.
Good copy, thank you, Bridge. Ships all stop pilots.
Depends how much time we have too. Right? If we have for a wear and we're in a situation like this with just blue water with no hazards, we could take time and like set up correctly. If we're in a rush, you could you could ignore the 6-8 turns into 6-8 in an emergency, and then just focus on turns in the tether. Or not even turns in the tether, just purely focus on streaming. Right, where you could just turn and leave it like that, and then we're in tow. Because also, if you turn right now, let's see, we have a negative. So yeah. It's not ideal, but I mean, it's something the tether like can do. It's not going to be super happy, but it wouldn't like it wouldn't necessarily like risk the health of the tether. If we did that every time, yeah, we'd probably see a quicker degradation in the fiber values and have to swap out ours sooner, but good. Higher RPM. Those also don't have like a blade. They're bladeless. High RPM fans. Alright, sonars still look pretty clear. We're looking 80 meters out.
So I just got an email from
closer to the transit, but
David
USBL was
Clegg
all
at the
over the place
Monterey
earlier.
Bay
I don't know that I would adjust it too
aquarium,
much.
And he said he snipped a frame of the weird track. I had sent him a
3
video
minutes.
clip of the weird track that we saw on the other dive,
Bridge RV now.
and he sent it to their
Hi,
two
Bridge.
Mbari
Request
benthic
another shipment,
biologists.
Please. Range 30 meters.
You mean the holes?
Yeah, the holes.
Degrees,
And
speed 0
he said himself, who's been all around the world, and their two benthic biologists at Mbari have also never seen anything like it. So the mystery deepens.
Yeah.
Good copy. Thank you, Bridge.
I understand the mystery is spreading around the internet.
Yeah.
With lots of interesting comments being made and thoughtful comments being made.
Yeah, it's amazing how there are still things that we can observe that completely stump us and are
baffle.
Yeah.
I mean, that's fantastic.
It is.
It's a joy to me because it means there's still so much remaining to be discovered, questions to be asked, and says how little of the planet we've still not seen. And how little we have seen, how much we have not seen.
And to me, it's also amazing just because of how visible it is, right? It's not an unknown question in terms of some strange mineralogical assemblage or some thermal state of a rock or some strange
biochemical reaction. You have to imagine what's going on.
Yeah, you need a bunch of analyses
Inferring.
to ask the question. It's 40 feet of holes on the seafloor, right?
Yep. Mike Vecchione, who's in the chat room right now, he's at the Smithsonian Institution, and he's the one, he and a co-author had published a paper on observations of those marks from ROVs that were done in 2004 from the same general area. He says that there are similar sorts of marks in the fossil record.
I was asking if you knew what the timing looks like for the shift now.
In the fossil record, you have the ability to look at the rock. You can see the hole from one angle, but then you can also look somewhat deeper. And he says that the holes are connected by a subsurface tube.
Yeah.
So that
I think it was
adds a little bit of information to interpreting what the holes are, that something is moving under the surface and periodically poking up to the surface.
It sounded like it was likely.
Likely. Understood.
That's my professional opinion. Let's see. Well, actually, we might have something maybe 80 meters out. Still pretty far away, though. Just a heads up as far as sonar goes.
Thank you. I'm just smirking at my co-scientist because I called it. I said near the end of this, at the very fringes of the blue view, we might see something.
You're misinterpreting the look on my face because what I really want to say is something about those holes.
Oh.
But I know that I shouldn't. So.
Yeah.
Yeah, then as far as altitude relative to D2, it looks like we peaked at about 30 meters, and now it looks like it's down at 27 now. So looks like it's trending back down. So it could also indicate we're past the deepest section of this little hole we're going over right now.
Thank you. And I didn't know if it would be a question or not, but yeah, just if you could just fly constant altitude to it, no need to get further down on the slope.
Oh yeah, we're staying. We're just staying steady.
Yeah, perfect.
Yep.
We're flying at constant depth.
Constant depth.
It's also interesting to me that we actually haven't, on this short little transect of 120 meters or so across to the next slope, we haven't really seen much in the water column.
Yeah.
Right, so,
and I'm certainly watching.
Yeah.
That is true. We saw, when we were down on the bottom, we saw a couple of jellyfish, and I've been doing some corresponding with folks in the chat room. And Alan Collins, who's also at the NOAA National Systematics Lab at the Smithsonian Institution, and he is an expert in midwater jellies and hydrozoans and various cnidarians. He believes that is the genus Benthicodon. I may have mentioned that very early on in one of our earlier dives, that is a genus of jellyfish that I believe spends more time settled on the bottom. It seems to like vertical faces of rocks and then seems to swim off and land on another rock. And that would explain why we were seeing it. We were very close to the bottom. So I'm not sure why we don't see more up here. You know, we have done, we did a day of midwater transects, and we were starting our first set of transects in the benthic boundary layer about 15 meters above the bottom, and we're not that much higher.
No. At 375.
Yeah, so reference, we're probably about 26 or 27 meters above bottom right now.
Above this.
There's something white coming up, though. This might be, is this a Solomyces? This looks like some kind of jelly with its tentacles all extended. You can see, it looks to me like what's happening is it's creating a great big field. Actually, it may be a foraminifera.
Good copy. Thank you, Bridge. Ship's all step pilots.
Copy. Are those radiating out spherically?
There we go.
Oh,
beautiful. Beautiful. Jellyfish. You can see all the tentacles. This looks like the one Alan described the other day. Maybe not. That had like the sort of stiff tips to the tentacles. You can see the lines emanating from the center. The darker part of it is they're basically tubes or canals leading from the central stomach to the margin of the bell to distribute food. And then the brighter orange parts that you see just along part of those lines, those are the gonads that are essentially hanging down from the upper part. Oh, that's great video. So yeah, the gonads are kept inside in the gastrovascular cavity for producing the sperm of the eggs. And so Alan says that is that Benthicodon that we were just talking about. So that's, I think, maybe the 5th good view we've had of a Benthicodon today.
I'm glad that they make cameos right on time.
Yeah. Cue the Benthicodon. Mike will no doubt start asking questions now about cephalopods and squid.
Yeah, perfect.
Matches at 60, that's 50.
Maybe so.
That's pretty close.
Down here, you think? Yeah, should we ask? Yeah, why not? Let's be aspirational.
And I think we might be, seeing something in that blue view now.
Yeah, you can kind of see, if you look at blue view and D2 sonar, you can kind of see some soft items coming into view.
Yeah.
Yeah, those two are definitely the same. But it might be like a very shallow slope because I don't get anything here.
Yeah. Which it does, it looks like it's still pretty far out before we get anything like steep.
Yeah.
When did that move in now?
2 minutes ago.
2 minutes ago. Understood. You want to do one more 30? See if it gets us there?
Yeah.
Ready for that?
Yeah, you're still getting returns, what, 50 meters?
50 meters out.
Yeah. Bridge, RV now. Hey, Bridge, I'd like to request another ship, please.
Pilot, may I ask a question?
Sure.
As we are moving slowly through the water column here, if another one of those jellyfish is coming slowly towards us, are you in a position you can slurp it, or is that not operationally possible?
We are not.
Good copy. Thank you, Bridge.
So that's a different configuration. Essentially, we put all our lights up and different configuration than we are in now as far as mid-water samples go.
Okay.
And not while we're moving to slope either.
Understood.
If you really wanted to, we could stop the ship and do something like that. But
no, we don't want to do that because that's not the priority. Thank you. That's exactly why I asked.
Yeah, of course.
I got some information from on shore that Benthochodon hyalinus was described from the Antarctic, and so we're quite far away from the home range of where that species was described, which is why I asked that question about sampling. So perhaps later when we're on the bottom, if we see some again, we may be in a better position. Something else kind of slowly drifting here into the frame. Oh, that's a sea cucumber. Well, we're not that far from the bottom then, if we see a sea cucumber drifting by.
Looks like Cirrus is just starting to pick something up.
Yeah, so at a lower frequency I can see it. At 7 whatever I cannot.
Oh, so the higher frequency.
Yeah, like right there.
Oh, so yeah, lower frequency.
Yeah.
And then when you went higher, you didn't see it.
You cannot see it anymore. Like right there, you have like a hint of it.
Chris explained at the higher frequency, I think the angles.
And then right there,
directed
it goes
more
away.
downward. So I think the angle is slightly downward looking essentially for this one slightly, or the 3.8.
Yeah.
5 is up a little more.
Okay, so let's go back to the 300. 385. Okay, so I think I'm pretty safe even with those 30 meters. And even if we have accumulated a little bit more from the moves,
yeah, copy that.
I think I'll be good. 20 meters away.
So we're still, about 40. 40.
I'm seeing the bottom now, I think.
Yeah. About 22 meters above bottom right now, so it's getting closer.
Hey, look, it's the seafloor.
It is the seafloor. You know, I was thinking, I wish I'd thought of this yesterday when you asked the question, but you asked me about partly why it's important to have all the names of all this stuff that we see.
Yeah.
And one of the things of course, part of it is we want to be able to record keep, if you want a very prosaic way of looking at it. But I was thinking about diversity a little bit more. And we've been talking about some of the things different species do. And part of the interesting point is that every species every taxon that has been shown to be a different species and has this formal name has a different biology, has a different physiology, has a different way of making its life, perhaps eating, interacting with other organisms. And so the understanding of that diversity tells us something about how the world works. And if you want to be real practical about it, shows other things we may discover that a species has that might be of some use in whatever endeavor.
But maybe not more than that.
So I think that's part of the importance of it as well.
Okay.
All right, so now I got another strange question for you.
Yep.
Okay, let's say we went to another planet and we discovered life. Do you think the first attempt would be to try and and let's say it's similar to ours in terms of, it needs some type of photosynthesis, it builds maybe a carbon-based structure. Do you think we would try and classify it within our current taxonomical system, or would we develop a whole new one, or have people even thought about there? Are there exobiologists who sit at home wondering these questions late at night?
Sure. So there's 2 points to classification and systematics, and one is just organizing things. So give it a name, and it would be easy for us to put a name on something that's foreign, and you're sort of more or less done with it.
Yep.
The more interesting part of that is the systematics part is understanding where did that thing come from and how does it relate to everything else we see. So what I would see is somebody would want to answer the question, does that life have any relationship to the life on Earth? Can we trace back far enough in history to know if we had a common origin on Earth, on the planet we went to, or on some third planet? So I think that's where we would go.
And we could potentially do that through DNA sequencing? Or
Absolutely. Assuming it was a DNA sequence-based organism or even a carbon-based organism. And if it wasn't, then we would have to develop a whole new classification scheme based on whatever hierarchical nature of how that set of species evolved. I mean, they should follow the same rules, If you survive, the characteristics that you had that allow you to survive should be passed on. That's one of the definitions of life, is that there's a set of instructions that gets passed on to replicate that life. So I think whatever basis that life took, it should follow that model.
And now, I don't really know anything about genetics.
Me neither.
My little
genetics.
My little brother's a PhD biochemist, microbiologist, and so he studies.
You have to listen to him more at Thanksgiving, it sounds like.
He studies a lot of genetics and epigenetics, so not necessarily what the genetic structure of something is, but what genes are turned on and expressed. So do you have similar things in the deep ocean in terms of how there might be differences?
Well, there are certainly epigenetic markers in deep sea organisms, for sure. I don't think we understand a lot about yet, simply because these are hard organisms to collect, right? And so let's work with what's a little bit easier as we fully understand. Epigenetics as a field isn't all that new, a couple of decades. We're making a lot of advances now in how we can understand it, but for those of you who aren't, this is a new field. Basically, if you think about DNA, which is a deoxyribonucleic acid, it's a series of nucleotides that are put together that can be read kind of like words in a sentence that provide instructions. And there's a biochemical basis for translating those instructions into proteins. Epigenetics refers to other small chemicals that are attached to the DNA that affect how the DNA is read, or if it's read, if it's expressed. And it's I still don't know enough, I don't understand enough about the way that they are passed on. But the interesting thing about it is I know that you could have epigenetic markers added to your DNA during your lifetime. And if that's passed on, that means a change that you acquired is actually passed on, which is kind of antithetical to the way we've thought about evolution for a long period of time. So absolutely, that's going to be going on in these organisms. They have the same kind of DNA, but I don't know the extent to which they're used.
Maybe some young kid watching will get excited and become a deep-sea epigenetic biologist.
Absolutely.
There you go. That's one to convince your parents to become.
I just had a student, Lauren Walling, who graduated with her master's last summer, I believe, and she was really interested in epigenetics. And I said, well, that's just not something I study, but if you're interested and you can think of a way to ask a question and answer it in this lab, let's do it. And she did. She came up with a great question. Nobody had ever looked at it in octocorals or deep-sea octocorals before. And so she did her thesis establishing that, indeed, these octocorals do have these epigenetic moieties, and we could quantify them to some degree.
Nice.
Yeah.
Very interesting.
Great. She's now in a PhD program in Florida doing more work on epigenetics.
We have sound velocity up.
Good for her.
Well, and there's the slope we've been looking for.
Yep. Let's see more rocks, a little bit more sediment, another sponge.
So more of these, what I think are actually in-place stacks of pillow basalts. I think there's some fragments in there, but you can see that a lot of these bulbous and lobe-like structures don't look heavily fragmented. They don't look like they've fallen down as a rubble pile. They just look like they've been built there as a stack and then draped over with sediment. Another way we can tell that they're likely in place is we can actually just look at our 3D bathymetry scene, and we can look at the slope
What do you have for
of these areas. And these slopes tend to be about 15 to 25 degrees. And that's the typical slope that we expect for lava that's erupted underwater. On land, like in Hawaii or in the Azores, when this type of lava, basaltic lava with this composition and this silica content is erupted subaerially, it's fairly fluid, and so it tends to spread out much more. It tends to spread more like hot, runny pancake syrup, right? Spread over a pancake. It'll flow over the entire pancake or the entire background environment, and that tends to have slopes of 2 to 6 degrees. 3 degrees is a good ballpark for the angle of the lava that it'll build a feature of subaerially. Underwater, that surface is a lot thicker, it's a lot colder, and so it tends to stack up and get a little higher angle. If we're looking at features that are built off of talus, then we kind of look at something called the angle of repose, and that's the kind of the natural angle that a slope will build up if you're just piling on loose, unconsolidated material, and that's significantly higher. That might be 35 degrees in some areas, 40 degrees. So, looking at those three kind of ranges of slopes, we can tell, is this a primary surface that was underwater? Is this a primary surface that was subaerial and within the air? Or is it just a talus slope field?
Oh, that's really interesting. It gives me some better insight into how you can look at these maps and know something or predict something about the geology or the origin.
Yeah, so that was actually my first master's when I was at the University of Hawaii about 15 years ago was mapping geophysically where the locations of the old volcanoes, these 5 million year old volcanoes, were, looking at variations in the gravitational field, but then also looking at the seafloor topography, the bathymetry, and looking at profiles across the seafloor to try and find out where the paleo shoreline was. So the old shoreline that represented the separation between the ocean and the subaerial eruption.
Okay.
Yeah. Sorry, Scott's pointing at WISP, and I got sidetracked for a second. That indicated that slope change between subaerial erupted lava and submarine erupted lava. That's now 20, 30, 150 meters below sea level currently.
What I'm seeing here look to be the remnants of Poseidon squeezing his toothpaste tube.
Oh, there you go.
All over the place here. I was pointing at the screen because I'm really pleased to see that right in front of me there are at least 4 large coral colonies and a fish over the side. So we've jumped over to this slope, and it's nice to see that we're essentially going to be continuing what we've been observing earlier. It's good stuff.
Yeah, we're almost there, watch it.
Yep.
Are we there yet? That was Scott, not me. I mean, that was Scott. Me, I, not Ashton.
Another sea cucumber.
All right. I'd call this pretty good. Yeah, we're only 4 meters off bottom, watch lead, so I think we can start again.
Yeah. Let's grip it and rip it. Fun it and gun it.
Ship's still moving
Unless...
Keep,
No, we can go. Yeah, this is all stuff I think we were seeing down below. I was just looking closely there because I was noting that there's a lot of stuff in the water column, right? We got a lot of marine snow, but we've heard from the pilots, and we can kind of see it ourselves, that the current isn't all that strong. But I guess that's why there's so much sediment on the seafloor. It's sinking down instead of being scoured away.
But then again, it goes back to that question of, what's kind of maybe the primary influence. Not necessarily that there has to be one, but you can look at these pillows, which look like they were, more or less erupted in place here, and they're not covered with 5, 6, 7 centimeters of sediment. It's just kind of a light draping.
Yep.
But definitely around them. So it, some of it's definitely getting scoured off. Kind of the little local bathymetric highs, the rugosity of the surface, how rough it is.
So of course we don't know what the depth of the sediment is. Like on this part here, this could be a really deep, quote unquote, ditch, channel. The sea poke. We need a long sea poke.
You guys try to disperse the lighting a little more. It's really hot, sort of in the center, but not in the distance.
Let's see. All arms are out, so we could try to dim them, the swing arms, or dim the mains.
Maybe dim the mains. Yeah, if we dim them all, that won't give me any more distance.
Okay. That's like 15% less.
That's better. I can see further out now. I can iris up more, and the front isn't blown out.
Copy.
Copy that.
Seeing the shadow cast by Sirius's lights.
An awful lot of colonies here.
Do you want to turn them off?
One of the little benthicoton swimming by?
Just noting it in the
or floating by, drifting by. It's not actually pulsing.
ROVs casting a shadow.
Sea cucumber down there on the sediment chute. I thought when we first got down, I thought I saw feeding traces of an Echiaran worm, and I'm kind of disappointed not to see any. Here's one of the flat sea cucumbers kind of drifting. Yeah, so I'm seeing the long lines. Ashton's just pointing to the monitor, noting that if you look on the sediment surface, you can see some areas that are lighter, and it's like somebody has drawn a line in the sand, and those would be the tracks of the sea cucumbers that are sort of moving back and forth and ingesting the organics, and as they ingest it, they take off the upper layer of sediment, and so reveal the underlying sediment, which is slightly lighter in color. And it's another good representation, actually, of what is the rate of deposition, that those trails haven't been covered up very quickly. You can see they're pretty extensive over here, and the sea cucumbers aren't moving around that fast. But what I had seen earlier was more like from a single point radiating lines from it. And it's a very characteristic trace of an Echiaran spoonworm, which burrows vertically down into the substrate, but then sticks out a long sort of tongue or proboscis, and sort of scrapes off the upper layer of food and brings it back to the head. Wow, if we look right in the center there, it's coming into view, if you could put the lasers on, I think this is another one of these really tall asbestopluma sponges. It's a really narrow stick standing up. We saw one earlier. I've never seen one quite so tall. There you can see the lasers. Yep, you got your lasers just about on it.
Come in a little bit.
So we're not going to be able to get the lasers on the sponge itself, but just to get some sense.
Aim at the base there.
Yeah. So, we'd sort of have to turn those sideways and go up the stem.
Actually, let me just move in. Some tether.
Look at the tip as you do that.
Yeah, but I think it's certainly more than a meter tall.
That's what they're going to be interested in, those there.
Very cool. So this is a sponge that feeds not by generating a water current through its body, but instead has silica spicules that are shaped in various kinds of hooks. And it's been described as kind of like a little Velcro. And for the unfortunate crustacean or worm that's swimming by,
are you ready for Tyson?
Gets an antenna or a leg sort of caught up in one of those hooks, and it struggles, it gets hooked even more. And then the sponge's cells will migrate, they'll literally move and move over it and encase it in cells. And then the question was for a long time, well, then how does it do the digestion? Because sponges don't have a stomach, so they wouldn't normally, have the capacity to externally digest something. But it turns out that there are bacteria that are associated with the sponge, and it's the bacteria that begin the digestion of whatever it's trapped. And then the sponge just takes advantage of the bacteria doing that work. It's amazing little symbiosis there. That's a great view. Thank you.
Well, at the end of the day, people are also just big bags of bacteria.
For sure, yeah. Our guts are full of bacteria that are also helping us digest our food. We hear all about probiotics.
Gut biome.
Yep.
Kombucha.
The understanding of the biomes that are associated with all these animals is a really hot field right now. And some of the things we're learning, not with these sponges, but with the more typical suspension feeding sponges, is if you take a water sample next to the sponge and then take a sample in the sponge, you find a completely different suite of bacteria, which is telling you it's not just that the sponge is filtering in these bacteria from the surrounding water, but instead is, I don't want to say they're farming their own bacteria, but they have this community associated with them. It's just fascinating. The same with corals. Yeah, go ahead.
Yeah, it's maybe the angle where we're looking at it, because it looks like 90 degrees up, straight up.
Yeah, it does, yeah. Oh, like it might be closer than...
Yeah.
I'm really hoping we find chondrocladia carnivorous sponge down here, because I found out some interesting recent studies on them that would be really fun to pass on.
240.
Where should we go next, huh?
They're looking on the surface of that rock and look like an encrusting sponge, maybe.
And so it looks like this should be starting to slope up, maybe about 20 degrees, and then I think we get pretty steep, up almost maybe 40 degrees. Which I imagine is maybe some talus that's fallen off, but also some of that shear face. You got to imagine we did start this dive with seeing a decent amount of angular talus at the bottom of the slope. There was some talus with some pockets of more in-place basalt, but a lot of that talus had to be derived from somewhere.
I mean, yeah.
And we haven't seen too many fragmented in-place pillows. They've been fragmented here and there, but there's been a lot of nice round in-place structures.
So that's telling you got a pretty good sense that this wall that we're seeing is a wall of pillows and not, some talus pile covered in sand.
Yeah, I mean, a wall of probably fragmented pillows that have fallen off a little bit, but I've been wrong before, and I'll be wrong again.
Huh.
Sounds good.
Sometimes it's tricky looking into the distance about whether I'm seeing rocks on the sediment or whether I'm seeing fish sitting on the sediment. But for the most part, there are rocks. There's a sponge, one of those vase sponges, tubular sponges that we saw earlier.
Now, there is a chance that it could be a rock fish, but there's no chance it could be a fish rock. So
correct. And I think most of the rock fish would be shallower.
Yeah.
Let's see. So for the most part, the dive track is kind of south-southwest, right?
That is not north-oriented. Yeah, so
south-southwest. Yeah, thank you. So right now, we're kind of looking west, so that means we are looking kind of along the slope there. Actually, here with that cucumber, I think you can see the trail behind it.
Mm-hmm.
So that's good. You can see.
I think that rock's moved.
Where it's been. Yeah, I agree. Some skid marks behind there. Pushed out of the way by an industrious sea cucumber.
Yeah.
There's a couple of mounds over here. I'm not sure if that's a buried rock or if that's evidence that there's some kind of crustacean that's building that mound or a worm that's building that mound. I haven't seen anything like that, but Pilot, can we get the lasers back on? Look at this. Doesn't this rock over here look like it's come out of that chunk right there?
Yeah, possibly.
Thank you, Pilot.
I'll give you that one.
Thanks.
I still wouldn't want to sample it.
No.
Yeah. But it could be a slice of the pie.
Can we get a snap zoom on as you're going over by the rock, the small rock lower right? There's a stick just in front of it as you're passing over. Yep, that's the one. Thank you. And probably a sea pen. It's extending right down into the sediment. There we go. Yep, for sure. It's a sea pen with an associated ophiuroid, and you can see that it disappears right into the sediment. It would have this inflated peduncle down there. The peduncle just being the swollen base of the colony. Thank you.
Now, if you tried to sample that, would that peduncle come right out with a stick, or is it pretty in there?
You could just pluck it out. Yeah, kind of like a plant growing shallowly in a garden. Mm-hmm. However, there are some. I don't think this one, but there are some sea pens that create a burrow, and they can very rapidly disappear into that burrow. So I've seen many an ROV pilot go to grab a sea pen that they could swear was there a moment ago, but there's nothing there. Which would really surprise that brittle star if it did that.
Yeah.
The Pashnik Anguli, a PhD student at University of Louisiana Lafayette who's working on the sea pen, says, this looks like a prototylum, the genus prototylum. Thank you. So that's the sort of thing I would expect to see in the lower bathyl, which describes the depth zone that we're in on soft sediments. Lots of sea pens, and so like now I'm seeing a stick down here. A lot of them are pretty small. I'm going to imagine now every stick I see is them because they interrupt the flow. They create some kind of baffling. You can get settling of organics around them, and so worms, harpacticoid copepods, things like that may associate with them. Sometimes fish. So they're not quite as attractive as a secondary habitat or an organism that is creating habitat as some of the corals on the hard substrate. But they do create a surface, and they do influence subsurface. I think we just passed over a brown holothurian as well. Seeing lots of what look like little pock marks in the sediment here. I wonder if there are subsurface hard urchins in this area. There's one of those sea cucumbers with all the podia along the body. We saw one close up early on. Yeah, again, lots of mounds up here. I'll bet there's all kinds of things going on below the sediments that we can't see.
Go ahead, Bridge.
I made that comment to you when we were looking at that sea spider earlier, how it looked like it was straight out of my nightmares. And it was funny, I went to lunch, and our our ship's medical officer, Michael Reed, came up to me, and he said the exact same thing to me. And I was like, I feel you. That was, we were both having nightmares that you were gonna sample it. Slightly terrified.
Make him work on it?
Yeah, that we'd see it running around our ship.
Yeah, Doc Reed has been helping us in the wet lab at night to process all these samples, so maybe he wouldn't be so excited. This is the one. This is the one. This is bentacodon. And earlier, Alan Collins told us that, so far as I can tell, at least this one species you're describing, I don't know if it's the only one, was sampled in and described from Antarctica. And so I was saying, you know, if we pass it, if we were in a position and we're just passing it, it was drifting by, could we just turn on the slurp and ingest it? Yeah, but let's not spend too much time on it, or else my partner here may punch me in the arm.
Slurp it if you can.
Yep.
And so talking about Doc Reed, you know, it reminds us that, you know, this huge exploration effort is possible not just by our ship-based scientists or our members of the ROV,
so they can swim,
and video team from the Global Foundation for Ocean Exploration, but also our wonderful NOAA Officer Corps members, Doc Reed, who I believe is a member of the Commission Corps of the U.S. Public Health Service, and then, of course, everyone who makes the ship work and run and takes care of us.
So that's sampled.
Our stewards, our engineers, our ABs.
Sean, that was terrific. Pilot, nice job. So we were just able to sample that bentacodon jellyfish. We've seen several of them today, and that's as far as I know. We'll get some more confirmation from Alan. Yep. The genus was originally described from the Antarctic, and I'm not certain how many species are known, but I think what Alan could tell, at least quickly, is that we don't know of any species that have been documented from the area, or at least collected and sampled from the area, so that'll be valuable.
That was a fast slurp.
Yep. Yeah. That's great. Nicely done.
Yeah.
Met all the requirements. Alan Collins says just 2 species have been described in that genus so far worldwide.
No. We've seen a number of them.
Today we've seen at least 6, and we've got really good video of at least 3 of them. Mm-hmm. So it's an interesting thing to think about. There are only 2 species that have been described, but that doesn't say anything about what the density or distribution of those species is, and this is another reason why we take occasional samples, is so we can better understand that. So is the species that we know from the Antarctic the same one as the one we see here? Are these sea cucumbers or are these fish? They must be sea cucumbers, right?
I think I see a mixture.
Is that right?
Yeah.
I wonder if there's a tripod fish down here, because this would be the sort of habitat that they would use.
A tripod fish is one of my favorite fishes. It's one of the first deep sea fishes I ever saw on a cruise out in Hawaii.
That or a lizard fish, because these look like they're sitting down on the bottom, don't they? Oh, that's a pretty cool sponge. That one that you were looking at while I went either the first or the second time to lunch was also really cool with the truly a vase and that really nice smooth opening with the rim.
And so now that we've come off of that little hill that was at the foot of this larger slope, and we've jumped through the water column, we've flown through the water column to that slope, and we've landed, we've kind of assessed the background, we've landed in this area that's probably at a little foothill or a little almost valley between that larger slope that we're going to be going up and that small hill that we came off of. Pretty pervasively sedimented, but we're going to start transiting up that slope. It's going to probably get fairly steep. It might start out around 20 degrees, but it should probably get up to 30, 40 degrees. So opportunity for lots of potential exposure of these pillow basalts, and then also less sediment, and then probably opportunities for some of these larger macrofauna.
Pilot, can we get a zoom to see if these are fish or sea cucumbers, please? Actually, the one on the lower part is definitely a fish. Thank you. So the two on the bottom are fish, and the one on the top is a holothurian. The one on the right, I guess, I think they're both the same, the two, the lower part of the screen, not upper part. I think that's a sea cucumber up there. Yep, just between your toes. Sorry, I didn't get to you fast enough. I pushed the wrong button. Looks like it might be next to an urchin. Well, it's definitely not a lizard fish or a tripod fish. You can see it's using its sensory fins there to sort of probe around the bottom. This looks like maybe a cusk eel. Yep, Mike Vecchione says it's a cusk eel. Okay, we saw this one earlier today. Thank you. So we have two cusk eels here, and then just a little further into the distance was a purple holothurian. So I think we're okay with those. Maybe just a quick view on the holothurian, because I don't think we imaged the one that had that extension from the dorsal surface, which is the back. Yeah, this is not the same one we imaged earlier. It's a little bit of a sail there, so this one is probably one that could swim fairly effectively. Thank you. Got a couple of notes. We must have zoomed over a xenophyophore as we were zooming in. Those are, you'll see a ball-like concretion on the sediments. They're being constructed by single-celled organisms that I believe now are classified, you were talking about classification and systematics before, as foraminifera. It used to be thought that they were their own offshoot, evolutionary offshoot, but the genetic analysis now suggests they're a specialized kind of foraminifera. There's a sea cucumber that's almost completely covered in sediments on the lower left. Yeah, if it doesn't slow us down, yes. Yeah, there you go. So I forget the name of them. but they coat themselves in sponge spicules and sediments and so on. I can still see some of the tube feet sticking out. That's good, thank you. And xenophyophore, xeno means strange or foreign. And the test that they make is made up of mud grains and pteropod shells and old smaller foram shells. Basically anything they can grab in the environment they will incorporate. And so I think that's what the xenophyophore is referring to, the fact that it's got all these foreign bodies incorporated in the shell, including its own fecal matter.
Good to know. Good to know.
Yep. Our house.
Do you think there's any children out there whose favorite animal is a purple holothurian?
Sure.
Or a xenophyophore?
Sure, they're very popular
Big
toys
kid up
in
here in
Japan.
the shading.
Oh, are they really?
Yeah.
Oh.
I mean, not the actual holothurian.
No, yeah.
That's a pretty impressive bamboo coral here, and looks like a couple of stock sponges. You know, there's been a limited number of aging studies done on coral. We often get this question of, you know, how old are these corals, how long is it taking to grow? But one of the things I don't think, essentially, that we've had enough time to do yet, I'm sure these studies are being planned or are desired if we can get the samples, is to know what's the rate, the difference in the rate of growth between a coral that's down here at 3,260 meters versus one that's at 1,700 meters versus one that's at 800 meters. And ideally, to allow for the best comparison, you'd want to do that on the same species. So you need to find a species that has a very wide depth distribution and then see how the depth may be impacting its rate of growth. Looks like what they call a Venus flytrap anemone, possibly the family Hormathiidae, tucked on the rock back there just above that branching coral. So to me, when I look at this pile of pillows, it all looks like it's being extruded from one point. Am I misinterpreting that? Or
no,
am I overinterpreting that?
You might be overinterpreting it, but I think that's a good place to start your interpretation from, right? So, you know, that hypothesis of where did it all come out from a vent in that location is a good place to start. And then, you know, if we were able to kind of fly around that in 3D and see, are all those lobes, those pillow lobes, forming one kind of central spire that they're coming out from? Yeah.
Another benthocoton.
And so as we continue upslope here, you know, hopefully we'll see more of those pillows and be able to tell.
Chris Ma is in the chat room, and he said that the purple sea cucumber that had that fin-like podium on the back is Cycropodes, and the one that was brown and sort of covered in sediments and particulates, look kind of camouflaged, if you will, is Olaflinus, or at least similar to a genus called Olaflinus. I'm wondering if that's named after someone Irish. Olaflinus. I mean, that's the way it's spelled.
Yeah, I can't even attempt to pronounce that one.
Yeah. Yeah, I wasn't actually trying to make a joke there. I was serious. Just the weird spelling suggests to me it's somebody's name who's been turned into a genus name.
Oh, yeah.
In fact, Chris Ma has just released a paper. I shouldn't say he's released. Chris Ma has just had one of his studies published in the last month. Where he's saying it's named for Mark O'Loughlin. There you go, a sea cucumber expert from Australia. But yes, the name is Irish. So yeah, I had a feeling with that odd spelling. So one of the things that's the, I guess, the honor of the taxonomist who scientifically describes something and has their paper accepted for publication, is that they get to choose the name. And so there's various ways that people like to name things, and part of it is to honor other people. So in this case, it would be honoring Mark O'Loughlin. Well, Chris named several species after different elements of the Okeanos Explorer program. And one of the sea stars, and I apologize, Chris, you'll have to tell me the name of the genus. I forget what genus it was in, but for the species, he's honoring the GFOE pilots, the ROV pilots, and the video engineers and videographers, this whole team that is giving you these fantastic visuals. And he called it, and he's going to have to tell me how to pronounce it, but we refer to GFOE, so I imagine the species name he intends is GFOEI.
Yeah, you're correct.
Yeah, but so there it is, Litonaster GFOEI, and he also named as a genus Okeanaster for the Okeanos, Okeanaster hohonuii. So it's easy for me to say, no pun intended, GFOEI, GFOEI. But somebody who doesn't know what GFOE is, I can't wait to hear them try to pronounce that species name. There you go. Gafui, yeah, there you go. Gafuii, maybe. Yeah, Chris Ma just said the same thing. This is what Caitlin said next to me was Gafuii, and Chris is laughing and saying, yep. But that's the challenge. Nice job, Chris. It definitely looks like we got the steepness part correct.
Mm-hmm. Yeah, and some of those pillows that we flew over, those look like they were primary in place. You could see those nice lobe structures and some of that evacuated interior with kind of that exterior shell still intact. And so I think, as I said, we're probably going to be getting up to, at least initially, much more rubbly areas, and then maybe seeing some more primary lobate exposures.
We just passed over a pretty tall vase-type sponge, and there's a kind of a, how come I forget the name already? I just looked this up. That sponge down there that we were looking at that had all those tubercles extending from it. Let's see if I've still got that open. Nope, I've moved on. There we go. So it's a euplectellid, and it's similar to the genus Sacocalix. What I'm looking at is identifications of taxa from the Pacific, so I'm not certain that it's the same, but it's certainly the same general morphology with those protruding knobby structures that are hollow on the inside and sealed on the outside. Bamboo corals, as near as I can tell, based on what we've seen below. It looks like maybe one of these Venus flytrap anemones is perched on another stalk. I think the couple that we saw so far have been on rocks. So if I picture how this anemone got onto here, I would guess that the larva settled here. However, anemones can kind of scooch over a surface, if you will, and some of them can even swim. I don't know that these ones can swim, but they basically arc the column back and forth, get a really awkward sort of swimming, basically folding themselves in half in order to swim. But this one, I imagine, settled here as a larva and grew in place. And so it looks like the skeleton was bare, settled on it, and then some other stuff settled above and below. And that stuff, I think, is hydrozoan. See, the anemone's a pretty good size. More than 10 centimeters across the oral disc, which would be that flat upper surface where the tentacles are arising. And so the mouth here is pointed downwards. And you can see why we refer to it as being similar to a Venus flytrap. It's kind of folded, that oral disc.
ROV, can you zoom out for a second? Video.
I think he's...
Can you zoom or pan to your lower left? Yeah. Are we in a position where we could try and grab something with the manipulator, rock? Or are we undergoing... It's okay. Yep. So what I was looking at, just for your own situational awareness, is that vertically thin piece, kind of center frame right now, that's segmented horizontally, and so that might be that's another type of piece that you can think about grabbing. So below that, yeah. Yep. Yeah. So and along kind of the laser section. Right, so if you're thinking about last time we kind of picked a piece out of a puzzle, that's also another good piece if we can get the manipulators all the way around it, because it's probably pretty narrow on the back end, so it might easily break off. Oh yeah, no worries. And so, yeah, so here we go. We have some nice, big, large, intact pillows now, these big, low bait structures. I'm actually kind of surprised I haven't seen any sheet flows yet. I was hoping to see one or two by now. But they might just...
So, I'm sorry, why would the sheet flows be higher on the slope than the pillows?
Oh, not necessarily higher, but they tend to segment the individual eruptions that have constructed this entire edifice. And so you can imagine this entire kind of volcanic edifice. This volcano is not built by one eruption. It's built by,
a series.
10, 20, 30, 40 eruptions. Okay. And each one of those might be marked by a more voluminous sheet flow. It could also just be marked by a series of pillows. But
I should have had a look at that. That's my bad. Yeah, look, I think Chris may have heard me. You see the thing that looks like a crinoid on that sponge stalk? It just had such thick arms. That's what I was looking at. The other thing I'm looking at is the sponge, how tall it is with its little cup at the top. Okay, it's not as unusual as I thought. Thank you for looking back at that. I thought the arms were a lot thicker, and that would have been significant. But yeah, really thin and tall stalk to this sponge, and I still think this is a Hyaluronima. And it gets back to the question I think you rose it yesterday. What grows first, the stalk or the sponge body? And I'm still not certain of the answer there.
And so we're just continuing our ascent of this underwater mound of pillow basalt under this likely constructional volcano. You can see on just to the right of the center screen right now a cross-section of a pillow, and you see what I talked about earlier where the lava inside has been evacuated out and has left the pillow hollow. And inside of that hollow pillow you'll see a series of almost, they look like plates that are kind of going across that pillow, and that's where the lava that's been evacuated has stood for long enough where it's cooled and it's skimmed over a surface, and then it's been evacuated a little bit more and skimmed over another surface and evacuated a little more. And so that's likely related to individual breakouts of more lava that's been connected to that pillow on kind of a pattern. And here's a great cross section. You can see in the background that slope of kind of these constructional pillows. Yeah, I would love to get a nice pillow sample from somewhere in this general vicinity, kind of middle slope. So just, yeah, keep your eyes peeled for that classic jigsaw pattern that we saw, where something might be extractable or similar, you know, one of those pillows that's been hollowed out and you just see the rind. You know, that rind tends to be much more easily fractured and broken off. Yeah. Yep. Yeah, that just looks like probably kind of thick. Yeah. 10 centimeter thick rind's pretty. Actually, that dead center, you see that brittle star just to the bottom left of the lasers? And, okay, and there's that rind, there's that kind of plate right below the lasers. Yeah, right there. If that is breakable, that exterior crust.
So that, to me, looks like you're talking about it's the outside layer of the pillow that's cooled first.
Yeah. So you can imagine almost if you're squeezing toothpaste out of a tube, and then that big long string of toothpaste that's coming out of the tube, if that exterior hardened and crusted over, but then you kept squeezing that toothpaste and another portion of that toothpaste broke out of that crust and went somewhere else, right? And so it would evacuate that hardened skin you've already formed, right? And you basically drain all the lava out of that hardened skin, but that hardened skin remains.
Right.
And you right before you stopped in, we saw one of these with a clear cross section right down the middle, and it was hollow on the inside, and then actually had a series of plates that were kind of connecting that inside of that tube. And each one of those plates represents a place where the lava has been evacuated and then stood for a little bit and allowed to skim over, and then evacuated a little bit more, and then skimmed over again. So kind of you can kind of build up this history of multiple breakouts from the same flow.
Right.
Oh no, the one above the brittle star. Yeah. So yeah, that upper plate.
It's like the top curve part of this pillow.
Above the shadow.
Yeah, it almost looks like split right there.
Yeah, so
both sides.
The top of that bridge. I almost need a giant pointing stick.
This almost looks to me like it's perfectly fractured for you. It's just waiting for you to come.
Yeah, a nice little keystone.
Pull that out. Yeah, exactly. you want to call this pillow again?
Yeah, let's call it pillow rind 1.
Or
it might be a grab and wiggle, a wiggle waggle. Yeah, whatever you're confident waggling it to. It's a classic game of ROV versus rock. Yeah, look at that.
Excuse me, it was a keystone.
Now this outer exterior surface, since it's cooled really quickly, it doesn't really have a chance to crystallize, right? And so it gets quenched fast, and that outer rind tends to be much more glass-rich. So it's better for subsequent geochemical analyses, for some analyses, because we're really interested in targeting the glass for things like microprobe analysis, where we're looking at that individual structure. But it makes it a little bit more friable, it makes it a little more weak. So it tends to be a little bit easier to break, for better or worse, right? Better for sampling.
So the crystallization process then allows what? Get packed tighter together and cemented tighter together?
Yeah,
That's why they're harder?
Exactly. Right. So this glassy structure, tends to be more amorphous, right? And it doesn't necessarily have the rigidity or the strength of the density of the crystalline material.
I did not know that.
Beautiful.
Oh, there's an isopod on it.
A nice anemone.
Oh, and 2 sponges.
Yeah, and then just get some nice shots of where it came from post
removal.
Post removal. Right, and so just like when you take a biologic sample and you're interested in seeing what habitat it came from, we want to know what was the geomorphology of the structure that we extracted this from. For the talus, it's a little less important, but when we're taking a primary flow like this, it's very helpful.
So I'm seeing both on the surface of what we just pulled out and what I can see from what's left behind, that crack must have been good enough that sediment had gotten into
Sediment has gotten in there, and then it's also allowed for weathering. So, some of that glassy material has weathered and altered, and that glassy material is iron magnesium rich, so you get a red oxidation from the weathering of that. And so that's one of the things that we hope is that we get a good enough sample that when we break it open or we cut it in half, that there is still some unweathered glass in there.
And I think I was seeing one of your flat sheet flows, or maybe that's the wrong term, but what you were saying before, inside of that outer rind.
So not a sheet flow. The sheet flow would be a larger structure, but that's same process that forms that outer rind is forming that inner rind. So part of the lava has been evacuated out of that tube, but it sat there long enough to cool and skim over, probably intruded with seawater, and then drained out again. And that's very typical. We also see that on a larger scale structure in lava tubes subaerially. And so sometimes if you're hiking through a fresher lava tube, you'll actually have kind of almost a false roof. And so if you're hiking through a big lava tube in a place like Iceland, where there's a lot of them and you can kind of just go exploring, you'll see within inside of a large lava tube a whole bunch of rubble on the floor. But the roof will still be perfectly smooth, or actually kind of stalactite-ish from the lava that's dripped down. And all that rubble a lot of times is from these kind of interior plates that were formed and then collapsed downwards, and they form almost, you're inside of this giant circular tube, you're like, where is this pile of rubble coming from? Well, it's coming from these plates that have fallen downward.
I believe I was inside one of these lava tubes in Craters of the Moon National Park, I think.
Yeah.
And, of course, Hawaii Volcanoes National Park.
Thank you very much, ROV.
You're welcome. And what was the depth of the upper part of this slope that we're climbing?
The depth of the upper part of the slope. Oh, where's our shallowest point?
Yeah, the top of this barnacle feature.
About 3160.
3160,
yeah.
So about 65 meters up still.
Yeah, and so that's where we come up to the top, and then I put in a little dog leg in there if there was time.
Yep.
But I'll be interested to get to the top. It's superficially to me, just looking at the bathymetry, it looks like a large underwater volcano with 3 or 4 possible pit craters at the summit, so little eruptive vents. And unfortunately, the scale just makes it impossible to fly around across the entire thing. But
sure.
And so if you're listening at home, and you have a student, or you are a student who's interested in working on these rock samples, please do. We're taking these samples so that people can study them.
Lots of bamboo coral up here. Nice little patch, clearly.
Those are interesting striations in the rock too.
I feel like some of the old photos I've seen. What's that? There's that classic book on the mid-ocean ridge, I think. Is it a Heezen book?
Maybe, very possibly.
It's a thick book that has lots of photos of this sort of thing, and that's what I remember. These pillows with these striations in it. Some of these bamboos that I'm seeing here look to me like what we would have called the bramble bamboo. They grow as a sort of tangled bramble of branches when they're small, and then I guess a few of the branches become the dominant growth axis and then grow into more regular sort of colony. And possibly the primnoid in the center there. We took a snipping of a primnoid from deeper today. Family Primnoidae, another kind of octocoral. And more often, what I see here are colonies that are in a state of decay, or the tissue has died and they're all overgrown with something else. I feel like I'm seeing more of those than I am seeing live fresh colonies. And this looks like a pretty healthy primnode that we're passing over. Pilot, while we're sitting here, how about we trip our third Niskin? Does that seem reasonable? Thank you. Sounds good. Thank you. Understood. Yeah. You ready for Niskin? Oh, 2 of them, 3 and 4 went. Okay. Yep. I'll just make a note of that. That's fine. Thank you. Yep. That's what we call replication in science. Yeah, I mean, if we're sitting waiting, we can zoom, but if we're ready to move, we can move. Okay, we can go. Thank you. If I think I may have just seen a snail or something just as we were lifting above the rock. Well, I don't know if you can back down. I'm just telling this to the people on shore, but it's on the pillow right in center. You just have to back up just a little bit more, if you can. And it should be right, yeah, when I there. And I just came on the lower part of the screen. It's just slightly right of center. It's on the top of this pillow feature. Your lasers are going to touch it in just a moment. And now it's above the lasers. It's like golden color. Not sure if it was a gastropod or an urchin. It's a sea urchin. There we go. We may have seen one of these the day before yesterday when we were also doing a dive down at about 2,700 meters. So that's great. This would be an even deeper spot for it. And these sponges are really interesting just to its left. They have a collar of sediments around them. That's good. I'm satisfied with that. Thank you. Yeah, I wondered. So Chris Ma is saying another irregular urchin, so I wondered if that would be the case. We did see one 2 days ago. We did a dive on an axial volcano at about 2,700 meters, and Chris had identified something that looked kind of similar as an irregular urchin, and these are urchins. He said it was like a hard urchin that kind of burrow through the sand. Looks like we're coming off this little local high point, and then there's another little sedimented saddle over there. We're at 3,217 meters as we work our way up this slope. I'm not sure that I wrote down the starting depth. I didn't. I think.
When you get a chance, do you want to talk about some volcano class?
Yeah, I was just talking about.
Oh, you were?
Yeah,
Oh, perfect. Oh, excellent. She had texted me. So. Highlight videos about silica.
A marriage of geology and biology. Did you adjust this when we got on bottom, or do you? Yeah, I forgot to write it down too. So excited. No, I apologize. I was talking to co-lead here. Still seeing plenty of tracks in the sediment here, so you can see where the lines of lighter color run across the sediment surface. And this is these sea cucumbers that you see here as they eat their way through the sediments. They ingest the sediments, they digest whatever organics they can get out of it, but they change the nature of the surface. And in some cases you see there's little pock marks up. Those might be some of the irregular urchins that are buried underneath there, or something else. So this is kind of an interesting one. I'm not certain if this is the same that we've seen earlier. Looks like it has this interesting sort of skirt to it, the margins. And you can see it's kind of wiggling and dancing a bit there. I think that's responding to the ROV's thrusters. These things are pretty lightweight and diaphanous. There's a lot of water to them. But you can clearly see that beige colored tube in the center. That's the intestine that's highly coiled in there, giving it lots of surface area in which to digest the organics. In this case, I think the head end is facing us. The darker purple is probably where the feeding tentacles are. Modified oral podia, the tube feet. The question I'm getting next to me, Caitlin, on video is asking if they have a brain. And so they do have a nerve ring, and they do have longitudinal nerve cords that extend from there, but not much of a brain, really. That's good for science. So just as a reminder for those of you who are just turning on the live internet stream here, this is the Voyage to the Ridge exploration team on board the NOAA ship Okeanos Explorer. We are surveying the sea floor at 3,220 meters depth. We came down this morning several hours ago at about 3,338 meters. We're in the let me just make sure I look at this to get the pronunciation right. Kurchatov Fracture Zone. And we're exploring, mostly the geology is our primary interest today, but also, of course, the biology and what lives on the seafloor. My name is Scott France. I'm a deep sea biologist from the University of Louisiana at Lafayette, and I'm your biology lead, and I'm here with Ashton Flinders.
Thank you, Scott. Yeah, my name is Ashton Flinders. I'm a research geophysicist with the Hawaiian Volcano Observatory in Hilo, Hawaii, which is part of the U.S. Geological Survey.
Would the front row like to introduce themselves? Is it appropriate? Do you have the bandwidth to do that? I see some nodding. Get the GFOE team to say hello. People are really running the show up here.
Sitting in the navigator position, Sean Kennison.
Sitting currently as pilot, my name is Fernando Aragon.
Sitting co-pilot currently is Chris Ritter.
And in the far right off camera is Roland at video.
And in the back, the video clipper is Caitlin Bailey.
And then we also have Arvind Shantharam, our data manager. You can please say hello, Arvind.
Hello, everyone. I'm Arvind Shantharam.
Come down a little week.
I'm the sample data manager. Coming in.
I'm coming over
NGI, Northern Gulf Institute, and
I didn't want to come down too much.
NOAA's
I think what you saw,
Center for Environmental Information.
In sonar was.
So that's the team that's currently in the control room, but we have a whole host of other folks on the ship who are coming in and out of the control room doing work, managing. We, of course, our mapping team. Some folks in the mapping team work overnight, so they may not be awake yet. They're the ones who provide us the great maps and the guidance for where we do these dives. And then there's the entire crew of the Okeanos Explorer who are operating the vessel on which this ROV is being deployed, or from which this ROV is being deployed. Now, Chris Marr gave us an ID, or potential ID, of a cycropodid, or a lassipodid for the last sea cucumber we were looking at. Those would be family-level names. And when I say a family-level name, what I mean is that's a taxonomic category or hierarchy. It's a larger group that includes various genera. Genus is the singular. And within any one genus, you could have many different species. So we have these different hierarchies. And the less certain we are of the organism that we're looking at, the higher up that hierarchy we will go to identify it. So we say it's a member of a certain family, it means it could be one of several different genera. Or if we just give a genus name, it could be one of several different species in that genus. One of the reasons we make the collections that we do is so that we can better understand what we're looking at and be able to connect what we see in imagery with a specimen that's been identified by a scientist using certain characteristics that may only be seen under a microscope, for example. There's another sea pen. And this sea pen, again, like the last one, has a brittle star oriented on the main axis. Upashna Ganguly described that earlier, or identified that earlier as likely prototylum. Yesterday we were talking about the black corals, and many of the genera names have the word pathes in it, referring to the antipathies being against the disease. In the sea pens, many of them have part of the name with tilum, P-T-I-L-U-M, and I believe it's referring to the feather-like structure of a sea pen. Looks like a feather stuck in the ocean bottom.
Now, when I remember back to my paleoceanography course, a lot of times when we think about sediment and we think about the biogenic oozes that form the sediment of the seafloor, we tend to think of those that are calcareous, those that have a calcite-based structure, and those that have a silica-based structure, so siliceous ooze. And so most of the organisms we're seeing here fall into which camp? Are the calcium carbonate structures or the silica-based structures?
We're seeing both, actually. I think, what you're referring to would be the shells of the planktonic organisms sinking through the water columns. Is a bit of a different context, but it is interesting to me that, for example, all these bamboo corals we're seeing, very common today, they have a calcium carbonate skeleton. So clearly, they also have to be concerned about the CCT and what's the potential for the dissolution of the skeleton versus the deposition of the skeleton. Now, when they're living, that skeleton is below the tissue, and so the microenvironment may be favorable to the deposition, but this is nice. Another acorn worm. Sorry, we'll get back to that in just a second, but we were looking at the Yoda worm the other day, which was purple and had the big sort of side flaps to its head. This is the same phylum, Entropnusta, so it is an acorn worm. This is a deposit-feeding worm, and you see that white broken up tube next to it? That is almost assuredly fecal string from this same worm. So these will be deposited all over and give you some sense of how much of the sediment it's processing. And you notice behind the head, there is a head there, at the top part of the screen, it looks like it's folded on itself. Those are referred to as genital flaps or genital wings, so the gonads are in there. But otherwise, the length of the body is mostly just intestine. And, it's facing downwards and just chewing on that sediment. Great, thank you. I'm glad you spotted that. That's the first time we've seen certainly this color mark. I suspect that's a different species than what we were seeing before. Acorn worms are, maybe I shouldn't say common, but they're characteristic deep sea soft sediment organisms. I don't know enough about their density to say whether they're common or not. Yeah, you can see how high up that fecal string goes. So it's been working that little spot in the sediments in the rock. Sako Matsumoto says that this is the first color that she's seen in this dive. Everything seems to be white, except for that one Benthochodon, Sako, the swimming jellyfish. But otherwise, yeah, I agree.
And so, what I'm looking at right now are these really bulbous pillow flips. They look intact, and you can see, like on the one on the left-hand side of the screen, it's got this rind where all of the lava inside of that pillow has flowed out. It's flowed out and formed another pillow. And that exterior rind, or the exterior surface of all of these pillow basalts, are really one of the crucial things that we try and sample when we're taking our geological sample. They're really rich in volcanic glass. That lava that's been erupted on the seafloor has quenched and cooled really quickly, and that's preserved this glassy state of that lava that we use for subsequent geochemical analysis. We can look at it with a range of sophisticated techniques, look at trace elements, look at trapped gases within that lava. And when we start thinking about volcanic glass that form the exterior surfaces of these pillow basalts, we can really think about glass and silicate minerals in general and kind of their range of varieties within the minerals that form the Earth's crust. So we tend to classify things from the geological perspective depending on how those silicate minerals are arranged. So by silicate, I'm talking about silica attached to 4 oxygen in kind of a tetrahedra. And the way that those tetrahedra are arranged, whether they're in chains or whether they're in sheets or rings or individuals, forms the basis of our mineralogical taxonomy that we do geologically. And so what's always interesting to me is these biologic organisms that also have silica-based skeletons, what the arrangement of them are, and kind of how they depend on the silica that's in the water column that might be derived ultimately from volcanic products to build their skeletons.
Yeah, it's interesting to say that we just passed over 2 glass sponges, the Hexactinellida and the glass sponges. The glass in the name refers to all the silica that they've incorporated into their skeleton. And one of the cool things about the way you just described it is to think about how all of these elements of the Earth are interconnected, because to get the silica to deposit in the skeleton, they have to take it out of the water. And where's it coming from the water? It's probably dissolved or has been released from the interior of the Earth, or the weathering of the rocks that you were just talking about. It's one big cycle.
Yeah, so the Earth on whole is about, I think, 25% silicon. And then the crust itself is about over 90% silicate minerals, so minerals that are derived from the element silicon. And those then are erupted onto the seafloor and provide an input source for organisms that need that to build their exoskeletons and internal skeletons.
One of the things I find amazing is that I look at the rocks, and you're just describing how this glassy rind is silica-based. But when I look at the Hexactinellid, that glass sponge, and I get it up on the deck, to me it looks much more like what I believe is not what I understand is glass, something that's transparent, something through which light can move. And so it's interesting, silica apparently has these different properties, or am I seeing the other minerals that are associated with it in the rock?
So the optical clarity of that glass is dependent on a few things. These basalts are really rich in iron and magnesium, right? So that lends to their opaqueness. Also, depending on glass, the amount of amorphous structure, or how those silica chains are arranged, also affects the optical clarity. You can imagine if they're all kind of bunched up like a bowl of spaghetti, it's difficult for light to pass through it.
I am trying to look up here a paper that I have that talks about this deep-sea genus Monoraphis, and studies on the silica fibers that it has, and I'll come back to you once I find it. But it's fascinating. It gets to this point exactly how the minerals are put together and how that affects the optical clarity.
Yeah, so going back to those silicate minerals, it's also interesting in terms of how they're arranged and whether they're kind of isolated silica tetrahedra or whether they form sheets. Also lends to the bulk material properties. So you can think of quartz, which is kind of just an individual silica tetrahedra. That crystallizes it in a three-dimensional framework that makes it very hard, whereas other minerals, such as mica, form sheet silicates, and so those tend to be very flaky in terms of their bulk material properties, and it's just because of how those individual silicate minerals are arranged internally. And there's
sorry, go ahead.
I was just going to say, there's a beautiful example of kind of one of those pillows that's formed kind of its lobate structure, and then the interior lava is drained away, and it's formed that rind, and then that rind has now broken through and filled with sediment.
Yeah, well, I guess it's going to be filled with water, so what I said doesn't make sense. What I'm about to say, I understand already. It doesn't make sense. But I was going to say, if it's hollowed out, why doesn't it collapse under the weight of all this water? But that's, of course, because it's filled with water. It's being replaced with water as the lava drains. Yeah.
The hydrostatic pressure is equal all around it.
Correct. Yes.
Until
I
it gets,
answered my own question.
Until it gets bumped by an ROV or a rock falls on it, or it just is weakened. Okay, so actually, what you see right in front of you.
Yeah, this thing?
That is really kind of cool. Okay, so what that looks like to me, that big long tube, is you had this long pillow lava that erupted out, right, and it formed that exterior structure. And all of that lava when we talk about water pressure, we talk about hydrostatic pressure. When we talk about lava or magma, we talk about magmastatic pressure, so the amount of magma pushing that. So that tube was full of lava. It got to that point where there's that break at the bottom of it. That entire skin cooled and chilled so much that it couldn't keep moving. The magmastatic pressure was still pushing on it, and it pushed on it so hard until it broke the end of it, and then a new little lobe of pillow lava erupted out of it. And so what you actually see is one snake of lava, then a break, and then another snake of lava coming out of it, and you can still see the broken piece stuck to that second little pillow flow. That's really cool.
And so, now I understand. If I was to take a cross-section through that, I would see these different layers of each of these separate flows inside the other. Very cool.
That was really exciting for someone like me who loves to study eruptions, whether it's subaerially or underwater, because it's something we don't get to see very often. And so that was also a perfect example of that. All of this lava that you're seeing now, this is all in place. This was all erupted here. There's no question that it was necessarily something that's been moved through faulting or a pile of talus. That was a very clear feature.
Oh, this looks like one of the slime stars, the Pteranaster. And, Caitlin, do you remember the name? What's the other one? Chris was, Hymenaster. So Chris Ma was saying yesterday that more regularly we see the purpley one with the transparent false upper skin, Hymenaster, and I'm pretty sure that's what this is. And let's see, Chris is still, thank you, Chris. So Chris is still in the chat room, and he's agreeing that this is Hymenaster. He can describe it much, much better than I can, so perhaps he'll call in just a moment. But the one thing I do recall is that, it has this orifice in the top center. And I love that we're seeing these, when we're in these volcanic areas, because to me it looks like this little volcano from which mucus can be released. Otherwise, you see those really long tube feet that are extending from each of the 5 points. Those are the arms. You can kind of see through the transparent upper part of this body that there's a more typical sea star underneath there with its 5 radiating arms.
I'll take my volcanoes with lava, not mucus. I don't want to go near a mucus volcano.
Good stuff. There you are.
Greetings, Scott.
Hi, Chris. Yeah, so we're going to have to move, but please do tell us about that Hymenaster.
Oh, no, that's fine. I thought you did a fine job encapsulating the basics. The name is actually not related to people often make the mistake that Hymenaster, which hymen means membrane, refers to the sort of very sort of gelatinous surface we see. And it's actually more of a comment on the spination on the underside. So that's sort of one of these odd taxonomic things is they're all in Latin, and so they allude to taxonomic. The names often allude to taxonomic details. But as you said, the tube feet at the ends are often very pronounced, probably finding its way around. We don't know what they do down here. probably eating detritus. But the surface is the second umbrella-like surface over the actual surface of the animal. And in this case, in all of the terrestriids, but especially in the deep-sea Hymenaster, the animal is basically a big kind of starfish jellyfish. I mean, the entire thing is just gelatinous, and the surface varies with different species, because the ones that we see here, if we collected that would probably just literally be poured out of the collection container.
That's
the
a pretty
ones that
picture.
I've seen are almost. Yeah, well, I mean, if you think that's good, the slime it produces would be just about as much fun. But in contrast, there are others that I've seen that are actually more fleshy. If you imagine pulling one of these up, and I've seen some of these that are almost like 1.5 foot across, and they're just they're like literally a big pillow, like a big soft pillow. It's just a bizarre animal to work with. I've tried to sort of pin down what species are which, but a lot of them are damaged badly by trawls. And I think that, if and when someone ever decides to actually try to master the taxonomy or the number of species of Hymenaster, molecular data will probably be necessary, because so much of the general morphology is so poorly understood. And especially because a lot of it's based on, you can imagine dragging a fine silk pillow through a trawl net. That's the kind of thing that you're going to get.
Yeah,
but
it's not going to come out in good
there's
condition.
all these mysteries with regards to their slime and other things. They come out at the base of the tree, too. Oh, you're right. Okay, yeah, no, I get it. Coral.
No. We've sampled this. I have a question for you, Chris. What the depth range? We're at 3190 meters. Is that deep for Hymenaster, or is that typical, or?
That's typical for Hymenaster. So Hymenaster is probably a bunch of different things. That Hymenaster is a garbage can.
Okay.
Because it's the genus was described by Walter Percy Sladen back in 1882. So there's a bunch of them, and they're not all the same, but they occur as shallow, like in the Arctic. It can occur in as shallow water as like 100 meters. You're not going to see them scuba diving, but you could definitely see them in relatively, close to shore. But they definitely, from what I remember, some of the things that are called Hymenaster can occur in water in depths as deep as 4,000 meters. And these really kind of squishy ones tend to be sort of in the, 2,000 to 4,000 meter depths. It's actually more typical to see like Hymenaster at this depth than, probably any of the other things. I'm kind of surprised, for example, that we haven't seen any Brasinghids yet.
I agree.
I realize that there's been limits to dives and stuff, but I've noticed that we haven't seen a single Brasinghid since we hit the mid-Atlantic.
That is true.
Plenty of crinoids and plenty of oafs.
Yep.
But we usually see at least one, so it's really strange.
Agreed.
But anyway, there are lots of mysteries here, and it could just be that the sedimentation or some other aspect interferes with their feeding, or any number of other potential reasons. But
we'll find my Chris.
One of these days, I think I'm actually going to collect one of those Hymenaster, and woe be the biology PI who has to deal with that. So we'll see. But
we've been dealing with plenty of mucus out here. We can handle it. All right. Thank you, Chris.
What was that?
I said we've been dealing with plenty of mucus out here. We can handle it.
Well, maybe the next one I see then. Thanks. Bye-bye.
Take care. Chris is on a very delayed phone line there, so it's hard not to talk over. So what we were looking at while Chris was describing that last slime star that we saw was Prenoid octocoral. Got some really nice close-ups of it there. And we had seen one earlier on our dive, and we took a sample of it. And so that's why I wasn't too concerned about describing it at the time. We're doing a pilot change, and so this is why we'll be hovering in the water for a couple of minutes here as the pilots update each other in a situation. So let me finish off on the silica thing. So I'm looking at a paper here on glass sponges, a nice review of glass sponges, and it does say that the skeleton is a delicate scaffold of siliceous spicules, some of which may be fused together by secondary silica deposition to form a rigid framework, and that silica is deposited in the form of amorphous silicon tetraoxide, I think, but it just went to sleep. Oh, let's try that again. The silica is deposited in the form of amorphous opal.
Yeah, so opal is a silica-based, naturally occurring, not mineral. We call it a mineraloid, and that's because in order to be a mineral, it has to have 3 set characteristics. It's got to have a defined chemical structure. It's got to be naturally occurring, and it's got to be crystal, right? And so it fits the first two. But that third one, it actually has a non-crystalline structure. It's got an amorphous structure. So all of those silicate chains are kind of, as I said, kind of a bowl of spaghetti. And so it doesn't have that defined crystallographic lattice. And I think I remembered that correctly because it's been a while since I've thought about the 3 things that define a mineral from geologic terms. So, yeah.
I think I'm looking at a diagram of the spaghetti that you're referring to in the formation of this, what they call the giant basal spicule in Monoraphis chuni, and I have to still dig out this paper, but there's this one fantastic image of a scientist holding one of these spicules, and it looks to be 6 or more feet in length.
Wow.
Look at that.
That is huge.
Mike Vecchione in the chat room has provided a potential identification of that acorn worm that we were looking at earlier, kind of golden color. Tergivillum cinnabarinum. Cinnabarinum. All right. Tergivillum cinnabarinum. Cinnabar. I wonder if that's for a place?
Well, when I see that, I think of the mineral cinnabar, which is mercury sulfide.
Oh, so maybe the color.
Yeah.
Okay.
So it's the chief ore of the mineral mercury.
Yeah.
MGS.
Yeah, I could buy that based on the color of that one.
But similarly, cinnabar, the name of the mineral, is derived from ancient Greek, which I think is for that color. So. So one of the things that we had mentioned briefly when you said when you think about pillow basalts or kind of mid-ocean ridges, you think of that kind of those striations on those pillows. So that striations, those are interesting. You can think of it as that pillow is forming and that internal magmastatic pressure is increasing. When it breaks out, sometimes it breaks the outer crust and then just keeps expanding, and that interior rind that's expanding is almost like taffy. Right, it's the consistency of taffy. So you can think about pulling taffy in one direction and kind of those striations you get that line up with that pull.
Yep. I see these these frozen in time pillows, and I'm thinking about the classic, I don't know, it's National Geographic from when I was a kid in the 70s of the pillows being extruded underwater and what I assume was Hawaii. So I can see that, and then I can see them here. I feel like I'm seeing way into the past.
Into the 1970s.
Like I said, way into the past. Yeah, Mike Vecchione is saying cinnabarinum is the Latin adjective for cinnabar, or vermilion color. couple more colonies of these primnoids up on that pillow just coming into center. Very pretty.
And so, you know, it's interesting, and it's always nice to be a little validated in my assumptions of the way I hope things work. And so when we were on those lower slopes of this portion, I think we saw things that were much more fragmented and a little bit more of a talus mixture. And that's when we were on those slopes that were, you know, kind of 40 degrees-ish. And when we saw that nice elongate pillow, that breakout pillow, that was kind of the transition of when we got into these lower slopes of kind of 20 degrees, 25 degrees, which I think are much more reflective of kind of primary placed piles of pillows. Primary placed piles of pillows.
That's good. That's 4.
Oh, almost there.
Yep. Pretty.
Pretty primary piles of pillows.
There you go. Copy that, pilot. Does that mean if we see something right in front of us, we can zoom on it? Great, thanks. So let's see, just at about, what's that, almost 7 o'clock now. I can't tell if I'm looking at a brown color on the front of a rock or something on the rock. So the lower part of the screen, just, yeah, it's about center right now. Maybe you can put the, yeah, yep, the right laser is on it now. I'm seeing like a brown curl. What am I seeing there? Must be the rock is, it's just the incrustation maybe has come off, and you can see a little bit underneath it, and there's various sponges. And
yeah, it looks like a little toe of a pillow, so sometimes we get a little breakout and we just get a little extrusion.
Yeah. Okay. So probably if you look down to the left there, you see there's a wiggly little white line. I'll bet that's a carnivorous sponge back in there. We don't need to zoom on it. It's okay. Thank you. That's fine. Satisfied. Oh, what's walking up here?
Hey, buddy.
So let's see. I think I saw one of these earlier. We weren't able to image it, so this is good. I think that is a hermit crab, a pagurid crab, that is carrying either an anemone or a zoanthid on its back. And I think it's a zoanthid. And I think what you'll see is some finger-like structures that are sticking out. There's probably 5 of them. I can only see 2 right now. One is kind of facing towards me on the right side, and that's the tentacles that have been withdrawn. I wonder if this is the zoanthid or just an anemone. But this is very characteristic for this group of crabs. They carry either an anemone or a zoanthid on the back instead of a snail. And is it carrying something in its left leg, or am I... Yeah, it looks like there's a... Is there a black coral down there? Is it carrying it? I can't tell what's going on.
It looks like it's carrying it.
Or is it growing on its leg?
Well, are its front legs encrusted?
Yeah, I always see that. I'm not sure what they're encrusted with. I think that's an incrustation, but they're always like that.
I think he just bumped in and stopped on that coral.
He might be holding it in the claw. Oh, I see what you're saying, Ron. Gotcha. He's knocking it over. He's tilting it forward. Very good. So if we could focus a bit on the coral, let's see if that's a hydroid or a sea pen or a black coral. I think it's actually a black coral. How about that? You can see now on the crab in the back right, you can see the individual tentacles in that brown ring. So it's kind of retracted right now. So you can see it's an old snail shell, and whatever this is, zoanthid or anemone, is growing on top of it. So that's cool.
Oh, that's nice view.
Yeah. And you can see more tentacles hanging down underneath it. And the fact that there's two sets of tentacles tells me that's a zoanthid. If it was an anemone, there would just be one. Very good. That was lucky.
But so it's not an empty shell?
Well, the shell is empty except for the abdomen of the crab, which is stuck in there.
Okay.
But there's no snail alive.
There's no,
anymore.
there's nothing else
Correct.
in there. Okay.
So snail shell, no snail, but living on the snail shell is a zoanthid. So the zoanthid gets to sort of travel around, and as the crab's making a mess and eating food, the zoanthid is just picking stuff out of the water. And possibly, I don't know if it's some benefit to the crab by deterring predators. You know, if it sucks into the shell, and it's just, ew, what's on this shell? I don't want that.
And so on the left-hand side of the screen, you can see this pillow that's broken and come down, and there's a beautiful example of the striations running vertically. So that's kind of like where the pillow is stretched out after the exterior crust is broken, and it's almost forming this kind of striations to a viscosity similar to like taffy. And so we see more of these lava tube structures in front of us, these large pillows, and as they're evacuated of lava inside of them, either to feed a breakout of another lava flow down slope, we get these empty tubes. But we see something interesting. No, I was saying we also see this skim coming across. Oh. Oh, no worries.
Mike Vecchione thought he saw some plastic floating by. We were talking to each other, so I wasn't concentrating on it.
I saw a green, wispy pile of gunk.
Huh.
Greenish brown. I don't know what it was.
That would be kind of sad to see
I'm
plastic
pretty sure
down
it
here
was
at
squid ink.
Squid ink, okay. Nope. Thank you.
I was telling somebody this anecdote of one of my first cruises I was on, which is kind of northwestern Main Hawaiian Islands, around the island Ni'iau.
And like footsteps.
Yeah, footsteps. And we were kind of in the abyssal plain. We were far enough away from the island, so we were kind of in the abyssal plain. It was a night shift, and all we saw was, we were logging this, of course, is like extensive abyssal plain, nothing interesting. And nothing interesting, at least for the igneous geologists aboard.
Right.
And then in the middle of the abyssal plain, we found, sitting there all alone, perfectly, like basically standing upright, was an empty Pepsi bottle from like the 1970s.
Yeah,
it was a little unnerving.
Pilot, if you want, zoom just below this big round rock, just in the foreground. I think there's a brown sea anemone, so it's to the, Keep going down, and to the right of the lasers, right at the edge of the rock. Right now. At the right. Yep, yep. It's on the sand. Yep. So that sort of lump, I believe, is the second viewing we'll have of this sea cucumber that is covered itself in shell hash and other sedimentary material here, so it's hard to tell and see the body, but it is a sea cucumber deposit feeder, and this is the one that earlier Chris Ma had said had been looked similar to one that had been named after a famous sea cucumber biologist. Oh, there, you can very nicely see this, the shell hash there, and is moving for us to prove to you that it is alive under there, and it's wearing this very attractive suit of armor made of, I guess, pteropod shells mostly, I think is what I'm seeing.
It's interesting because it reminds me actually of one of my favorite rocks, which is a coquina, which is kind of a partially mineralized and concreted conglomeration of shells and forams.
Yeah, so Olaflinus is also what Cindy Van Dover is suggesting here. Oh, good, you can see the feeding tentacles, feeding podia at the left end there. So, again, hidden underneath all that shell hash. So these are the same sort of tube feed that you see in sea stars, but these ones are modified at the frilly end, and you'll see it extend down to the sediment surface and grasp it, just like a hand making a fist and grabbing some sediment, and then it'll curve that into the mouth and ingest it. Great stuff. Now it's a little shy. It's just frozen in place.
Definitely looks like it was rolled in cornflake.
Yep. Nope. This is good.
And so I might have missed it. Is there a reason why? And why does it cover itself?
Oh, look at this.
Yeah.
Why? I don't know.
Yeah.
You know, we can make some just so stories. I always wonder about things that are camouflaged in the deep sea where there's no light, and so.
I mean, is there anything that preys on those?
Yeah, good question. Oh, hold on. Is there a ctenophore? Oh no, this is an isopod, I'm sure, that just swam up off screen, top center, really small. You'll see two long trailing with her legs, actually. There they go. That's just off the top of the screen again. There he is. It's going to be flapping those rear legs. I'm pretty sure that's what we call a water walker. Isopod with some extremely long legs. Yeah, it's really small. It's pretty far away. It looks like gelatinous zooplankton, but it's actually a crustacean. So what you see beating there are actually the back sets of legs, the legs that are under the abdomen. We call those the pleopods. And the long trailing things are the thoracic legs. And this is essentially a roly-poly, a deep bathyal roly-poly with extraordinarily long legs. Munopsid isopod, Mike Vecchione says. Thank you. So they call them, I think that's the ones they call the water walkers, but I may be wrong. The water walkers may use those other long legs to sort of paddle. What was I going to search? Oh, yeah. All the shells that it was using to.
Mm-hmm. And so if you're just joining us, we're on the Kurchatov Fracture Zone on the Mid-Atlantic Ridge. We're 175 kilometers north of the Azores, north of the northwestern island in the Azores archipelago, the island of Corvo. We're diving on a right lateral offset in the Mid-Atlantic Ridge. And by right lateral, I mean if you were on a segment of the Mid-Atlantic Ridge looking northward, and the entire Mid-Atlantic Ridge moved rightward from your position, about 20 kilometers, that's what we're looking at. We're looking at that fracture zone where the Mid-Atlantic Ridge moves to the east. We started at a depth of about 3,340 meters, and we're coming up to a depth of about 3,120 meters below sea level, so hopefully about another 50 meters to go. And we've been diving on the slope of this large underwater volcano that's made up of these stacks of pillow basalts, these large lobes of basaltic lava that erupted underwater into these large piles. We started the dive with an area that was pretty heavily sedimented, and as we've been coming up the slope, we are seeing more of these large pillow lobes that are actually erupted in place here. We don't know the age of this feature. It could be as old as maybe 1 million years, but based off of looking at the condition, I would say maybe 100,000 at the oldest. But we're taking some biological and geological samples on the way.
That's pretty young for the old Earth.
Yeah.
100,000 years.
Yeah.
I just got an email from Dr. Mary Wixton at Texas A&M University, and she's a crustacean expert. She's not able to be in the chat, but she's watching along, and she says that hermit crab we were looking at earlier is in the family Paraperguridae, and possibly the species Parapergurus nudus. She says that species lives at the depth we are sampling, and it carries zoanthids instead of sea anemones on its shell. Other species in the family will carry sea anemones. So thank you for that, Mary. Much appreciated.
And so if you're looking on camera 1 right now, it's interesting to me, you can just see how stark the transition is from one side of this little valley to the other. On one side, where it's sloping up to your left, it's very heavily sedimented, and on sloping off to the right, tends to be much more rubbly and pillow. ROV, with our current rate, what do you think the chances is of us making our next waypoint right on the kind of that first crest? Oh, yeah. No worries. Thank you very much. And so one of the reasons I'm interested in trying to make the top of this this bathymetric high is that we see a lot of these really large in-place pillow basalts, which means this entire mound is part of a volcanic structure. Now that's a little disingenuous because the entire Mid-Atlantic Ridge is a large volcanic structure. The top kilometer or two are formed by these pillow eruptions. But unlike some of the areas that we've been diving earlier, where we've been on the tops of these normal faults and we see a lot of these pillows dissected and rubbly and fragmented in place, lately on this dive we've been seeing a lot of really well-defined in-place pillows, which means the structure that we're in probably hasn't undergone a lot of post-depositional deformation. These pillows haven't been erupted and then fractured or heavily sheared. They've been erupted here in place. And so if we get to the top of this feature, and this entire feature is indicative of a large volcano that was erupted here and placed here, at the top of it we should see maybe some younger volcanic products. We should see some younger pillows, more intact pillows. And looking at the bathymetry, it actually looks like there might be 3 or 4 little individual pit craters that form this volcano. Yep, go ahead. Yep. Okay, waypoint 3 is, that's the, someone took over the flater mouse scene that I was looking at on MV2 Proc. So just to be clear, that's the first on the hill. Yep. Yep. Yeah, so I didn't expect to make waypoint 3, so don't even worry about that. You know, that was just kind of another point to draw in case we got to waypoint 2 and we needed a direction. But at the same time, don't necessarily take it completely out of the, yeah. It'd be nice to see some of that elevation. It's just not it's not mission critical in my sense. Yeah. Okay. And perfect. Perfect. And I'm sure, I know Scott wants to sample another octocoral, so that'll, depending on the what, where, and when, I'm sure that'll take some time, and I'll probably want to try and grab another rock or two. So. Nope, sounds perfect. Thank you. And again, we're just looking at kind of a stack of these pillows that have kind of started to break up their exterior surface and kind of fall down as talus, as rubble. Oh, yeah.
I see you've fallen in love with the sea cucumbers.
Yeah, those purple power eaters.
Yep.
Are these little black sponges on the left, on the rock face?
These blue things?
Yeah.
Yeah. They're actually transparent. What you're seeing is there's sediment on the rock around them, and so where the sponges are, you're seeing more through to the rock, but they're transparent.
They're throwing me off. I keep thinking that there might be little inclusions in the rock surface.
He's on a bamboo coral.
Oh.
And the bamboo coral's still alive because I can see the polyps there. Huh. I would be paper right there if this thing was feeding on the bamboo coral, and it's not. So, Chris, it's not. I'm telling you.
I'm writing that paper.
Yeah. Actually, I do think I see maybe an aplicofferan worm there. That could be feeding on it.
So what is the main diet of those sea cucumbers?
Sediments.
Just sediments.
Absolutely. Yeah. The only one that I know that does not feed on sediments are the solid sea cucumbers, which have modified actually, I shouldn't say the only one, but in the deep sea, they've modified their oral podia that they use for picking up the sediment, and it faces up, and it's more like a series of tentacles that we see on the fan worms and the corals and so on, and so they're suspension feeders.
Okay.
Now, there are other sea cucumbers who will burrow into the soft sediment and stick their head end up and extend their podia into the water. So they're kind of like suspension feeders also, but they're not as highly modified. They're very recognizable as this. But the solids sometimes are hard to recognize. You'd think you're looking at an anemone maybe from a distance. If you looked at it closely and you picked it up, you'd know this is not an anemone. Oh, thank you. Yeah, Mike Vecchionis just reminded me. I completely forgot. There's another highly specialized sea cucumber called Pelagothuria, and as the name suggests, it's pelagic. Very unusual thing. It spends all of its life in the water column, and so that would also be a suspension feeder. And Mike, maybe you can help me. I suspect that produces a fair amount of mucus, so it binds up some of the stuff that's floating around with it. We saw a lot of those in the Central Pacific on some of our cruises during Capstone. They're just fascinating animals. So I finally found some of the text that I was searching for earlier, Ashton, to follow up on our discussion of silica in glass sponges. And so this is from a paper that was looking at some of the chemistry and engineering behind the spicules. And it says the combination of spongin protein with silicon dioxide extracted from seawater by silicatine protein, so there's a genetic component to this that produces a protein that grabs that silica, presents a natural nanocomposite material of unique optical and mechanical properties. Mechanically, it combines the elasticity of protein with the flexibility and durability of silica. The light propagation inside spicules of glass sponges is of substantial interest for developing novel elements for photonics applications. The glass sponge spicules have remarkable light guiding properties. So I remember from looking at that paper, which is, it's not a bio paper, it's well beyond my understanding, but is that for industrial uses and fiber optics, they found that these were much more transparent and could better translate light. And so they were wondering, how do the sponge cells deposit that amorphous silica to produce such a great fiber optic cable, basically.
Yeah, and so while all of these pillow flows are silica dominant, we classify igneous rocks based off their silica content. Basalts that we're looking at now are typically less than 52-53% silica. You can imagine most of the silica is bound up in the rock. It's not mobile, right? So it's not necessarily getting into the water column. So most of the silica that enters the ocean on an annual basis is actually terrigenous. It's from fluvial input, from rivers and streams, from eroded sediments on continental land. And there's another beautiful example on the left of one of those cross sections of those pillow lavas where the lava has been evacuated out to feed another break, but it's only been evacuated out a little bit initially, and it's had enough time to skim over and form a top cooling surface, and then another breakout happened, and it drained down a little bit more, and then another breakout happened, and it drained out a little bit more, and then, that one plate, two plate, and then that third gap, and it's solid all the way down, and that means that breakout of that next little pillow never happened. It stopped, and so all that magma had an opportunity to solidify in that pillow tube.
I'm really glad we saw this one because when I earlier saw this sort of texture, I hadn't thought about the way you're describing it, and I thought it was being from the bottom up, and now I totally get that it's forming from the top down as you get each tube within a tube within a tube, and a little bit of shrinkage as it's cooling and so on. Yeah, very cool. I also find very cool that sponge that's draped over the uppermost ledge there. Yeah.
Yeah, now the subaerially, the upper inside surface of those they're very smooth on a larger scale, but then they're also very, they've got overlaying on that smoothness is actually this really, really sharp, prickly rugosity. And so it's smooth because of that interior glassy texture, and then prickly because it's got all these little drips of lava. Now that's subaerially, but on submarine it looks like there's a bunch of little, there's a rough surface that gives all those little microorganisms little anchor points.
This close-up is fantastic. As you can see, there's all these little sponges. We just saw that little red, pink amphipod sitting there. I mean, if we're here anyway, yeah, sure. Okay. We do lots of zooms here, and we see lots of great stuff, but we don't always zoom really tightly on the bottom and on the rock if we don't otherwise see something, macro that we're interested in. And yet, it's covered in life. It's all over the place. And it just takes a matter of seeing it at a fine enough scale. So that's kind of remarkable just how many sponges are actually on that rock.
No, it's kind of a little sponge apartment building.
Yeah, very much so.
Yeah.
Multi-level.
Yeah.
That top one, I guess, has the best view.
In the penthouse, yeah.
It's got a balcony right on the edge.
Rooftop access.
Protected from the detritus dropping down above. I'm thinking to the left of the sponge, there's those couple of tube-like things that are, one looks like an S. I guess those are worms. Look at all the stuff in there hanging from your ceiling. Oh, there's an old cup coral. Look at that. So that dark structure upper right of the sponge is a cup coral that's been long dead, and has been encrusted. You can see now it's all black, but you see those plates that are subdividing the wide diameter. Those are the septa of the cup coral. That's how I could recognize that it's not just part of the rock. What else we got in there? I'm not sure. You know, a lot of this hanging stuff, I don't know if these are little mud sticks that are built by amphipods or these are foraminiferal single-celled organisms that are making these things. And you asked this earlier, you know, that rock we got up from Waiteria was covered in this sort of stuff. So we preserved it, so I hope that somebody will be able to identify it and then I'll stumble across what
There's a little worm going for a walk on the right-hand side.
Right-hand side over here. Oh, yeah, nice. Yeah, so that's a polychaete worm. Polychaete is the major group of, on the wall in the back, out of focus, upper right.
Long white.
Long tube. There you go. Now you got it. It's got kind of a reddish, I'll call it a neck, because it seems to have a long tubular head after that. You can see all the paddle-like limbs called the parapodia. There, it's using them to sort of crawl along the surface. And it has these short tentacle-like structures that it uses to sense the substrate, looking for its prey. This one looks pretty mobile.
Now, I know you already have an appreciation for the rocks and the geology, but I want to say something that I hope makes it appreciated even more.
Okay.
Because we were talking about the infauna and the epifauna and how we don't have an opportunity to study the infauna because we can't really observe it. But I would argue that maybe features like this evacuated pillow basalt with this beautiful cross-section, give us a little glimpse into kind of those infauna that hide in the rock crevices. It gives us an opportunity to look inside and see those organisms that are not necessarily prone on the surface. You can tell me I'm wrong.
Well, it's just that essentially they're on the outside of the rock, but they're tucked on the underside of it, so I agree with that. There are a whole series of organisms that can literally bore into the rock.
Yeah, so not necessarily the ones that bore into the rock or live in the sediment, but the ones that spend most of their life maybe hiding in the rock.
Absolutely, in the cracks and the crevices that we wouldn't otherwise get to see. So I, too, appreciate your little pillow amphitheater.
Yeah, everybody loves a pillow.
This one back there kind of reminds me of the Hungry Caterpillar.
Yeah. Yeah, so it would have been amazing to see that actually form, because it would have been this large bulbous structure that would have moved forward a couple inches and cooled, and then another bulbous head would have broken out of that foot, that toe, and moved forward a little bit more, and then move forward a little bit more. So actually kind of moving like if you imagined a caterpillar, but that caterpillar moved, and then every time that caterpillar stopped, another caterpillar exploded out of that caterpillar's head and then moved forward a little bit. And so a series of escalating and cascading exploding caterpillars is very similar.
Are they ever smaller caterpillars, or are they so big they're just causing the person to burst open?
Sometimes they're small, and sometimes I think we saw a little pillow toe, right, just a little thumb that came out of a larger.
Yeah, sure.
Yeah. I've been thinking how to describe this because I've had to draw it, and it makes a lot more sense when you draw it. But maybe the exploding caterpillar analogy is the one I'll work with.
I understood it perfectly before, but now I'm going to have geology nightmares of caterpillars throwing up new caterpillars, throwing up new caterpillars.
Well, I think that's only fair because I'm going to have nightmares of deep sea spiders.
Exactly. Yeah. Well, we'll hear each other screaming through the bulkhead.
Yeah. Caterpillar spiders.
Pillow lava.
Mm-hmm.
Pilot, as you get up to the pillow that's coming into the frame, getting to center now, there's a stick standing straight up. I think this is now maybe the third or fourth time we've seen this. I think it's this Bestipluma carnivorous sponge, and they're just so tall, really erect, really straight. And, we've been talking a lot about silica, so this is another one. The main axis of this sponge is formed of silica fibers. Yeah, let's please do that, and then we can verify it's what it is. And what we should see are small filaments coming off of either side. I can already see some of those filaments. So it's not going to have polyps, all right? It's not a coral. This is just a really odd sponge. We tend to think of sponges as these globular sort of soft things that hold a lot of water. But this is a whole different family of sponges that have adapted a new lifestyle. They no longer funnel the water through their bodies and instead snag things on their hook-like spicules. That's indeed what it is. So one of the things we can look for is if we see swellings, especially if they're discolored swellings along the stalk, that would be evidence of where the cells have encapsulated some zooplankton prey. I'm not seeing any at this level. And those filaments that stick out the side of the sponge, which are also silica, I imagine, are just to increase the surface area over which it snags its prey. Yeah, I don't see much. I think I saw one item on that sponge. So maybe, I don't know what the frequency is with which they eat. Or
yeah, I was
how
actually.
Often they have to eat.
I was going to ask you that earlier. That's an interesting question because you were talking about. As soon as you talked about catching it's catching something and then enveloping in its cells, it made me immediately think, well, how big of a thing can it envelop, and then how long can it go in between meals?
Yeah, so the temperature down here is 3.38 degrees Celsius, so it's really cold. And what that does, in part, is it affects the biology by affecting the physiology, the rate of reactions of enzymatic reactions. And so everything here in the deep sea, that's good, pilot. Everything goes pretty slowly. Metabolism is pretty slow. So you don't necessarily need constant source of food in order to survive. This thing, it builds the silica skeleton, and then it's a very passive collector of prey. And so when something swims into it, okay, if it's stuck, now we can move our cells and we can digest it and feed. The answer to your question about how big, I imagine, is it's got to be small enough that it can't just pull itself loose from the Velcro.
So that's an interesting comment you made about, it builds its skeleton first, and then after that it's pretty low needs.
Sure. Yep.
And so I guess for a lot of the sponges and the corals and things like that we're looking at, would you say most of their energy needs are front-loaded early on in their development when they're building that skeleton structure initially, or?
Yeah, not entirely, because they don't have all that much energy packed into them as a larva. So they have to start feeding pretty early in life.
Yeah.
And so it's not like, well, let's grow the skeleton for 20 years and then we'll start feeding.
Oh, no, right? I mean, does it need to feed more when it's younger?
I see.
Yeah.
Yeah. So many of the corals that I'm familiar with are always growing both in diameter and apically at the tips. So I think they're always getting larger. They're always adding on to their mass. So in that case, I suspect they wouldn't increase their consumption. I don't know about these sponges, but they're pretty tall.
Yeah.
There are a few corals that they seem to hit this growth limit. Let's say it's 1 meter, and then I guess they're not growing anymore. The exception to some of the things I'm saying is when it's time to reproduce. And so then you may have to either ramp up your energy consumption or delay the time at which you can produce your gametes until you have accumulated sufficient energy that you can divert the energy from the maintenance of your tissue into the production of sperm and eggs.
I think we're good. Just proceed under your own guidance.
Go ahead, sir, everyone. Yeah, it was accidental firing of 2 of them, so I noted that they were both taken at the same place. So we only have one left. We'll do that in a deep scattering layer.
And so I'm always a little dumbfounded and humbled when I go on a dive like this and you have this conception of what you expect to see. So a couple days ago we were diving on the axial volcanic ridge that forms the center of the active portion of the Mid-Atlantic Ridge, and I was expecting to see fairly young, fresh pillow basalts, really great pillow structures, some breakout structures, and it was almost completely sedimented over. And it should have been some of the youngest areas we've dove on, maybe just 10, 20,000 years. Now here we're in an area where if the one interpretation of this being a transform fault is true, this area might be 400,000 or 500,000 years old. If it's an active center, then it's probably could be just as old as that portion of the AVR. So anywhere from 20,000 to a couple 100,000 years old. And it's more or less barren of sediment on these upper portions, on these upper slopes. Very great exposure. So it just goes to show you never really know what you're going to find. And it's dependent on so many things. It's dependent on the age of the crust, the amount of primary production in the water column above you, the steepness of the slopes and the ability of that sediment to settle on you, ocean bottom currents, it's local currents, it's a range of confounding factors.
Every now and then I'm seeing one of these sea cucumbers like flipping by. There's quite a lot of them, and they're surprisingly small.
ROV, just to confirm, we've got about, what, 45 minutes of bottom time?
This kind of looks like alligator skin.
Okay. Thank you. Awesome.
Cool.
Awesome, awesome. All right. Are we undergoing a move, finishing a move, or I might want to take a sample up here somewhere if we have an opportunity. All right. You see that pillow right in front of you that's fragmented on the lower third of the screen? Yep. And there's a kind of another one of those little keystone blocks right in the middle of it. Yeah. If we could try and grab that keystone or kind of dig around in there and see if we can get a nice...
this one? Or?
No, the one that's just left of the lasers. It's kind of like a tall pentagon. Just to the left. The left laser's on it now.
I see.
No. It should be. If you kind of put a finger in there and kind of either drag it up or out, it should be completely unattached, and some of that stuff should break out and around. But give it your best go, and if it doesn't seem doable, we can always move on to another one.
So you've used both rock boxes. Do you want a bio box for this one?
Oh no, I can toss 5 rocks in the same box.
Yeah.
Yeah. I think they're distinct enough.
There's space.
Yeah, and
if you want it.
No, and that's why I like to take photos with my phone too, and that way I'll just do a quick comparison.
Sure.
Yeah.
What do you want to call this one?
Pillow Rind 2.
Okay.
But we'll wait till we get it up because it might be kind of Pillow Rind Fragment 2.
Okay.
Depending on how much of that inner surface is connected.
Ooh, look at that. Ooh.
Like a pro.
Yeah, it's sitting right down there.
Mm-hmm.
That may be the biggest one.
Yeah, so that's another, beautiful in-place sample. We've got no doubt where it came from. It's got that nice exterior surface on it. No. Yeah. It's like one of those crane machines, except you're blindfolded.
This is why I hate sticking my hand in the carburetor.
Yeah.
You never know what's down there. Someone's going to turn it on.
I have that same fear, except mine's a little bit more because I do my own home electrical.
Don't trust that electrician.
No. He learned everything off of YouTube.
It's not as big as I first thought.
I always want to imagine that manipulator hand can rotate at like 100 RPMs and just... Let me get a nice photo of it too. Yeah, that way I can just make sure I can identify.
This one's got more worms than the other one.
There you go. Thank you, thank you. And then if we could also, once it's secured, get a nice photo of that outcrop it came from. This is going starboard.
Yep. Starboard. Oh, not biobox. Starboard. Oh, starboard rock box. Thank you.
And that was what sample number?
10.
10.
9. Pardon me, 9. Arvin, does that agree with your numbering? That's number 9. Thank you. We had 2 water samples. We had to give them each a different number. There's 2 different bottles, so I give them different numbers. You have to do that? Yeah. That's what we've been doing for, like when we have 2 things on one that have 2 different labels. We just like, same thing, take a photo, change the label, same thing. Same, that would be the same as you. Duplicate the clipping. Yep, yeah. In fact, Caitlin, in the video, you can see both of them close at the same time, so. Yeah. I don't know how they're going to treat it.
Some nice glamour shots of a broken rock with a big hole in the middle of it. A testament to the skill of the front row, all y'all.
What are you seeing here, Ashton, when you look in the hole? You see
well, it's a good example.
Layers, like you told me.
Yeah, and it's a good example of, you know, the the types of outcrops that are nice to sample. You can imagine that if this pillow didn't have a breakout somewhere else where it evacuated all of that lava, it would have just been a solid giant rock, and we wouldn't have been able to sample it. And so the fact that it's this exterior shell where the magma has been evacuated out makes it really, really nice to sample. Yeah, you saw how nicely that came out.
Yep.
And if we could get one with the lasers too. Thank you, thank you. And that you know, the other thing that I always love is that beautiful texture on the outside, so that crackliness. We see that's very indicative of pillow basalts, but we also get that in more silicic systems. So volcanoes on land that have a higher silica content, going back to that silica conversation we were having. Basalt 52 or 53% or less silica. When we start talking about more silicic systems of lavas that are more rich in silica, and we start getting into the end member of those, what we call rhyolites. Those are really silica rich. And the more silica that there is in the lava, the higher the viscosity, right? So the tougher it is.
More syrupy.
Yeah, and so we get to this point where the lava doesn't flow really easily like the basalt that we're used to, and it actually fragments. So those more silicic systems are much more explosive. They're able to resist that magmatostatic pressure until it fragments explosively. Now that texture we had on the outside of that pillow basalt is also texture we get on some of those silicic systems. We call it bread crust, because it looks like the surface of a freshly baked loaf of bread that's kind of crackled on the exterior. I think geologists like to just create analogies to food.
Now you're making me miss my fresh baked bread.
Yeah. You know, you could probably create a pretty awesome sourdough starter from maybe something that you find at the bottom of the ocean.
Scrape off the rock.
Yeah.
It'd be unique. Yeah, I don't want to have a situation like we did yesterday where most of the last 35 minutes was in blue water when we could have just stayed where we were.
Oh, there's going to be something so awesome at the top. I heard that it was this unique sponge and coral garden.
Yeah.
And you know the most amazing thing about it? Unseen ever before.
I heard that it's a throne on something sitting up there just throwing down pillows.
Oh, there you go. Yeah, no.
Yep, you said it right.
100% right, yeah. I'm kind of just curious to get to the ridge crest at the top. Yeah.
Oh, Sako saw or Tina saw Tinafor. I missed that.
There's another example on the bottom left of the screen where you can see those striations in the pillow basalt. So you can actually tell which direction that pillow flow was moving and being extruded out by the direction of the striations.
Oh, I see. Yep. Pilot, are you waiting right now for... Yeah, can you zoom in then on the stick on the left of center? Thank you. And then after that, we'll zoom in on the sediment right in front of it. Thanks.
You bring a deep-sea biologist to the Mid-Atlantic Ridge, and all he does is look at sticks.
Look at stuff on the ridge. Yeah, that's going to be a peninsula, which is new for the day. But on the rock, I think... At first I thought this was another sponge, but now I think it's a bamboo coral. Oh, that's interesting. I think it's a bamboo coral skeleton, but they're not polyps. They're all barnacles at the top, and then there are several ophiuroids going down. That's enough, Pilot. I'd actually like to look below the rock now on the sediment, and you'll see there's a soft feather-like thing in the sediment. There it is. Yeah, so this is a classic sea pen, probably the one for which sea pens were named, the Penatulaceae. I think this is the genus Penatula. So you can see it's very much like a feather. It's got that central axis with these sort of fleshy lobes sticking out, and then sticks into the sediment with the fleshy peduncle. So one thing I haven't yet said during this expedition that's another cool thing about our understanding of the biology of the sea pens is that that main structure you're seeing with the whole axis going up and those fleshy lobes coming up, that's one giant polyp. We call it the primary polyp. And it's the primary polyp that has a straight axial rod inside of it. And then all of the feeding polyps are arising essentially from its series of arms. So that's kind of cool. Nice. Pashner agrees that that is Penatula. I can also see some lower down, some of the probably eggs. There's clusters of white spots where those fleshy lobes are leaving that central axis. And those would be gametes that are being formed on the basis of what we call mesenteries. These are folded sheets of tissue on the inside that subdivide the digestive space.
Now, it's interesting to me that the arms clearly start small, get big in the middle of the body, and then get small again.
Yep.
But it's not clear to me why.
Right. Or it's not clear to me, maybe because that part is actually older, the tip is younger, and is putting out new arms.
That makes sense, but then like almost if it was,
why isn't it like?
Yeah, the fact that it's bimodal almost.
Yeah, I'm not sure I can answer that.
Yeah. And so those are those beautiful striations I was talking about when these pillow basalts are forming, and we kind of have one pillow head being erupted out of the next, and it's being stretched out along that fracture surface. So if you looked at this and you wanted to know which way this pillow was actually moving, it's along those direction of striations.
So here's a question for you that's going to sound flippant, but it's not. It's meant for you to explain. If the rim is so important, why didn't we just settle down on the rim?
Oh, the rim is not important, but, we had kind of this conversation the other day in terms of, the idea of planning a dive for biology versus geology. And, one of the things that I really appreciate having you here for is giving me that perspective of what a biological dive could look like. There's so much biological diversity and abundance in a small area. But geologically, one of the things that's really important is situational awareness. And so, you can imagine if we're looking at the macro structure of this volcano, focusing on, a 50-meter area is really difficult to get an idea of the entire setting. It's almost like being given a satellite image of this ship and then being put in a room in this ship and being told you can't leave the room and trying to figure out what ship you're in, right? You need to get out and wander around. And so seeing this entire edifice from the base to the very top gives us an idea. If we got to here and it was nothing but rubble, and we got to the top and we saw nothing but rubble, that's a good idea that it's a faulted surface. Right. The fact that we're seeing all these pillow basalts is really cool. The fact that if we get to the top and maybe we see a transition of pillows going on both ends, then maybe that means that there was an eruptive vent near that rim.
I could also see that if we came down onto the top and it was, thickly sedimented, and all we're seeing is, oh, look, it's just a flat abyssal plain.
Yeah.
Abyssal, in quotes, air quotes. That wouldn't have told you much either.
And then, of course, one of the things that's important is getting that idea, even if we got to the top and we saw nothing but heavily sedimented with no exposure of pillow basalts, that forms a piece of the geological puzzle after we do, post-cruise analyses. If we get those rocks back and we date them and we go, hey, wait a minute, these rocks are only 5,000 years old. Why is that entire area so heavily sedimented? What does that say about the primary production above it? It must have been really heavy in order to sediment this area in that short amount of time, especially when we go back to that generalization of 10 meters of calcareous sediment per million years. Similarly, if we go to the top and it's not very sedimented at all, which I don't think it will be, it'll be sedimented to some extent, and those rocks date to 500,000 years old, then we know that we're in an area of active currents because those sediments have to be swept off here.
Yes, science would. Thank you. So we're looking at another, I'm pretty sure this is glass sponge here, really big rim on the top of this tube/vase. And I guess it's still alive, It's got some dirty bits on there, some discolored bits. You can really see the lattice work of the silica skeleton under there. But there's enough white in there that's telling me that there's still live tissue.
Beneath all the dirty bits.
Some mucus, there's all this stuff that's floating by in the water, right?
Yeah.
And it gets hung up on the spicules. And the mucus that's being produced by various organisms. There's a cool little snail. I can see its proboscis sticking out. Not the proboscis, excuse me. The what did I call that mantle tube? Siphon. Can we tilt back up just a little bit? There's a small snail there, right there. Thank you. Yep, I understand. You can see there's a transparent tube extending from the top moving to the left. A little bit hard to see, but it's there. Mm-hmm. And this tells me that this is a fairly evolutionarily advanced snail. It's a predator, and that tube draws water into this mantle cavity space where the gill is housed. And just before the gill, there's a sensory structure that is basically like our nose, and so it can sniff out chemicals in the water. So the predatory forms have modified that mantle cavity out into the siphon, and it's very muscular and going to move around. So it's basically, sniffing its environment and deciding what direction it wants to go. That's great, Pilot. As we move over the sponge, if we could just try to look down on the top of it, I want to see if it's open or closed. Thank you. Alan Collins agrees this is definitely an alive sponge. Oh, okay. It's open. I just meant, did it have a hollow space, or was it closed up? So that's good. We can look around here, see what else we can see. There's another one of the benthochodon jellies. We've seen several of those today, and we even managed to collect one. Yeah, we don't need to go after that. We've got really good video from earlier in the day. We have a collection. So I'd rather use the limited time left to see what else we haven't imaged yet. Looks like a sort of a globe sponge that's tumbled off of a rock there. Yep, looks like a geodia, a sponge. Here's another one of your pillows with a good example of the smaller pillow coming out of the larger pillow.
Good eye.
Thank you.
You're going to be recognizing pillow breakouts like
I am.
Like no one. I'm going to be recognizing octocorals.
This has been fantastic. I've learned a lot today, and I realize I've misinterpreted a lot about how I view and think about these overall structures, these pillow mounds. So I'm seeing a couple of whips ahead. Maybe we can go towards those once you have the tether. Right of center. No problem. In Paris, there's this really neat sort of art installation of kind of like a giant sea serpent that comes out of a building and into the sidewalk and out of another side of a sidewalk and then back into the side of the building. And water runs through it periodically. There's big patches of it that have like, sort of a plastic window. Coolest thing. I mean, it's huge.
Yeah.
but it reminds me of some of these pillows, the way they're disappearing into the sediments and then coming back out in other places.
Yeah, and it's one of the reasons, some people, don't really like the idea or the terminology, the scientific jargon that's entered of pillow, because when these were first kind of described, they were thought to be much more individual features and not necessarily these large, long, lobate structures that we see. And so that's why, I tend to use kind of pillow lobe or elongate pillow, because they can form these kind of individual smaller features, but only when there's a real change in the bathymetry, when they can erupt from a vent and then fall off some type of precipice and become detached. Now, what's interesting to me is, we've probably done, 200 meters in elevation change since we started this dive, something around there. And I think it was a little bit more biologically rich at the bottom.
Yeah. Pardon me. All right, that's better. It was steeper down there as well.
Yeah.
I mean, maybe not right when we landed, but it was steep, and I don't know how the currents are interacting with the slope down there. And clearly this slope is much more gentle. Maybe that has something to do with it. But I agree. It was almost like somewhere in the, not right at the beginning, but first third that we saw our maximum.
Now that looks like a octocoral.
Yep, that's very good. It was produced. Oh, you see a fish? There's some of your pillow toes.
Yeah.
Oh, there's the fish. Thank you. I didn't see that fish. I was going to say that is mostly dead, but actually I take it back. It's mostly alive. This looks like it might be that grenadier that Ken Sulak wrote about earlier that he said he couldn't quite place. And he gave us a couple of IDs. One was a possible genus Coryphaenoides. And the other, I don't remember now, it's going to take too long to try to find it, but was a genus that I'd never heard of before. So yeah, let's see if we can get good image. Oh, that's perfect focus. Beautiful. You can see all the pits on the other side of the head. Very nice. Thank you for that. Oh, he just opened his mouth there. I saw him yawn. Let's, if you could, go back to the coral. I'm just concerned about the amount of time left. Thank you. Huh. There's a six-armed sea star there on the side of that rock.
The little one.
Right here.
Yeah.
Sure. No, not there. Not there. It's in the distance at the top. That's Ophium museum. That's something we know really well. But yeah, this is different. Yeah, that's really good. Good view. So that's definitely the first one of those we've seen today, maybe on the expedition. Everybody kind of thinks of sea stars as having 5 legs. So that's not necessarily always the case, and the sun stars have lots of them. All right, thank you. So let's get that close-up on that coral, please. The last couple. Okay, let's see if this is a living bamboo coral or if it's been taken over by something else. And I can see that it is a living bamboo coral. Yeah, so what's your situation? You think you can clip the top of this? Do you think you have enough time, or is the ship move already in place that you can't? So if that's the case, give me one thing. If you can get a tighter zoom just before we... All right, that's perfect. You can see the sclerites there. We got the focus. Count to 5. Beautiful. And now just have a look down at the base. And I want to see there's a branch coming off. I just need to see where the node, because I'm certainly not going to ask you to collect it down there. Here you can see that brittle star has probably scraped off the tissue, and all the polyps below it are kind of sad. And it all but one. There we go. There's a node. There's a branch. Yep. So I can see it's at the node, but if we can just zoom in on that branch point. See a little solitary hydroid hanging down from that little branch. And there you can see it's kind of a golden in color. And this is kind of common for when these bamboo corals are relatively young. Just there, yeah. There we go. Perfect, Brian. Yeah, nice. All right. Excuse me. That's a good view. So whatever's easiest for you to snip off the top, 6 or 7 inches. That's good for me. So we've been seeing this really frequently today, ever since we got down on the bottom. It's kind of a sparse brancher. And so this is going to be a collection that allows us to say exactly what is this thing that's surviving here greater than 3,000 meters.
But those are lower branches that have died off on the base?
Yeah. The one coming towards it, 2 coming towards us still have polyps, but the 2 going over there look like they've been entirely stripped. And that could be for a host of reasons. There are several asteroid sea stars that will feed on this. There are aplacophorine mollusks that will feed on it. Those are the only 2 things that I have seen at this depth that I know for certain could do that. If we were on like that shallower dive yesterday, the Oreo fish apparently nips at some of these polyps. I've never actually seen them nipping at a bamboo coral, but it is possible. But the reason we want to see the branch is because you see how long that is. It's unreasonable to take a clipping and try to stuff it all in the box. But we can take a small piece, know that it's a nodal brancher. We've got really good imagery. And so we'll have enough for morphology. We'll have enough for genetics. We'll use the imagery to say how it's branching. That's all really good.
Now, this might be a naive question, but if it was nutrient deprived, would you expect it to die off as single branches, or like would it shed branches, or would it just kind of slowly spot die throughout the organism?
That is such a good question. I have no data for that from deep sea coral. I wonder if somebody has done that with shallow water coral. I don't actually know. I probably should know, but I don't.
That's okay. I don't hold it against you.
Thank you. Yeah. It's much appreciated. So one thing I know is there are other species, Metallogorgia is one that we saw yesterday, that definitely shed branches. However, they always shed the branches, and I think it's independent of the nutritional state. It's interesting to ask, well, why are you doing that? You know, why
is it a response?
Why don't you have more polyps that all of them are feeding? You have more opportunity. But that's the way they grow. That looks pretty good, yeah. And that will clip really easily. There we go. What side are you going to go for, pilot?
cycle, that will conclude the dive.
Port inner is open, correct. There it goes. Thank you so much. We've seen so much of that today. This is so deep that it's unusual to find bamboo corals, branched this deep and in this abundance. So that was a really valuable collection. So I thank both the pilots and my geology co-lead.
No thanking me necessary.
Oh, yeah.
I heard there were some really cool features about a kilometer away.
For sure. Copy that, Nav. Thank you.
Thank you very much, you guys.
And pilot, just for awareness, we are not taking a Niskin here on the bottom. We've used 4, but we will take one at the deep scattering layer, and we'll get back to you on where that'll be, but it won't be up till about 500 meters. Thank you. So, ladies and gentlemen on shore, this ends the bottom part of the dive today. If you enjoy the water column, there's going to be a good hour and 50 minutes or so climbing through the 3.15 kilometers of water that we're under right now. It's been a pretty interesting dive. You want to briefly summarize?
Look at that big, giant, beautiful pillow.
Yeah, you knew that was going to come.
Yeah.
Sure.
So we are on the Kurchatov Fracture Zone on the Mid-Atlantic Ridge, and this is a fracture zone that segments the Mid-Atlantic Ridge, and it moves it about 20 kilometers eastward if you were looking from the north. And so we started our dive at about 3340 meters below sea level, and we've come up about 200 meters, starting at the base of this deep pillow volcano, and then transiting upwards. We came up to the top of a small little hill within the first 40 meters of elevation, and then we, as we were coming up, we started to see some basaltic talus that had fallen from downslope, lots of calcareous sediment, and then as we came up that slope, we started to see lots of these more fresh and in-place pillow basalts, and along the way, quite a diversity of biologic organisms.
Yeah, I was actually surprised by how many we saw, and more than that, the size of them. When we talked about what was the expectations for the dive when we were getting to the bottom, I said, well, we're certainly going to see a lower abundance because we're farther from the source of the food, which is the upper sunlit waters. And usually organisms at this depth tend to be quite small, again, because they're food limited. So seeing all these large branching bamboo corals and whips and sponges was frankly a bit of a surprise to me. A lot of them were not in great condition. They seemed to be a lot of exposed dead skeleton, but some parts of the skeleton hanging on, although there were lots of fouling organisms living on them. Hydroids, we didn't see any zoanthids, but especially lots of hydroids. We saw a number of brittle stars and so on. So every dive is a surprise. Every dive gives us another piece of the puzzle, and we'll try to put it all together.
Did we see those carnivorous sponges anywhere else?
We saw at least 4, maybe 5 of them during the day. If you mean, have we seen them anywhere else during the expedition?
Yeah, on previous dives of this expedition.
We saw 2 yesterday that we actually collected, but that were maybe 5 to 6 centimeters in length.
Oh, okay.
I've never seen anything
like that.
Well, I shouldn't say never seen anything. Yeah. I've never seen the besta pluma, these stick-like ones that tall. That was amazing.
Yeah.
So thank you, everybody, for tuning in. Thanks to all the scientists on shore who provided us information. And for those of you who will be participating in our dive planning call for tomorrow, we need just a couple of minutes to get set up in here, get the mapping lead in, get our expedition coordinator involved, and for Ashton and I to take a bio break. See you soon.
A bio break for Scott, a geo break for Ashton.
Hey.
Hey.
This is Chris Ma. Hello?
Hey, Chris, how's it going?
Good. I just saw that 6-rayed sea star that you guys passed or just panned up from.
Yeah, go for it. We're off the bottom, but by all means, tell us about it.
Oh, you're done already?
Yeah, we're in the water column, but that's okay. We can use the audio, so go for it.
So it's too late to collect?
Yeah, unfortunately, we just finished our dive 2 minutes ago. Yeah, that was kind of the last hurrah.
Okay, well, it's pedicellastrid. They're probably in the genus Hydrosterias. Those are not very common. I mean, they're known in some collections, but I think there's one of two possibilities as to which one it might be, but having one for DNA would be great, but that's fine. I mean, they come up occasionally. They're not that rare, but it would have been nice to have collected one.
Do they always have those 6 arms?
It being new or what?
Do they always have 6 arms?
Yes, that particular species.
Okay.
In fact, that's the basis of the name.
Okay.
Hydrosterias. Well, there's one of 2, but that one is sex something. The Latin name translates to 6 arm.
Yep.
Six like Sexophilus or something like that. So I'd have to look it up. But like I said, they're at the base of the general forcipulate tree, and forcipulates are sea stars like the Intershore Asterias or Pisaster, and so they're kind of very early offshoots in that branch of life for sea stars, and as such, every time we get to see them, there's kind of a living fossil dynamic to them, and we've seen them before in different places, and sometimes I've seen animals like that, like in Antarctica and on the California coast near vent habitats. So, what are they doing down there? I don't know. Maybe they're feeding the microbial films or whatnot. But I've seen a lot of things like this, sort of in these kind of basaltic bottoms and volcanic areas. So it would have been interesting to.
Well, very cool. I'll make sure that I'll write a Post-it note that we'll put down not just for us but also for the next expedition. That if we see any 6-star sea stars,
6-armed,
6-armed
or 6-rayed,
yeah,
cool.
Okay.
Axial Valley specialist.
Yeah.
Cool, Chris. Well, I'm glad at least that we got a close-up of it.
Okay. You guys are literally still collecting that bamboo coral on what I'm watching, so clearly...
You are way behind.
There's clearly a lag.
We are now 60 meters off the seafloor.
Okay, well... all right. Well, I'm running around. So thank you very much. I appreciate the time.
All right.
Bye-bye.
See ya.